Welcome, Vanakkam. Once again, very good evening, all my dear friends. Welcome back again to your Unacademy NEET English channel. So today, here is your Baba HSP. My dear friends, all future doctors and engineers, just do let me know in the chat section. Can you hear me? Can you see me? I want to see. This is your Baba HSP. I want to see in the chat section that if I'm perfectly audible as well as visible, my dear friends, do let me know in the chat section. Show me the green signal. I want to see green signal or the orange. I want to see, my dear friends, chat section full of with the green signal. If you can hear me, see me. Yes, and if the Josh is high, I want to see fire in the chat section. So today I will let you know the whole isomerism. But for that, I want to see the chat section full of with the fire. Fire. I want to see fire, kids. Your Baba is over here. And you know that this isomerism chapter holds a hell lot of weightage. Optical isomerism, you can't do SN1, SN2 reaction, the class 12th alkyl halide, aryl halide without the knowledge of optical isomerism, conformational isomerism. Everywhere in every chapter it is being required. Structural isomerism is the base of your chemistry. So how are you, my kids? Everyone, your Baba is over here. You know that all the Avengers, NEET Endgame students, and all those students who are being preparing. Yes, this is your Unacademy channel, and all the teachers are super awesome. And let me tell you, my dear students, one thing. Before moving ahead, see, just see. Can you see? This is the whole frame and India's best teacher. See, Pankri ma'am, Ambika ma'am. You know, Pankri ma'am, Ambika ma'am, very well, kids. The best teachers. Wasim sir, Saliva, the king, bro, chemistry. You know, your Baba HSP, very simple teacher, but hardworking. Our Kailas, physics legend, our Yavasa, lovely Yavasa, best faculty of physics, my dear friends, 2 chemistry teacher, 2 bio teacher, 2 physics teacher, India's best teacher, and you can convey this message to everyone, those who are preparing for, yes, their future, whether they are going to appear for NEET 2024, or even if they are preparing for NEET 2025, you are just getting for 4,499 rupees. See, kids, the whole syllabus, the chance to complete your whole syllabus, and what's you will call it just 4,499 rupees. You will call it, it's a crash course, but it is special crash course. You will study each and everything in depth. It's not just the formality, which you have seen everywhere, everyone is doing. But kids, you can ask NEET Endgame students, crash course students, that what the material, what the quantity, what the quality they are getting, you will never get anywhere. The quality that is error-free. Kids, do let me know if you are hearing and if you are in NEET Endgame crash course. Do let all these students, the India should know that what quality you are getting, what quality from each and every teacher you're getting in your batch. This is the best batch, and I would like to say, yes, your brother, sister, your colleagues, your classmates, whatever, wherever the students, you know that sharing is caring. If you're sharing this thing to each and everyone, you are doing something good for you, kids, because God, Almighty God is there to see that if you're helping others, God is there to help you. Now, Let me see the chat section. Are you agreed? Everyone, Saucy is there. Saucy is there. Guna is there. Baba, yeah, Guna, everyone I can see, my dear friends. Everyone I can see. So, if you are new to this channel, kids, this is your Baba HSP. Just a short brief. Baba HSP is teaching for the last 20. I have been teaching for the last 24 plus years. Produce number of ranks 1, 2, 3, top 10 ranks along with the mass selection. Whether you talk about JEE or you talk about NEET examination, AIMS examination, you can say any examination, number of ranks. But I would like to say not only me, because of me, my dear friends, it's a triangle. Your parents, your teacher, and you, your hard work. If you're doing hard work, your success is waiting for you. So see, Baba has done MSc. I was a topper in MSc in 1999. I'm 51 years old. See the energy. This energy I'm getting from you people only, kids. Your hard work shows that you are going to get selected. That hard work is making me this much energetic that Baba is looking very young. My dear friends, MSc, after doing MSc GATE JRF, I did my MTech in 2004. And when I was doing MTech, I was teaching. I was taking classes. I produced number of rank, 14th rank in IIT JEE, 17th rank. All those kids because of their hard work. So, now is everyone ready? Yes. If everyone is ready, if you're new to this channel, subscribe this channel. This is the best channel, kids. And I want to see likes, kids. I want to see likes. Your likes matters a lot, because this like is your attendance. If everyone is ready, I want to see your likes. You know the drill. Hit the like button, everyone. Smash the like button, everyone. Now Baba is going to start. Now I will start with, from the very beginning. See, kids, if you're ready for the isomerism, structural isomerism, I want to see one thing in the chat section, kids. What do you want? What do you want? You want to study from the scratch? If yes, if you want to study from the scratch up to the first rank, show me thumbs up in the chat section along with fire, because I cannot see the whatever the things are written. I want to see fire in the chat section, thumbs up and the fire if you want to study from the scratch and you want to go up to the first rank. Yeah, Baba want to see, because I can see your thumbs up, I can see the fire in the chat section, because the messages are too far away. I cannot read them properly. For that, I have to come nearest to the screen, and then only I can see. My dear friends, oh, I can see everyone's, yes, everyone's thumbs up. I can see the fire. I'm going to start. Yes, kids, let me divide isomerism. Kids, number of times you are having too much knowledge, but you are doing, or you are getting negative marks. Let me tell you, this is Baba HSP. Suppose this is one molecule. Its weight is 70 kg. In front of you, this is one molecule. I am being molecule and my weight is 70 kg. Let's do the classification, because the classification means not to see what scientist has given the classification. You should be the scientist. You should know how to classify. Now this is one molecule. Now another day, if you see HSP molecule, in place of hand there is leg, and in place of right leg there is right hand. What you will say? Oh my God, what happened to Baba HSP? In place of hand he is having leg, and in place of leg he is having hand. That means his structure is changed. Another HSP whose in place of right hand there is leg, and in place of leg there is right hand. Same HSP, same weight, molecular weight, but his structure is changed. Whenever the structure is changed, always remember that we will say structural isomerism. Never see or go for geometrical isomerism or optical isomerism, because if structure is same, then only you have to go for stereoisomerism. The structure is changed, never go for optical and geometrical isomerism. My dear students, are you getting my point? So first classification is isomerism. Now for isomerism, molecular formula must remain same. If you want to see isomerism, same molecular formula. If the molecular formula is not same, then don't go for isomerism. Same molecular formula. Now, if the molecular formula is same, then just see whether their structure is same or not. So we will see structural isomerism. Structural isomerism. This is also known as constitutional isomerism. Constitutional isomerism. And if you're not able to understand what is constitutional isomerism, what is structural isomerism, you can think about one thing. Their IUPAC name must be different. IUPAC name must be different. Its IUPAC will be different. Different IUPAC. Compounds with different IUPAC. IUPAC name must be different. And you can divide it into following types. I will let you know what is the meaning of that. Let me divide it. 1, 2, 3, 4, 5, 6. Just see what is that. Write your famous position. Write your famous position. Write your famous ring chain isomerism, tautomerism, functional isomerism, metamerism, and yes, after this, chain isomerism, and P for position isomerism. This is the sequence. 1, 2, 3, 4, 5, 6. Why I have written like this? R for ring chain isomerism. My dear students, if compound is showing two different compounds, if they are showing more than two types of or more than one type of structural isomerism, then what should be the priority order? Kids, am I audible? I'm just thinking about, am I properly audible? Yes. So this is the priority order. I would like to say this is the priority order. I will tell you the full form of all these things. Ring chain isomerism, tautomerism, functional isomerism, metamerism, chain isomerism, position isomerism. If compound is showing more than one type of structural isomerism, then this is the priority order. If they are giving in the option both, then both is being correct. But if you are supposed to go for only one thing, then yes, this is the priority order. If the priority order is clear to each and everyone, show me the thumbs up, kids. In between me and you, this is only the connectivity to see in the chat section. No need to say again and again. If the thing is clear to all of you, show me some signal. Any signal which is you are having in your laptop, in your mobile, you can show me that. If you're not having any emoji or the signal, you can write it down. Yes, you got it. Yes, you got it. So the code is write your famous position. What is the trick? Trick is brainy Baba's trick. Brainy Baba's trick. Write your famous position. So after some days, you are going to get the first rank. That should be your position. Write your famous position. Wow, my lovely students. The chat section I can see full of colored. Now write your famous position. Now my dear friend, if structural isomerism is not there, then only go for stereoisomerism. The stereoisomerism. This is also known as, my dear friends, stereoisomerism is also known as three-dimensional. 3D. This was 2D. Now, my dear students, before moving towards that, I want to take one position. You have to make a promise that gets, structural isomerism, Tautomerism, geometrical isomerism, optical isomerism, conformational isomerism. Whenever, if I talk about such type of isomerism, it will require near about 9 to 10 hours. I will give you break also, but you have to make promise that you will stay up to the last, because Baba is ready. Baba is ready for that. Are you ready? If yes, show me the hearts or the thumbs up or any symbol that yes, you are ready. Those who are ready, then only I can decide that I have to tell you each and every point. Even if 2 students are ready for that, I will tell you up to the last, because that promise only you can make. It's if you're hardworking, success is waiting for you, my dear friends. Yeah, that's fantastic. I can see in the chat section. That's really fantastic. Really fantastic. Now, if I divide stereoisomerism, then this stereoisomerism is of 2 types. 2 types. One type and second type. Now, my dear friend, see, if I say one molecule Baba HSP, molecular weight 70, hand is at this position, hands are at this position. Right now he is teaching and entry is like this. See, entry is like this. Your teacher Baba HSP, he is always remaining like this. He is always remaining like this. Can you see? Baba HSP, molecular weight 70, he is always remaining like this. But if you go to your college and another Baba HSP is coming, see. Hey, entry of Baba HSP. This Baba HSP is always remaining like this. What type of talks will be there? Talk of the town. Oh. This Baba HSP's hands are originating from here only. Both the hands are originated from here. Structure is okay. But see, one Baba HSP is like this, another Baba HSP is like this. Hands are originating from here. So they are not a structural isomer, because these 2 Baba HSP structure is same. Then what is the difference? Difference is in the space orientation. This Baba HSP's hands are remaining like this, and that Baba HSP's hands are remaining like that. So their space orientation is different. So people call this form as cis. If they have given name Alia or Pandu, I must be teaching this form Pandu and that form Champa. But scientist has given this name cis, 2 same atoms or groups remaining same side cis and their opposite side trans. So cis and trans, they are not interconvertible into each other at room temperature. So this is further divided into 2 parts. One part is configurational isomerism. Configurational. Another is conformational. Now, how to say conformational? First, let me tell you configurational. Configurational isomerism means one form of isomer can't convert into another at room temperature. If you supply heat, if you provide temperature, then they can be converted. Now see, now let me tell you conformational isomerism. See, this molecule has come in the entry. At the entry time, Baba HSP like this. After some time, Baba HSP like this. Now he started doing exercise. He started dancing like this. And Baba HSP is doing number of different movements. Now this form is continuously converted into this form. That means the single bond is having free rotation at room temperature. When molecule is free to move, doing dance, doing Zumba, doing exercise, free rotation. Cis form is continuously converting into trans and like this. So this is not GI. This is not configurational isomerism. We call it conformational isomerism. That means the bond is free to move and it is doing infinite conformers. It is in infinite forms. There should be some very, very stable form. There should be some less stable form. Are you getting my point? So conformational isomers are those which are free to rotate and the energy they are getting from the room temperature, right? So let me divide where the pen has gone. Yeah, it's over here. Now kids, one form can convert into infinite forms, at room temperature, So this is the whole division. I have divided into different parts. Now you should know and you should remember this thing, whatever I am telling you kids, or whatever the things I've told you. Now do let me know, is this thing clear to all of you? Is this division clear to all of you? The classification which is given by me is clear to each and everyone. Keep on showing thumbs up or the hearts or the whatever the thing, so that no need to tell again and again, no need to tell you again and again about these things. Yeah, kids, your Baba HSP wants a connectivity between me and you, that my kids are able to understand or not. If the express train is moving and without allowing you to sit in that train, what's the benefit? Yeah, 100%. That's really awesome. Some people are writing 100%. That means a lot, that you are able to understand. That's really fantastic. Now kids, so first I will tell you this thing and then I will let you know that thing. Okay, so I'm going to start from here, structural isomerism. So let's begin structural isomerism, kids. Okay, so heading is structural isomerism. What structural isomerism? Another name. What is another name for a structural isomerism? Everyone write down in the chat section another name for structural isomerism. I want to see what is the another name for structural isomerism. Write down in the chat section, everyone, another name for structural isomerism. Kids, everyone, if you want to understand, you have to write down. We have that much of energy. Another name, constitutional isomerism, because examiner will ask this question. This is also known as constitutional isomerism. Constitutional. What is the meaning of this constitutional? That meaning is linkage is being different. Linkage is different. So in this category, first form is chain isomerism. Chain isomerism. This is known as CI. Remember that molecular formula same, but different parent chain, but different parent chain. You know IUPAC? So parent chain is different. Molecular formula remaining same, but different parent chain. Let me give you example. If I say C4H10, this will exist in two forms. One form is being CH3 CH2, CH2, CH3. Another form is being CH3, CH, CH3, CH3. If I talk about their numbering will be 1, 2, 1 rana monu nale, 1 rana monu only. 1, 2, 3, 4. The parent chain is of 4 carbon atoms. Here the parent chain is just of 3 carbon atoms. So parent chain is different, but the molecular formula is remaining same. So they are structural isomers. Clear to all of you? Is it clear? Once again, if the things are clear. Okay, now this is the smallest alkane which shows parent chain isomerism. Now, if this is clear, I'm going to ask one question. Are you ready for the question? This question can be asked in JEE. This question can be asked in your NEET examination. So if you're ready, show me the fire. If you're ready, show me the fire, because once I have told you the chain isomerism, now the time is for question. If you're ready for the question, do let me know. The question is find out minimum number of carbon atoms required to show chain isomerism, in first, second, third. In first position there is alkane, second position there is alkene, third position there is alkyne. Already the first one I have told you. It was 3. Answer 3. Now it's your turn. Alkene and alkyne. Do let me know what should be the answer for alkene and alkyne. Baba is waiting for your answer, kids. Alkene and alkyne. 4, 4, 5. Kids are writing 4, 4, 5. Let me see. 4, 4, 5. One kid has written 4, 4, 5. 4, 5. Okay, let's see whose answer is being correct. Let me check it out. See, if I take CH2 double bond CH2 CH3, and if I say CH2 double bond CH3 CH3. Wow. Congratulations those who have given the answer. That's 1, 2, 3, 4. 1, 2, 3. The functional group is remaining same. The parent chain got changed. Congratulations. 4 is the correct answer for this. 4. Now let's see for alkyne. If we want to draw with the 4, is it possible? Let me check it out. CH2 CH3. Now I want to change the parent chain. CH triple bond C CH3 and CH3. Oh, I have done it. Anything wrong? In this, anything wrong? Kids, this structure is absolutely found to be wrong. Why? Why this structure is wrong? What's the problem with this structure? Everyone, write down in the chat section. What's the problem over here? I want to see. What's the problem, kids? Why cannot we make the alkyne with 4 carbon atoms? Then the answer is valency of this carbon 5-valent, pentavalent has become, and that's why it is wrong. We cannot make. Am I right, kids? So what we are supposed to do, CH triple bond C, CH2 and CH2, 1, 2, 3, 4, 5. Now CH triple bond C, CH3, CH3. So this is being 5. This question has been asked number of times. My dear students, if this is clear to each and everyone, once again, don't wait. Show me some fire in the chat section. I want to see. Kids, don't wait. Put some fire in the chat section, or hearts, either hearts or some fire in the chat section. Yes, that's really awesome. Now, after this chain isomerism, let's move towards ring chain isomerism. 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 Ring chain isomerism says compounds having same molecular formula, but one form cyclic and another form acyclic. What do you mean by this? One form cyclic, another form acyclic. Remember this point to be noted, my lord. Everyone, note this point. One form cyclic, another form must be acyclic. Now let me give you one example of it. Just see to it. If I draw CH2 double bond CH2 CH3, its molecular formula is C4H8. Now if I draw another form, B form, like this, just check it out. What is the molecular formula of this compound? You will see CH2 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 CH2. So see, its formula is C4H8. This is also C4H8. This is being acyclic form and this is being cyclic form. So what's the relation in between these two? Definitely they are ring chain isomer. But remember one point. Mark my words. Categorically, I'm telling you this thing. Remember it, that their functional group also got changed. This was unsaturated olefinic and this is saturated. So functional isomerism also. So I would like to say A and B are ring chain isomers as well as functional isomers. Functional isomers, my dear friends. When they are both, in between these two, the relationship is of RCI as well as functional isomerism. Then why I'm saying they are RCI? Because if the examiner is asking just to mark only one correct, then you remember that, write your famous position. The priority order was like this. So here is ring chain isomerism and here is functional isomerism. So ring chain isomerism will get preference. Kids, if this much is clear to all of you, I want to see some fire, some yes, kids. Yeah, for alkene it was 4, alkyne it was 5. Yes, 4, 4, 5 was the correct answer. Now, kids, this is your duty. Humble request. Baba is doing humble request that once the concept is clear, concept clarity is there, always show me some hearts or the fire or the thumbs up, whatever. Now, after this ring chain isomerism, Baba is moving towards position isomerism. Position isomerism. This is very, very important one and dangerous one. So take care of it. Position isomerism is very, very important. It is dangerous also. If you're not taking care, then it will become dangerous. People call it PI. Let me write down its definition first. Compounds with same molecular formula same functional group same parent chain. My dear students, these many things are being same. These many things are same, my dear students. Just see, this is same, this is same, and this is also same. All three things are same. That is the condition, and that's why people are doing mistake. These three things should remain same. Then what should be the difference? Where should be the difference? The different what? Different what? But having different position, different position. What different position of what? Different position of alkyl group or multiple bond or functional group. Sir, what you have written? Functional group? Why, sir? There you have written functional group should remain same. It's what I'm saying. The group should remain same. Functional group should remain same, but its position should get changed. Point to be noted, my lord. What I'm writing, position of functional group should get changed. Functional group should not get changed. Yes, are you getting my point? Kids, are you getting my point? Everyone, now let me show you. First of all, see, then only I'm going to tell you. The definition is clear to all of you. If yes, once again, you know the drill. Show me some fire or the hearts or the thumbs up. Kids, I'm not going to teach. Baba is not going to teach in this way. You kids, again and again, I have to say, show me some fire, show me some fire. What is this? Yeah, now this is the way I can see that it is clear. Teacher is teaching. If it is not clear to the students, what's the benefit of teaching? Yeah, now it's fantastic. Now let me give you example. See, suppose I'm having compound like CH3, CH2, 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 CH3. What is the molecular formula of this compound? The molecular formula is C5H12. Now, if I write down another compound like this, CH3, CH, CH3, CH2, CH3, what do you say? Are they position isomers? Write down yes or no. They are position isomers. True or false? True or false? Yes or no? They are position isomers. False or true? True or false? See, they are not position isomers. Here the parent chain 1, 2, 3, 4, 5. Here is the parent chain 1, 2, 3, 4. Parent chain is of 4. Parent chain is of 5. They are actually chain isomers. They are what? Chain isomers. Why they are being chain isomers? Because their parent chain got changed. And what I have told you, their parent chain should not get changed. Their position of the alkyl group can get changed. So they are not chain isomers. So they are not position isomers. They are chain isomers. position isomers. They are not position isomers. Now let me show you another example. See, if I write like this, C5H12 CH3 CH3 CH2 CH3, and if I draw it like this, where should I place this CH3? Where should I place this CH3 so that I can get position isomer? Should I place that side? Should I place that side? Here. Now what is the relationship in between these two? Will you say they are position isomers? A and B are position isomer. Will you say like this? Yes or no? Yes or no? I want to see in the chat section. Yes or no, my dear friends? Yes or no? Hey kids, quick. I want to see everyone's participation. Everyone has to become doctor, engineer, so everyone's participation is required. Baba is asking. So what type of isomerism is there? Do let me know in between these two what type of isomerism is there. So the answer is they are identical. They are being identical. They are not isomers. Identical. Identicals are also known as homomers. Homomers. See, 1, 2, 3, 4. 1, 2, 3, 4. So they are not isomers. So I have tried all the possible things that with C5H12 I should make position isomers, but I got failed. Baba got failed. No one can prepare position isomer with C5H12. That means if the examiner is asking, see kids, if the examiner is asking one question, examiner's question, see, question is find out minimum number of carbon atoms required to show position isomerism in one, 2, 3, 4. Alkane, alkene, alkyne, any organic compound. It's 1, 2, 3, 4. I'm waiting for your answer. Do let me know. Yes, Baba is waiting for your answer. Alkane, alkene, alkyne. Minimum number of carbon atoms required. Just use your brain and tell me. Let me check it out who is going to give the correct answer. Kids, I'm waiting for your answer. Baba is waiting for your answer. Jesse, oh great, Jesse. 6442. I think Jesse, and who has given? Sushmita. Akshita. My God, kids, really. Salute. Pranam. Welcome, you kids are really intelligent. Now I'm really feeling happy to teach you kids that I can see the future of India. There are so many kids, those who are giving the correct answer. Oh my God, oh my God. I'm really feeling accomplished with this stupendous performance, marvelous performance. Kids, salute. Baba is saluting you. Hats off, kids. Hats off. Very good. Now let me explain. Don't think like that. Some kids have given the correct answer. Baba is not going to explain. Baba will explain each and everything. See, kids. First, I will tell you alkane. In alkane, just see. alkane. Alkane. Just see. If I take C6H14, I will make like this, two compounds like this. Just see. CH3, CH2, CH2, CH. 1 to 1 rana monu nale anche are 1 2 3 4 5 6. Do you know this language? And the second compound like this, CH3, CH2, CH, CH3, CH2, CH3. 1 rana monu nale anche are 6 6. Its molecular formula is same and its molecular formula is also same molecular formula. But see, let me check it out. What's the position of parent chain? 1 2 3 4 5. 1 2 3 4 5. Yay! In both the two compounds, parent chain is of 5 carbon atoms. So the parent chain is not getting changed. Oh my God, really? Parent chain is of 5 carbon, parent chain is of 5 carbon atoms. But see the position, my dear students, just see the position. Position got changed. Here the position is 2 of this methyl group, and here the position is 3 of this methyl group. Can you see? The position of alkyl group got changed. Position of alkyl group got changed. Parent chain same. Position of alkyl group changed. Position of alkyl changed. Got it, kids? Everyone got it? Now if I say in this way that parent chain is one number and second number is position of this, the second number. So in the first case, what I will say? I will say in the first case that parent chain is of 5 carbon atoms and position is 2, 52 number. And in this case, what I will say? 5 and 3, 53 number, 53 number. Can you see? Can you see? If these two numbers are different, position, parent chain and position, then they will be definitely what? They will be what? They are going to be what? Your position isomers. Are you getting my point? Everyone got it? Now, let me tell you the alkene case. Alkene case. Just see alkene case. Case of alkene. Alkene. Now, kids must be thinking, sir, then why not 5 was the answer? See the question. Minimum number of carbon atoms required to show position isomerism. So minimum number is 6. So 6 was the answer. Is it clear? Not the 5. Because the examiner has not asked the parent chain carbon. He asked the compound's minimum number of carbon atoms. Now let's see alkene. If I draw alkene like this, CH2 double bond CH, CH2 CH3, it is C4 H8. Now if I draw another compound like this, CH3 CH double bond CH and CH3, you see the parent chain is same. The parent chain is remaining same. Only the position of double bond got changed. 1, 2, 3, 4. Here the parent chain is of 4 carbon atoms. Here the parent chain is of 4 carbon atoms. Both the parent chain are of being 4 carbon atoms. But see, here the position of double bond is 1 and here the position of double bond is 2. Is it clear to all of you? So 4 is the answer for alkene. Is it clear to all of you? If this much is clear, hey kids, keep on showing signal in the chat section. That will give me energy that I am able to make you are able to understand. all my Avengers, NEET Endgame, all my YouTube students, as well as the one who is in the crash course or the Avengers batch, plus Iconic, IIT, offline students, whatever the number of students, Jaipur students, Tamil Nadu students, Chennai students, Karnataka students, Maharashtra, UP, Bihar, Lucknow students. Now kids, Andhra, Bhubaneswar. Now kids, just think about where right now Baba is, which city. Right now Baba is in which city? I'm giving you hint. The city is also known as the color of KMNO4. The color of KMNO4. Yay! Color of KMNO4 is pink. And the pink city, Jaipur. Yeah, you got it. Pink city is Jaipur. Jaipur is known as pink city. Oh, great going. Now, it was a small Kit Kat break. This was the small Kit Kat break. Now, moving ahead, my dear friends, everyone, till now, if you are able to understand what concept, then have some water along with sweet. Yes, whatever the thing mama has given to you, along with water, you can have that. Keep hydrated yourself. Your Baba is not only teacher, your Baba is parent teacher also. I have to take care of you, that you should remain hydrated. Kids, I'm your parent also. And whenever you are going to become doctor, engineer, you have to take care of the whole world. You have to become that much intelligent, so the world should wait for you. That Saucy is coming, that Achal is coming, that Mr. John is coming, Dr. John is coming, Dr. Saucy is coming. They are waiting for engineer Mr. Ravi, like that. So Shandar, Dr. Shandar is, everyone is waiting for Dr. Shandar. Everyone is waiting for engineer Ravi, Vishesh. Now kids, come back. So this is 4. Now let's see for alkyne. If I talk about alkyne, just see to it. Alkyne. If I draw one compound like this, CH, triple bond, C, CH2, CH3. And if I displace this triple bond on that side, CH3, C, triple bond, C, CH3. Now kids, you know one thing, that I was chemical. Before this life, I was a chemical, and I was listening all the things, what the talks were going on. This compound is asking to this compound, hey bro, what's your name? Hey, I'm butene. Okay, you are butene. 1, 2, 3, 4. I'm being butanine. Hey bro, what's your molecular formula? Hey, my molecular formula, 1, 2, 3, 4, 4 carbons. How many hydrogens? 3 and 3, 6 hydrogens. Oh, me too. My formula, the 1, 2, 3 and 3, 6. Oh my God, same to same. We have got same molecular formula. Same, even same parent chain. See, your parent chain is of 4 carbon atoms. My parent chain is also 4 carbon atoms. So we are identical? No. We are not identical. our position of triple bond is different. You have got position 1 and mine is 2. Oh, so our structure is same, our parent chain is same, our uh, functional group is also same, we both are alkyne, only the difference in position. So what's the relationship we are holding? Hey, we are brother, we are sister, or hey, we are pi. Got it? How many of you like this version? This version of explanation, kids? Do let me know. In this way, how many of you want to understand? How many of you want to analyze these things? The system is giving more clarity. Samria, yes, I can see. Samria is there. Thumbs ups, Laharikas, everyone, so great. Everyone is enjoying. Perfect. Thank you from the internal core of my heart, kids. Now, let's see any organic compound. Any organic compound. So when somebody is talking about any organic compound, just see, if I draw like this, CH3, CH, and if I place 2 chlorines over here and another compound, CH2Cl, CH2Cl. Now just see, this is known as gem halide and that is known as vicinal halide. Vicinal halide. My dear friends, here the position of both the 2 chlorines is 1 1 and here it is 1 2 1 2. So their positions got changed and the answer is just 2 carbon atoms. Everyone got it, kids? Have you got it? Now those who are having problem in gem and vicinal, just see, in my village people don't know what is to pronunciate it. They are calling it game. Let's play game. To play game, they are nearest to each other. And once they are having jealousy. In Hindi, vis means poison. So if they are having poisonous mind, they will go far away from each other. Far away. You got it? How to remember vicinal and gem halide? If you liked it, if you're liking anything, show me the thumbs up and the hearts. Then only Baba is going to give you number of tricks. If you're not enjoying Baba's trick, then what's the need to give you, kids? So the thing which you are liking always, I want to see the reflection in the chat section. Now see the questions answer, kids. Questions answer, you got it. And somebody has given the answer that it is being 6, it is being 4, it is being 4, and it is being 2. Now this is the answer, 6442. Always remember that 6442 for this type of question, and this question it is like this. I hope that it is clear to each and everyone. Now position is clear, structure is clear, ring chain is clear. Now it's a turn to tell you metamerism. Just see metamerism. Let me give you some another color. Okay, let's see this color. Let's enjoy this color. Metamerism. Now kids, compounds with same molecular formula same functional group but at least one different alkyl on either side of polyvalent functional group. Now see kids, this is the isomerism where most of the students they are doing mistake. Most often they are going to get negative marks in this type of thing. Now one thing is that what is this polyvalent functional group? First we will understand this polyvalent functional group, then only we can do anything, and they will have same functional group. This should get alkyl group on either side of polyvalent functional group should get changed, but the functional group should remain same. Let me tell you. Just see to it. If I take compound like this, CH3, CH2. Okay, first let me tell you the polyvalent functional group. Sorry kids, polyvalent functional group. Otherwise you won't, otherwise you won't be able to understand. See kids, see, polyvalent functional group means what? The meaning of polyvalent functional group: polyvalent functional group. See, if I say ether, ROR, this is divalent. One R can get changed, one R can get changed. This is divalent. If I write down ROH, this is not polyvalent because only R can get changed. This cannot get changed. This can't get changed. This can't get changed. So this is monovalent. So it can never show metamerism. This is ether. It can show. It may show. Ether may show. Now if I write down compound like this, NH R dash R or RR dash 2 degree amine, this is divalent, can show. But if I write down 1 degree amine RNH2, can't show because this is only 1 R. If I write down compound like this, ester RC double bond O R, can be same or different, that's different thing. But if I write down acid carboxylic acid, it is monovalent, can't show. They can't show. These people can't show metamerism, can never show, etc. Can never show metamerism. These may show. These are divalent. These, I'm not saying they will always show. They may show. So what is required to show metamerism? Are you able to understand polyvalent? They are monovalent. These are divalent. Now one question must be arising in your brain. So is it possible that 3 degree amine can show? Yeah kids. 3 degree amine can also show metamerism. Can show metamerism. Are you able to understand? More than monovalent, more than one valency, that can be divalent, trivalent, they can show, they may show. Now let me tell you what is the necessary condition. More things which are required, which you have to grasp in your brain. Till now it is clear what is monovalent, what is divalent. Now see kids, see to it. So if I take an example of ether, this is the most frequently asked question. So let me write down C5H10O. So I have written like this: CH3, CH2, O, CH2, CH3. Now just see, this is ether. This side we are having ethyl. Can you see? Ethyl. ethyl, and that side also we are having ethyl. This is first compound. This is first compound. Now let me draw second compound. Just see second compound. If I write methyl O CH2 CH2 CH3, this is methyl. Can you see methyl? This is being methyl, and that side it is N propyl, normal propyl, normal propyl. Now just see, if I write down third compound, just see to it, third compound. If I write down methyl O CH CH3 CH3, just see, this is remaining methyl only. This one is remaining methyl only, but that got changed to isopropyl. Now they are talking to each other. What's the difference? Hey bro, our molecular formula is same. All three are saying, hey, we are from the same family. My molecular formula, your molecular formula, your molecular formula, all three, they are in a party. They are in a party. Let's have party tonight. Party of knowledge. Party which is leading towards our success. So let's have chemistry party tonight. Now see, this is saying, hey, I'm ether. This is saying, hey, I'm ether. I am also ether. All three are being ether. They are enjoying, yay, we are ether. But this is saying, one side ethyl, that side ethyl, one side methyl, that side propyl. Oh, both side of polyvalent functional group, the alkyl group got changed. So what's the relationship? What the relationship? They are saying, we are metamers, metamers, metamers. Now, by just shouting, hey, we got a relation that we are metamers, one old man came. Hey, why are you shouting? They are saying, we are metamers. Old man said, you don't know chemistry. Who taught you chemistry? They said, hey, Baba HSP is teaching us. Call Baba HSP. Now that old scientist was having conversation with Baba HSP. I said, hey, this is metamers. He said to Baba HSP, hey, Baba HSP, let me check your knowledge. See, there is the parent chain of 2 carbon atoms. And here, the parent chain of 3 carbon atoms. Oh, Baba HSP, amazed. What happened? What is this? There is the parent chain of 2 carbon atoms, and here parent chain is of 3 carbon atoms. That old man said, hey Baba HSP, I am also watching your Unacademy NEET English channel. I will make a complaint against you. What you're teaching? I said, hey old man, what happened? See, the parent chain is different. So they are not chain isomers. I've seen your YouTube channel at Unacademy NEET English channel. You also teaching like this, that they are parent chain isomers because the parent chain is different. Odi Baba, yes, they are chain isomers also. I touched his feet. Hey scientist, forgive me, forgive me. So they are chain isomers also. So they are chain isomers also. Oh my God. Kids, are you understanding it? Are you getting it or not? Just see, they are chain isomer, they are metamer. Then why Baba HSP was teaching like this is the metamers? See, write your famous position. Write your famous position. Write your famous position. Have I told you this thing? Write your famous position. Then I said, hey old scientist, what I was teaching, I was giving more knowledge. They are chain isomer as well as they are metamers. But if they are supposed to pick only one option, then who comes first? Who comes first? That metamers or chain isomers? So metamers is getting position. So they are both type of isomerism is there. But if only one option you have to mark, you will mark metamers. Kids, you got it? You got it? So what's your question? Who is asking question? Alina Asfake, sir, please reply about my question. What's your question? What's your question? Okay, let me tell you another one so that you can understand the first one. See, they are metamers, but you see, they are also chain isomers. Parent chain is of 2 carbon atoms and parent chain is of 3 carbon atoms. So they are chain isomers also. But out of these two options, if only one option we have to take, we will mark metamers. Now see in the second one, 1, 2, 3, and here, just see here, 1, 2, 3. Parent chain is of 3 carbon atoms. The parent chain 3 carbon atom, 3 carbon atom, but the position of this methoxy is 1. Here the position of methoxy is 1. Here the position of methoxy is 2. So they are position isomers also. They are pi. And what I have told you, that side it is n-propyl, this is isopropyl. So at least on one side, if the alkyl group is getting changed, they are metamers also. Pi as well as metamers. Metamers. But pi and metamers, we will give preference to metamers. Kids, how many of you are able to understand? If you got it, show me hearts. If you haven't got it, then show me fire. Fire means you want to need it again. I should explain it again. Fire means again I am supposed to explain. Heart means it's clear to you. Hearts means clear to you. Fire means once again. Then I will explain once again. So fire and hearts combination. Okay, let me explain once again. Let me explain once again. I got it. I got it. I got it, kids. See, one thing you should make very clear in your brain, that metamers are always either chain isomers or position isomers. Just keep this thing in your brain always. Metamers are always either chain isomers or position isomers. But why we are giving preference to metamers? Because this is the sequence. Write your famous position. Write your famous position. So see the sequence. Priority order. This is the priority order, kids. R, T, F, M, C, P. So metamers, the metamers are always either chain isomers or position isomers, but we will give preference to metamers. One thing is clear to all of you kids. Do let me know. Is this point clear to all of you? Yes, this point is very much clear to all of you. Now I am going to explain it. See. Just see. This is ethyl. Here is the functional group. Let me first explain two. And this is also ethyl. This is diethyl ether. Diethyl ether. Oxygen is there. This is oxygen. Now in the second one, if I write here methyl, and I write here N-propyl, CH2, CH2, CH3. So if I say this is X, this is Y, just see to it. I told you this is polyvalent functional group because its valency is 2. Its valency is this side also. It is having two hands. These are the hands. Just suppose this is the person, Pandu. This is Pandu and he is having two hands. Pandu and he is having two hands. So two hands. One side ethyl, another side ethyl. Pandu is saying, hey, right hand side ethyl, left hand side ethyl. My molecular formula is C4H10. Pandu is shouting like this. Now Pandu's clone, this is saying, hey, my molecular formula is also C5H10, but on one side I'm having methyl and another side I'm having N-propyl. So the alkyl group, either on one side it is getting changed, then also metamer, and both side it is getting changed, then also they are metamers. They are flying like that, eagle. They are eagle. Pandu eagle, Pandu's clone eagle. So this Pandu eagle is saying, hey, one side is ethyl, another side is also ethyl. This is saying, oh, one side methyl, another side N-propyl. So what relationship these eagles are saying? We are metamers. This much is clear that X and Y are metamers. Kids, first of all, do let me know, is this point clear to all of you that X and Y are metamers? One thing is clear to all of you, do let me know. I want to see in the chat section those who were not able to understand earlier, now right now they are able to understand. If they are able to understand, earlier they were not able to understand, and those kids also, those who were able to understand earlier and right now also they are able to understand. If everything is clear about metamers, then show me green signal, yes. Then second point, both the eagles while flying, they applied their brain. Hey, let's see, my parent chain is of 2 carbon atoms. Parent chain is of 2 carbon atoms, and this is saying my parent chain is of how many carbon atoms? 1, 2, 3. My parent chain is of 3 carbon atoms. Our parent chain is different. So the first point about isomerism today I taught you, if the parent chain is getting different, if the parent chain is different, then they are chain isomers also. So X and Y are metamers. X and Y are chain isomers also. So if examiner is giving both the options, then both are correct. If examiner is saying that only one option you are supposed to mark, you will go for metamerism, because write your famous position. Write your famous position, and in this way metamerism is getting more preference. Kids, I want to see that Baba's efforts working or not. Kids, Baba's efforts are working or not. I want to see in the chat section. Kids, do let me know. Is this clear? Now, just see the another one. See another one. CH3 O CH3. Now this compound is talking to this compound. These two eagles are talking with each other. Let us suppose this is Y and this is Z. This was the Y and this is Z. This is Y and that is being Z. Both eagles are saying, hey, our molecular formula is same. My molecular formula is C5H10, yours, mine same. I'm ether, you are also ether. One side, my one wing is methyl. Oh, same sister, mine also methyl. If their one wing is same, they are saying we are identical. No, just show me your another wing. So another wing, its another wing is 1, 2, 3, isopropyl. And its another wing is straight chain, that is branched. This is straight chain, N-propyl. What do you think? This wing is same or different? This is different. So on the basis of this difference, they are metamers. They are metamers. One thing is clear to all of you. Is this point clear? That at least if one wing, one alkyl group is changed, they will be known as metamers. Now, another type of relationship they are holding, that its parent chain is of 3 carbon atoms. Its parent chain is also of 3 carbon atoms. So they are not chain isomer. But if you see the position of this methoxy, if you see the position of this methoxy, that is 2, second position, 2 methoxypropane, and here it is being 1 methoxypropane, 1 methoxypropane. So their position is getting changed. So they are pi also, position isomers also, but preference should be given to metamerism. Kids, now let me see the chat section. If everyone, it is clear to all of you, show me the hearts. If you're not able to understand, show me once again the fire. Baba will let you know once again, no worries. Fire or hearts? Kids, everyone has to participate in this. Yeah, now I can see everyone is giving hearts. That means it is clear to each and everyone. Thank you, kids, for understanding. That's really lovely. Now let me give you one more example. Let me show you one more example so that to make it very clear to all of you. Just see. If I say I am having this compound, should I give you easy question or tough question? What do you want? Should I give you easy question or tough question? You just decide and write down in the chat section. Till that time, let me give you some information. 1 degree, 2 degree, 3 degree amines are treated as different functional groups. Now you wanna easy question or tough question? Easy or tough? Both. Okay, both. First, let me give you easy question. Most frequently asked easy question. Question is, find out relation in between CH3, CH2, NH, CH2, CH3, CH3, NH, CH, CH3, CH3. So I am giving you options. First option, A option, constitutional isomers. B option, chain isomers. C option, metamers. D option, all of these. A, B, C, D. A, B, C, D, kids. Let me see the chat section. A, B, C, D. A, B, C, D. So kids, the correct answer is being D. All of these. These are structural isomers. These are chain isomers. Structural means constitutional. Constitutional and structural isomers same. They are metamers. The parent chain here is of 1 and 2 carbon atoms. Here it is of 1, 2 and 3 carbon atoms. Can you see? Everyone, is it clear to all of you? Is it clear to all of you? Now I'm going to give you a tough question. Are you ready? I'm going to give you a tough question. This was easy question. This was easy. Not tough question. But for your syllabus, it will come in your syllabus. Means it will come in your examination. Bit tough question. Now question is, find out relation A is CH3, CH2, and CH3, CH2, CH3. B is CH3, CH2, CH2, NH, CH3. Do let me know. First option, I'm giving options. A, metamers. B, chain isomers. C, both A and B. D, none of these. Yes, let me check it out. Your answers. Who is going to give the correct answer? First correct answer, I will declare the name. I will declare the name. Madhu. Madhu is absolutely correct. Everyone is going for A, but Madhu and Madhubala has gone for the correct answer, and Shushmita has given the correct answer. D, JDSS has given the correct answer. Kids, see, everyone has given the wrong answer. D is the correct answer. Why? 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. Number of carbons are 5. Here, 1, 2, 3, 4 carbons. Their molecular formula is different. Different molecular formula. Different molecular formula. Kids, what will you say? This was easy question, tough question, or easy in the form of tough, or tough in the form of easy? What will you say, kids? This is Brainy Baba's brain, and such type of questions you will get in the examination, and you will get failed, because you have seen right now from the starting Baba is telling you, if the molecular formula is same, then only check for the isomerism. If the molecular formula is different, you can't say they are isomers. Kids, you want one more question? You want one more question? Kids, do let me know. Baba is asking you. Hey kids, you want one more question? So see another question. Baba is going to give you another question. See to it. Just see. Kids, right now we are dealing with the easiest thing, that we are dealing only with the structural isomerism. And in structural, when I'm going to tell you tautomerism, that holds a hell lot of weightage. And when I'm coming to GIE, and then after optical isomerism, the whole night is there. We have to celebrate this chemistry party tonight. How's the Josh? I want to see some fire in the chat section. Everyone, I want to see some fire in the chat section. How's the Josh? Am I audible and visible to all of you right now? Can you hear me? Can you see me, kids? My screen is proper to all of you? Screen is proper. Screen is as usual. Screen is proper to all of you, kids. Do let me know. Is the screen properly visible? Perfect. Okay. Now see, kids. So the question is, find out the relation. Compound A is compound B is first option is metamers, second option functional isomers, only two options are there. Only two options, kids. Only two options. Now do let me know what's your answer. Only two options, kids. Now let me check it out. What answer you are going to give, kids? Only two options. B. Yeah. Hats off to you. Salute. Perfectly correct. Kids, perfectly correct. The toughest question you have solved, they are functional isomers, because this you can see the nitrogen is attached with 2 carbons. The degree of this nitrogen is 2 degree, and this nitrogen is attached with 3 carbons. So the degree of this nitrogen is 3 degree. So secondary and tertiary, they are treated as different functional groups. So they are not metamers, they are functional isomers. Salute for your dedication and for understanding it properly, kids. That's really awesome, really awesome. Now see, kids, after this metamerism, let me move towards functional isomerism. Functional isomerism. Now, kids, first of all, do let me know how many of you find it very difficult to find out what compounds could be functional isomers, how to find it out, how to visualize it. How many of you want to get command on this, that immediately within fraction of seconds you can get an idea about it? How many of you want? So to get a command in this functional isomerism, to get whole command in this functional isomerism, kids, we should know one thing. The name of that thing is double bond equivalent. That is double bond equivalent, or we call it degree of unsaturation. Du, or we call it index of hydrogen deficiency. Index of hydrogen deficiency. All the names are same. Now, my dear students, this thing have you studied? If you have already studied, show me fire in the chat section. And if you want to study, that means you have not studied, show me hearts. Hearts means you want to study, because I don't know whether in the general organic chemistry you have studied. If you studied, then we can directly move, and if you have not studied, then I will let you know. Yes, hearts of fire. Hearts means you want to study. So fire, hearts, maximum of the hearts are there. I can see maximum hearts over there. That means you want to study. Now see, kids, just see to it. Kids, just try to visualize it. Try to visualize it. If I write down alkane, what will you say? What is the molecular formula of alkane? CnH2n, CnH2n plus 2. That means if I write C6, then 6 2 are 12 and 14. This compound is saturated. This compound is saturated. Proper alkane. This is proper alkane, right? This is proper alkane. Now if I write down C6H12, now see, kids, in between A and B, what is the difference? This means B is having something less. What is less? Carbon or hydrogen? What is less? Carbon or hydrogen? Definitely hydrogen's difference is there, and two hydrogen atoms are different. That means one H2 molecule. This compound is having one molecule of hydrogen less. One molecule of hydrogen less. Am I right? So its dB is 0 because there is no hydrogen less, but its dB will be 1. You are able to understand? Now you must be thinking, sir, why can't give us the formula of dB? There's formula. Even you can give us the formula. I will give you the formula, but first visualization, because formula gives the speed. Remember that formula just gives what? Formula gives us speed only. No visualization. No visualization. Formula never gives visualization. No visualization. And that's why anything could be tough. But if you visualize, visualization is important. Visualization gives accuracy. Visualization gives accuracy. So what is more important? First, accuracy is more important or speed? First, accuracy, and speed will come automatically. If you work on accuracy, speed will come automatically. Am I right? Am I right? Am I right, kids? Now see, if I write down C6H14, its dB is how much? Its dB or degree of unsaturation will be how much, kids? Degree of unsaturation or D is 0. Now if I write down C6H12, it's 1. Now kids, if I write down C6H6, so compare with C6H14, C6H14 and C6H6. How many hydrogens are less? 14 minus 6. 14 minus 6 is how much? Kids, you know maths, do let me know. 14 minus 6 is 8. So how many H2 molecules? These are 8 hydrogens. So convert into molecule, 4 H2 molecules. So its dB is 4. Okay. Is this point clear to all of you? Now I'm going to give you formula. This is the visualization that how many hydrogens are less in that compound. Now let me give you the formula. Formula is, just see the formula. Formula is CXHY. CXHY. It's just a second. So kids, just see what I was telling you. CXHY, where X is number of carbon atoms, X is equal to number of carbons, and Y is equal to number of hydrogens. Now apply formula. If I apply formula on this one, then its dBE will be 6 plus 1 minus 14 by 2. 7 minus 7 is 0. Now apply this. dB is equal to 6 plus 1 minus 6 by 2. 7 minus 3, 4. This is the formula, that is the visualization. You got it? First of all, do let me know in the chat section if it is clear. Keep on indicating that yes, you got it. Now let me show you dB. This was the dB calculation from the given molecular formula. This was the dB calculation from the given molecular formula. dBE calculation with the given molecular formula. Now I will let you know calculation of dB from given structural formula, but before that you have to tell me the answer. I'm going to give you question. Question is, find out dBE. Find out dBE. First is C3H8. Tell me the answer fast. Quick. C3H8. Second is C4H8. Tell me the dB. Fast kids. Fast. I want to see answer. Very good. 0. Here 1. Third is C6H10. 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 Everyone, C6H10. So what is the dB? So see, its dB you can calculate 6 plus 1 minus 10 by 2, 7 minus 5, that is how much? 7 minus 5, 2. So its dB is equal to 2. Perfectly clear. Now by chance, along with carbon and hydrogen, oxygen is also there, nitrogen is also there, halogen is also there. That question will become very tough. Now let me give you formula for that. See, if compound is like this, CXHYOZ, oxygen will not make any difference in the formula of dB. See, once again the formula for dBE will remain as x plus 1 minus y by 2. No role of oxygen. Formula will not get changed. For example, if I write down C2H8, H6 or C2H6O, their dB will remain same. Its dB is x plus 1 minus y by 2, 2 plus 1 minus 6 by 2, 3 minus 3 is equal to 0. Its dB 2 plus 1 minus 6 by 2, that is 3 minus 3 is equal to 0. So their dB will remain same. Is this point clear to all of you? Now, if nitrogen is there, halogen is there, then what should be the formula? C. This is going to be a tough question. How many of you want to know? This will be the rank deciding question. Rank deciding question. C. Rank deciding. CX HY OZ, nitrogen A, halogen B, or their family members. Family members, like if I say who is the family member of halogen? Halogen Xs, fluorine, chlorine, bromine, iodine. Who is the family member of oxygen? Oxygen, sulfur, selenium, tellurium, polonium. Who's the family member of nitrogen? Nitrogen, phosphorus, arsenic, antimony, bismuth, like this. Okay, you got it? Everyone got it? So valid for the family members also. This is going to be valid for the family members also. Now see kids, everyone see to it that what is the formula for dBe? dBe will be equal to x plus 1, this will remain same, minus h by 2. H by 2. What is h now? What is h? H is equal to number of halogen atoms plus number of hydrogen atoms. That means halogen and hydrogen are counted in the same. Number of halogen atoms plus number of hydrogen atoms. Let me put it inside the box. Number of halogen and hydrogen atoms minus number of nitrogen atoms. Number of nitrogen atoms. Once again, oxygen is not having any role. Oxygen is not having any role. Now, how will you learn this formula? Just see how to learn it. Hello? Arey, hello. Hello. Hi. And night. Just add hello, hi. Hello, hi, add you. And leave the nitrogen. Just add hello, hi. Hello. Hey, hello. Hey, hi. Somebody is saying hello and somebody is saying hi. See, hello, hi. Just add them and leave the nitrogen. So during night time, we are going to sleep. We are leaving everyone. Just in the morning, hello, hi. This is making a bonding. This is just addition. In the morning, we are saying hello, hi. This is the bond. And during the night time, we are leaving. We are going back to our home. Just minus night. Hello, hi, minus night. Hello, hi, add. Just subtract night. Got it? Kids, are you getting this formula, everyone? Everyone? Hey kids, I want to see some appreciation. Your Baba is telling you tricks. Great tricks Baba is going to give you, kids. Baba is in need of some appreciation. Thank you, Nawab's World from Lucknow. Thank you, Nawab. Thank you, Jesse. Thank you, Anita. Thank you. So, I will give you one question based on this. But before that, let's celebrate the water H2O in the liquid form. Hydrogen bonding intermolecular. Now kids, just see calculation of dB from structural formula. I know that you must be thinking, sir, just give us one example of this. I will give you example, don't worry. But first, calculation of dB from structural formula. The formula for this is number of pi bonds plus number of cycles. Number of pi bonds plus number of cycles. Let me show you. Let me show you. If we are having compound like this, CH2 double bond CH2. So 1 plus 0 is equal to 1 dB. If I show you compound like this, one cycle. So 0 plus 1, 1. If I show you this compound, 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 now do let me know their dB in the sequence respectively. If you are able to understand, if you are able to understand, do let me know their dBs. If you got it, do let me know their dBs, kids. Yes, let me see who is going to give the answer, kids. Who is giving the answer? Yes, kids. Show me the answer. 1, 2, 3, 4. Very good. Fantastic. Fantastic. 1, 2, 3, 4. 1, 2, 3, 4. This is the correct answer. Now, if I show you another compound, tell me the dB. If anyone is going to ask, what is the dB in naphthalene? This is naphthalene, kids. Naphthalene. Do let me know what is the dB in naphthalene. Yes, kids. I'm waiting for your answer. Waiting for your answer. So see, 2 cycles, number of pi bonds plus cycles. So here 2 cycles plus number of pi bond 1, 2, 3, 4, 5. 5 plus 2, 7. How many of you got 7 answer? Let me check it. How many? Yeah, everyone. That's fantastic. Now, the time to go for this compound, just see. Let me place here benzene. Let me place here C double bond O. Let me place here CHCl. Let me place here CH2 and NH2. CH2, NH2. Every atom has come. So, I have given you one formula just to calculate dV from the given molecular formula, and here I have written structural formula. They have to match. Calculation of dV from the given molecular formula as well as calculation of dV from the given structural formula, if that is getting matched, then only my visualization towards you was the correct thing. Otherwise, I am wrong. Let's check it out. Let's check it out from the given structure formula. One cycle, number of pi bonds 1, 2, 3, 4, 4. 4 plus 1, 5. Is it clear, kids? 4 plus 1, 5. This is from the given structural formula. Let's change it into molecular formula. Help me in changing into molecular formula. See kids, how many carbons? This much is C6H5, C6H5. This much is phenyl, C6H5. So 6 carbon, 7, 8, 9 carbon, C9. Hydrogens 5, 6, 7, 8, 9, 10, 10. Am I right? C6H5, 5, 6, 7, 8, 9, 10. Halogens are 1 halogen, chlorine is 1. Now oxygen, no role of oxygen. Nitrogen, 1 nitrogen. Kids, the molecular formula is okay. If this is okay, now let's apply formula. Formula was dBE is equal to x plus 1 minus h by 2, and h was hello high, add nitrogen, subtract. So carbon 9 plus 1 minus h is equal to what? Add hello high 10 plus 1 minus 1 divided by 2. It will come out 9 plus 1, 10 minus, this will cancel out, 10 by 2, 5. 10 minus 5 is 5. Gets working. This is from molecular formula, that is from structural formula. Both ways you are getting the same answer. This is from the given structural formula. And this is molecular formula calculation from molecular formula. Gets, I have verified it. Now the time is to apply how it is going to help us. That is the thing. Once it is clear to all of you, do let me know. And you are ready for that, show me the Josh with the help of fire. That till now it is clear to all of you. Then I will tell you how to apply it and how the organic chemistry will become easy, how the speed in your organic chemistry will get increased. Baba is going to tell you that. How the speed, how to increase the speed. Let me tell you. dBE will increase your whole organic chemistry speed. dB, you call it dB, you call it du, will increase your speed, will increase your visualization, and speed in your organic chemistry, in your organic chemistry. That means I want to say, if you are able to understand this dB, the one who is crawling will start flying, Now see kids. You have to participate in this. If dBE is 0, what is it is indicating? What indication you are getting? If dB is equal to 0, that means compound can't be cyclic, can never be cyclic, can't be cyclic. Am I right? Can't be unsaturated. Can't have any functional group. Can't have any multiple bond functional group. Agreed? If you are agreed, never stop to show thumbs up if dB is 0. This is the first point. Agreed, everyone? Never forget to show thumbs up, kids, if you are agreed. That is the only way to communicate, and that is required right now, kids. Now, second page. If dB is 1, if dBE is 1, that indicates first point, saturated cyclic. Saturated cyclic means without any pi bond, the cycle can be there without any pi bond. Second point, it could be means acyclic alkene or acyclic compound with one pi bond. Kids, got it? This point is also clear to all of you? Is this point clear to all of you? Now, if I say dB is 2, just see, look. If I say C point, if dBE is 2, now kids, you can find out what I mean. That indicates 2 cycles. 2 cycles means it can be bicyclo, it could be spiro. This is possible. If I say 1 cycle plus 1 pi bond, or I can say acyclic means without cycle, alkadine or alkyne. Are you getting my point, kids? Everyone? Now you must have got the sense, and we are going to apply this sense in the functional isomerism, and this will really change your view, because dB holds a hell lot of weightage in your organic chemistry. It's just like a soldier with sword. Tipu Sultan. Yes, sword was there with Tipu Sultan. Without sword, the Tipu Sultan is nothing. A writer without pen is nothing, and a doctor without stethoscope is nothing, and an engineer without those building material qualities and whatever the things, waves in their chemical brain, they are nothing. Are you getting my point, kids? Everyone? Now let's see. Now let me check out your this messages in the chat section, and then I will start. You can have water. Just give me 30 seconds. Let me check out the chat section. Okay, so learned a lot. Nawab's World, Ramesh Kumar, oh Shruti, everywhere, oh my god. So kids, keep on writing in the chat section. I want to see everyone's attendance, who is there. My blessings are with you. Wow. Now in the chat section, everyone write down, I'm here, east or west, Wawa is best. It's Ratnesh Kumar, thank you. Ratnesh Kumar, Nikita, Ramesh Kumar, wow, thank you. Nawab's World, thank you. I'm good. Joseph, Madhu, Priya, I'm good. Sneha, I'm good. Baba the Great, TDSS. Samria, thank you. Kanika, thank you. Susi, God of Chemistry, Baba, thank you. Madhera, thank you. Thank you. The real legend. Okay, thank you, kids. Really, thank you. And those who are new, please hit the like button. I want to see likes to get increased. Baba is waiting for your likes. Legend of Chemistry, Madhu. Thank you. Okay, kids. Now, let's apply this. See, we were studying the functional isomerism. Now, if I say, see, the view will get changed. I'm having formula like C6H10O2. C6H10O2. How many types of compounds can you make and what relationship they are holding? Only kids who is going to take maximum time in the examination, do let me know. First of all, let's do some preparation. Your maximum time during examination will get consumed by counting hydrogens. Counting hydrogens consumes maximum time. Consumes maximum time. Now kids, Baba is going to show you magic. No need to count hydrogen. Right now, Brainy Baba is going to show you magic. There is no need. There is no need to count hydrogens. Then what is required? Only take care of only take care of what? dBe and number of carbons. Only take care of dB and number of carbons. Are you getting my point, kids? You are supposed to take care of these two things only. Forget about hydrogen. Hydrogen will get balanced automatically. Are you ready, kids? Are you ready to play? Everyone, just keeping this thing in your brain, in your hippocampus. Are you ready to play? Is everyone ready to play? Show me hearts if everyone ready to play, kids. If everyone is ready to play. Now, my dear friends, once again, let me tell you one thing for sure. Kids, number of students, they were worried, sir, how to study. This is the whole team, you know. Pankri ma'am, biology faculty, best biology faculty. Ambika madam, the best biology faculty. Wasim, you know, king of chemistry. Thalaiba, your Baba HSP, very simple teacher, hardworking. Kailash sir and Yavas, two physics legends. My dear friends, the best India's teacher, they are taking your crash course, and I will not say crash course. It's the science which is going to give you selection, in-depth knowledge. They are going to give you with tricks and tips. So anyone who is preparing, who is going to give examination, this fantastic crash course is available just for 4,499 rupees. Tell to everyone, and don't forget to apply this code. Which code? HSP10. One rana monu nale anche are ere ette umpad. HSP umpad. Am I right? Tamil or Telugu, I don't know. But this 10 is umpad or not? Do let me know. So tell everyone, all your friends, classmates, brothers, sister, relatives, it is just available for 4,499 rupees. It's not even 5,000 rupees, kids. Okay. So, okay, pad. One rana monu nale anche are ere ette umpad pad. Okay, 10, HSP 10. Don't forget to apply this. Let me write down in bold. HSP 10. HSP 10. This is code. If you apply this code, the 17,683. This is the price of this crash course. And I would like to say it is more than 1 lakh kids. It is written here only 17,683. It is even more than that. It is just available for 4,499. If you divide in among all these teachers, not the rupees, the quality you are going to get. So it's nothing. Tell everyone. Okay. Now let's come back. Oh my God, so fast. Just a second, kids. So see, C6H10O2. C6, oh ho ho, C6H10O2. Now I will ask questions, you have to reply. What is the dB? Fast. What is the dB of this compound? Do let me know. What is the dB of this compound? I want to answer fast, quick. What is the dB? Yeah, you will get break at 8. At 8 o'clock, I will give you break. Okay. At 8. 2. Very good. 2. Now I want to make acid. If I want to make carboxylic acid, just see kids. If I want to make carboxylic acid, can I make carboxylic acid with this? See how many carbons? 6 carbon. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 and 2 oxygen. O and OH. How much dB I have consumed? Till now 1 dB I have consumed. 1 dB. 1 dB. 1 more is left. Can I place double bond? 2 dBs I have consumed. Now kids, I have not counted hydrogens. They will automatically get balanced and they will come only 10. C kids. CH3, because carbon valency is 4. Now 1, 2, 3 valency, 1 hydrogen. Now 1, 2, 3, 1 hydrogen. So 1, 2, 2 hydrogens. 1, 2, 2 hydrogens. Just check it out. 3, 4, 5, 2, 7, 2, 9, 1, 10. Liked it? Now see another one. If I want to make ester with this, ester, what I'm supposed to do? Carbon, double bond O, 1, 2, 3, 4, 5, 6 carbons. 1 dB I have consumed, 1 more dB. Now count hydrogen. They will come immediately. 2 hydrogens. 1, 2. No need to count. I'm showing you. Otherwise, no need to count. This is just I'm making it that whatever I've told you, it's correct. Absolutely correct. Just check. 2, 3, 5, 2, 7, 3, 10. Now, if I want to make hydroxyaldehyde, just see what I am supposed to do. 1, 2, 3, 4, 5, 6. 3 and 3, 6. Let me add hydroxy. Let me make aldehyde. Now let me put one more pi bond. So see, basic format is correct. I have used 2 pi bonds, 6 carbons. Hydrogens will get balanced automatically. See, 2 valency, 2 hydrogens. 2 valency is 2 hydrogens. 1, 2, 3, 1 hydrogen, 1 hydrogen, 2 hydrogens. So that's got balanced. If I want to make hydroxy ketone, I can make hydroxy ketone kit. C. 1, 2, 3, 4, 5, 6. 6 carbons I have used. This is ketone and this is hydroxy. Now just only 1 dV I have used, 1 more dV. Now you can count hydrogen. Automatically they will get balanced. Now, till now I have drawn 1, 2, 3, 4. Let me draw one more compound. C6H10O2. C6H10O2. Just see to it. Suppose if I have consumed all the 6 carbons, 1 dB. If I place one more pi bond, 2 dB, 6 carbons I have consumed. Now 2 oxygens. 2 oxygens I can write like OH. You can count hydrogen yourself. They will get balanced. Or you want to count. See, let me count. They will get balanced by themselves. See, 2 hydrogens, 1 hydrogen, 1 hydrogen, 1 hydrogen, 1 hydrogen. Just see how many hydrogens. 2, 4, 5, 6, 7, 8, 9, 10. It's okay. Now, if I am going to make ring of 5 carbon atoms, and if I place double bond over here, dV, I have consumed 1. Now I can place one more dV, the one cycle, one pi bond, OH. This will come like that only. Now, if I write it like this, I have consumed one cycle like this, and I am writing like this. 1 oxygen I have consumed. 1 cycle I have consumed. 2 dV I have consumed. 1 carbon is left. I can place like this. I can place like this, or even I have gone like this also. CH2OH. Then also it's fine. I can make n number of compounds. Kids, are you getting it? Infinite compounds I can make. I will keep on making. Are you getting sense? Let me check it out, kids. If you got it, if you smelled it, if you visualized it, show me some hearts, fires in the chat section. Kids, have some water. At 8 o'clock I will give you break. At 8 o'clock I will give you one break. See, kids, your comments, they will give me energy. So if you are liking it, if you are loving it, do let me know in the chat section. Stacy, I haven't forgotten you. I remember you. Young ex Stacy. Now see, kids. Now. So after this, the most important thing Baba is going to tell you, and that thing is what is left. Do let me know what is left. That thing I am going to tell you. What thing is being left? Baba is going to focus on that. In structural isomerism, Baba has told you, write your famous position. Write your famous position. So Baba has taught you ring chain isomerism, functional isomerism, metamerism, chain isomerism, position isomerism. So only tautomerism is left. Tautomerism is left. And it holds a hell lot of weightage. Very, very important for all examinations. Very, very important for all types of examinations. Very, very important. For all exams. Kids, I will tell you tautomerism from the scratch, from the base. Everyone ready, because it holds a hell lot of weightage. Very, very important. If I divide the structural isomerism, one side the all type of isomerism are RFMCP, and one side tautomerism. Tautomerism, if I divide like this is valence, and if I divide like this, then one side is tautomerism, another side RFMCP, equivalent, the structural isomerism. If I talk about a structural isomerism, then it is like this, balance. So you are supposed to apply your whole brain. Are you ready, kids? At 8, I will give you, it's 19:25, means 35. After 35 minutes, I will give you a break. So are you ready, kids, for the tautomerism? In tautomerism, remember that someone is moving, someone is moving from one place to another place, from one place to another place. Someone is moving from one place to another place, and who is moving? The question arises, who is moving? Then you know that till now, even the scientists are not able to specify it, where to keep the element hydrogen in the periodic table. None other than hydrogen. Hydrogen is moving. So let's see hydrogen. Hydrogen atom is moving, and that is responsible for giving tautomerism. Let me divide tautomerism. Your tautomerism is of 3 types. Tautomerism is of 3 types. Is of 3 types. What are these 3 types? 1, 2, 3. One is diode system. Diode. In this, hydrogen moves from 1 to 2. 1 to 2. First atom to second atom. Triad. In this, hydrogen moves from 1 to 3. Pentad. In this, hydrogen moves from 1 to 5. The one who is maximum important, this is triad system. Very, very important. Very, very important. These two have got only one example. It's example, only one example in syllabus. And that is also having only one example in syllabus. And this one is having multiple examples. Very, very important. So multiple examples are there. Multiple examples are there. So kids, are you ready? Everyone ready? Let's see. Let's see. Just see. Diode system. Diode system. The hydrogen is cyanide. Cyanide, you know very well. Hydrogen was attached to carbon. Hydrogen was saying, hey carbon, you are mine, I will never go anywhere. And you see, this is isocyanide, coordinate bond, isocyanide. Can you see? The one who was saying, well, never go, never go, never go, it was belonging to carbon, now it belongs to nitrogen. So from first atom, it has gone to second atom, hydrogen cyanide and isocyanide. This is the only example, cyanide and isocyanide. Kids, let me tell you, they are tautomer. Before tautomer, they are the functional isomers also. Cyanide is the functional isomer of isocyanide. So they are tautomer as well as they are functional isomers. Remember that. They are tautomers as well as functional isomers. So my dear students, why we are giving more preference to tautomers? Because write your famous position. Write your famous position. So who is having more preference? Who is having more preference? You can see tautomers are having better preference than functional isomers. That's why this is the only example of diode system which is in our syllabus, and I hope this is clear to all of you. Clear, kids? Is it clear to each and everyone? Okay, now see triad system. Everyone see triad system. I'm going to give you one trick, Baba HSP's trick. See, Brainy Baba HSP's trick. Brainy Baba HSP's trick. Just enjoy this trick. X double bond Y single bond Z and Z attached with acidic hydrogen. Acidic hydrogen. This is acidic hydrogen. X, Y, Z are non-metals, where X, Y, Z are non-metals. Whenever you see such type of compound, wherever you see such type of compound, this will always show tautomerism. If the examiner is asking whether the given compound will show tautomerism or not, remember that if this type of condition is there, that in between X and Y there is one pi bond, and there is one acidic hydrogen, such type of compounds will always show tautomerism. In a short time, I'm going to tell you the mechanism how it will show tautomerism. But if you want to draw a tautomer of it without understanding mechanism, then let me tell you, see. This is one form where hydrogen is attached to first atom, second atom, third atom. After some time, what is going to happen? This double bond will move in between 1 and 2, and this hydrogen will go from 1 to 3. Who is moving? Only atom, electron, or both? If you are able to understand, if you are full on energy, do let me know. In tautomerism, just remember, in resonance only electrons show their movement, whereas in tautomerism, atom as well as electron is moving, and that's why tautomerism is also known as desmotropism. Desmotropism. The meaning of this desmotropism is that both are moving, bond as well as electron is moving. bond as well as electron is moving. Bond as well as electron is moving. So its tautomer will be, just see to it, its tautomer will be X, Y, Z, and just try to understand. Let me write down 1, 2, 3. It was 1, it was 2, it was 3. The bond has gone in between 1 and 2. So the bond will be over here. And the atom has gone to 3. So they are tautomer. Now kids, this is just cramming part. If you really want to understand the mechanism, so you have to understand each and everything. Are you ready? To go in depth, to go in detail, we have to understand the mechanism. Otherwise, you can do any question with the help of this fundamental thing, that the relationship they are going to hold, because it holds a lot of weightage, that is a tautomer. But those who are interested in the mechanism, those who want to go in detail, just show me the hearts or the thumbs up or the fire in the chat section. Yes, everyone is ready. Everyone. Now see, to understand tautomerism, we should know acidic alpha hydrogen atoms. To understand tautomerism, we should have knowledge of, acidic alpha hydrogen atoms. Now see, what are acidic alpha hydrogen atoms? If I draw compound like this carbonyl group is the functional group. This is the functional group. This is your functional group. And the carbon which is directly attached to the functional group is known as alpha carbon. And if this is sp3 hybridized, then its hydrogens will be known as alpha hydrogens. So this compound is having 3 acidic alpha hydrogen atoms. Is it clear to all of you? Now if I draw another compound like this, CH3, C double bond O, CH3. Just see, this compound is having functional group over here. Can you see? This is the functional group. Now on its right hand side, this is directly attached with this carbon, and the left hand side, this is directly attached with carbon. This is also alpha, that is also alpha. It is having 3, that is having 3. So 3 plus 3, it is having 6 acidic alpha hydrogen atoms. Now if I write compound like this, the compound is given like this: CH3, CH2, CH double bond O. You can see this is your functional group, this is your functional group, and adjacent to it, this carbon is attached to acidic alpha hydrogen atoms. I hope this is clear. If this is being clear to each and everyone, then I will give you questions and then try to find out whether the compounds are having 2, 3, 4 like that. What is the number of alpha hydrogen atoms are being there? Are you ready? Everyone, are you ready, kids? Are you ready? Those who are new, please hit the like button. That's Baba's humble request. Make it 350. Let me see. Like should get increased. Now, question for you. Question for you. Question is, find out number of alpha hydrogen atoms. Compound is here. Here is compound. And you're supposed to find out number of alpha hydrogen atoms. Number of acidic alpha hydrogen atoms. So let me give you compound. Formaldehyde, H, C double bond OH. I want your answer fast. First, second, benzaldehyde. 2 compounds I have given. Just find out number of alpha hydrogens. I want to see answer in the chat section. 0, 0. Very good. 0, 0. Now, if anyone is not able to understand why in benzaldehyde this is being 0, just see to it. The carbon's valency is 4. This carbon's valency is 4. 4 valency. Just see 4 valency. So no hydrogen is there. Now, if I write down third compound, just see to it. Third. Now, in the third compound, how many acidic alpha hydrogen atoms are there? Just I want to see how many acidic alpha hydrogen atoms in the third compound. I'm here. Just tell me how many acidic alpha hydrogen atoms are there. Very good, kids. You are rocking. Someone is writing 9. No. If anyone is saying that 9, that's a wrong answer. 9 is wrong. Cut it. See, this is the functional group. This is the functional group. And directly attached carbon is this. This is not having any alpha hydrogen. They are beta. They are being beta. So answer will be 0, 0. Everyone able to calculate? Everyone is able to calculate now, my dear friends. This much is clear to all of you. Now, see. Tell me number of acidic alpha hydrogen atoms in this compound. This is your compound. Do let me know how many acidic alpha hydrogen atoms are there in this compound. Because little knowledge is always a dangerous thing. We should have proper and clear knowledge to get the rank. So, first of all, do let me know how many acidic alpha hydrogens are there. So, if your answer is 2, that is absolutely wrong, kids. Examiner will give you big 0, big 0. Why? See, I've told you that this is the functional group, right? Functional group. This is alpha carbon, right? But this is sp2 hybridized. These hydrogens are vinylic, not acidic. These hydrogens are vinylic. They are not acidic. They are alpha. They are alpha, but not acidic. But not acidic. Vinylic are not acidic because I've told you this carbon, alpha carbon, must be sp3 hybridized. If it would have been sp3 hybridized, then only the hydrogen would be the acidic. Otherwise, sp2 hydrogens are not acidic. Clear to all of you? Is it clear to all of you? Carbon's valency where? Oh, 1, 2, 3, 4. Okay, sorry. So carbon's valency is 5. Let me draw another one. You are right, kids. Okay, see. Now, this is the compound. I missed one carbon. This is the compound. Now, this is not alpha. That is alpha now. The alpha will get changed. Now, this is alpha. That is beta. Once again, you can see they are both are sp2 hybridized. There is 0 alpha hydrogen acidic. No acidic alpha hydrogen atoms. No acidic alpha hydrogen atoms. Got it, kids? Is it clear to all of you till now? So the alpha carbon must be sp3 hybridized. It's clear to all of you? Now one more question I am going to give you. Just try to find out. Just try to find out. This is the compound. Now how many acidic alpha hydrogen atoms are there? Give me the answer. How many acidic alpha hydrogen atoms are there? I'm waiting for your answer, kids. Fast, fast. How many acidic alpha hydrogen atoms are there? Kids, fast. 6. So let me know. This is the alpha carbon. It is having 1. These are alpha hydrogens sp3 hybridized. So 1, 2, 3, 4, 5. Answer is being 5. Am I right, kids? Agreed or not? Everyone agreed or not, kids? Do let me know. Is everyone agreed? Now if I draw compound like this, another compound like this, see how many acidic alpha hydrogen atoms? Do let me know. How many acidic alpha hydrogen atoms? Everyone do let me know how many acidic alpha hydrogen atoms. Fast kids. 6. Yeah, very good. Fantastic kids. 6. 1, 2, 3, 4, 5, 6. Fantastic. 6 alpha hydrogen atoms. Fantastic. Now see kids, I'm going to give you questions which have been already asked in number of examinations, whether I talk about NEET, JEE, AIMS or IIT. Just see to it. Kids, this time the syllabus of NEET got reduced, so definitely the level of IIT, they can give you the questions in your examinations. So IIT and NEET, both same chemistry will come. Now see kids. If I say CH3, C double bond OH, this is your compound, and OH negative if we add OH negative. Now OH negative is a base, this is a base, and this is in need of acidic H. This hydrogen is acidic. So OH negative will say, hey hydrogen, I want to take you. So compound will say, yes, take him, let it go, and this carbon will develop negative charge. If I want to take your pen, if you're comfortable in giving that pen, you will say yes, you can take. And if you're not comfortable, then you will not give me that pen. So why carbon is comfortable? See, carbon has donated its proton and that has become carbanion. Now this is happy. Why it is being happy? Anyone? After donating its proton, it has developed negative charge and the carbon is saying, hey, I will do resonance. I want to come over here. Yeah, come. You shift that side. Now they will do resonance, and this is the resonance. Gets resonance. Electron wants to move. The electron wants to move. This will come over here. That will go over there. And the resonating structure, just see, you will get like this: CH2 double bond CO negative H. These two are being resonating structures. What is the relationship in between these two? They are resonating structures. Only electron is moving. Only electron is moving. Now the proton, the water, because this must have come from NaOH or KOH, so this is saying, I'm the catalyst, just give me back my water. Hey water, just give me back my what? My OH negative. So Na has taken this OH negative and H plus is being left. H plus is being left, kids. Now this H plus will say, hey oxygen, I'm yours. By chance I have gone over there. I want to join you. Oxygen is saying, hey, Ingeva means come over here. I'm yours. So that hydrogen has formed the bond with that, and it is looking like this: CH2 double bond COH and this H. Now see kids, it has been formed like this, and this is the whole mechanism. Now if you compare these two compounds, first one and the second one, just see, can you see what I have told you in the starting, in the beginning, that hydrogen has gone from 1 to 3. It has migrated from 1 to 3, and double bond is there. Can you see? Just see 1 2 3. 1 2 3. Hydrogen has gone to third atom and there is bond in between 1 and 2. That is the shortest fundamental thing which I have told you, kids. Just see to it. And this is the whole mechanism. These two are resonating structures and these two are tautomers. And there is equilibrium in between these two tautomers. Equilibrium. This is a equilibrium. Now kids, experimentally it has found that this is only 1%, even less than 1%, even less than 1%. And the equilibrium is shifted toward this side, this form. This is known as keto form. Right now it is aldehyde, but the general term is used keto form. This is more than 99%. So remember that. Thermodynamically, it has been found that this CO bond is more stronger. The bond stability of this is more stable bond. Actually, how they have calculated, see, number of bonds involved. One carbon hydrogen is breaking, one this bond is breaking, and this bond is getting formed. 3 bonds of that and 3 bonds of that. They have calculated thermodynamically, they have applied thermochemistry experimentally, and they have found that in between these two structures there is difference of 12 kilocalorie per mole, and that 12 kilocalorie per mole was more in favor of this compound. This was having less energy than that, and the one who is having less energy is being more stable. Just like water, ice and water vapors, all three are H2O, but water vapors are most energetic but least stable, and the water ice work form is least energetic, most stable. You know that Titanic once collided with that iceberg, and who was broken? Maximum the Titanic got. So it is all about the stability and energy. So this is more stable form. Have you got it? Till now, is it clear to all of you? Yeah, at 8 I will give you break, kids. I will give you break at 8. So 12 kilocalorie per mole is in favor of this. 12 kilocalorie per mole is in favor of this. And my dear friend, no need to remember this value. No need to remember this value. This is experimentally determined. But this is not that simple. There are some compounds whose enolic form, this is enol. See, double bond in and OH all, made up of two things. Enol, just see. For double bond in and OH is all, enol. There are some compounds whose enolic form is more stable than keto form, and the examiner will ask that. They will ask whose enolic form is more, enolic content is more. Arrange the following in decreasing order, increasing order. For that, I'm going to tell you. But remember that generally keto form is more stable than enol. Let me write down. Let me write down this statement. Otherwise, you will forget what I'm saying. What I'm saying, kids. Generally, whenever somebody is saying generally, I am always true. That means sometimes you are liar. So generally, this word is very dangerous. Generally. So let me underline it. Mark my words. Generally. If something is starting with generally, that means it's fishy. Generally, keto form is more stable than enolic form. But this though everyone knows, then why the examiner is going to ask question? So examiner will ask question based on that which is not common. So but in some cases enolic form is more dominating because of certain reasons. What are those reasons? Because of certain reasons or factors, and we are interested actually in these reasons and factors only. So are you ready, kids? We are interested in these reasons and factors because they only can give us marks and will make us winner. So kids, I was unable to see the chat. Everyone ready? Show me some fire in the chat section. I want to see some fire in the chat section, kids, if you're ready. Have some water, kids. Have some water. Keep yourself hydrated. And if your eyes are paining, just do like this. If your hair is small, do like this. Blink your eyes. Blink your eyes. Take a long breath. And once again, let's set go. Let's set go. Now see, kids. Factor number one. Factor number one. Factor number one. Aromaticity. Aromaticity. If enolic form is aromatic, then the equilibrium will be like this. Keto will convert as a whole into what? Into enol. It will be 99.99%. It will be negligible. See, in Hindi there is one song. क्या से क्या हो गए देखते देखते, वो जो कहते थे बदलेंगे ना हम कभी. In English, the one who was saying I will not get changed, just in a fraction of second you got changed up to that extent that we can't believe. The one who was 99% and the one who was less than percent, that has changed to 99.99%. Can you feel? Now let's see what is this aromaticity. This is done by this aromaticity. Who is responsible? The aromaticity. Now let me give you example of it. Just see to it. Just see. Wait and watch, kids. Wait and watch. Suppose if I say there is one compound like this. I'm having one compound like this. Just see to it. This is the compound. Right now it is aromatic or anti-aromatic. In the chat section, do let me know right now this is aromatic or anti-aromatic. I want to see in the chat section. Is this aromatic or anti-aromatic, kids? Do let me know. Is this aromatic or anti-aromatic? Everyone do let me know. It is aromatic or anti-aromatic. Do let me know fast. Madhu Bala has written non-aromatic. Rest of other students, let me check it out and let me compare who is going to give the correct answer. So, number of kids, they are writing anti-aromatic. The mistake done by you though, the one who is writing anti-aromatic, You have just counted the number of pi electrons. Never first count the pi electron. Just see the planarity. First see the planarity. This is sp3 hybridized non-planar ring. Non-planar ring. And non-planar ring means what? Non-aromatic. Non-aromatic. Now kids, do let me know, is this compound having acidic hydrogen? Answer is yes, sir. It is having two acidic alpha hydrogen atoms. Two acidic alpha hydrogen atoms, right? Now, this will move from 1 to 3. As I have told you, these hydrogens will move from 1 to 3 and the bond will come in between 1 and 2. How it will look like? It will definitely look like this. These bonds like this. One more pi bond will be there and this is a new pi bond and it will convert into OH, and now this ring is being aromatic. Aromatic ring, you can see now this aromatic, and that's why it will whole amount will get changed into that, and a just fraction of second will be in this side. We can say it will be very less in towards this side. So 99.99% is this compound only. Just see. Everyone, is it clear to all of you? Is it clear to all of you? Now see the second example I am going to show you. This is really very important. Just see to it. If I draw this compound, just see to it. This is very famous example, and every examiner try to give this example. This is keto form. How many acidic alpha hydrogen? You know very well, 6 alpha hydrogen atoms which are acidic. So how many times tautomerization will take place? So your answer should be, and should have to be, that 3 times tautomerization. Am I right, kids? It will undergo thrice tautomerization, 3 times. Thrice tautomerization, and all the hydrogens, how they will move? 1, 2, 3. 1, 2, 3. 1, 2, 3. So the hydrogens will move like this, in this way. This hydrogen will go over there, so bond will come over here. This hydrogen will go over there, so the bond will come over here. This hydrogen will go over here and the bond will come over here. So what you are going to get? Definitely, kids, you will get compound like this. The generation of aromaticity, and this will be your product, my dear students. Am I right? Then show me some fire. That yes sir, absolutely correct. And this is aromatic, and once this is aromatic, so it will be 99.99%, and this compound's name is fluoroglycinol. Fluoroglycinol, and this is being aromatic, and that's why it is like this. Now after this, I will give you one example and that will change your vision. But before giving that example, let me know if till now it is clear to all of you. It's 8 o'clock, but let me give you one example. After that, I will give you a break. Okay. So if you're ready, if you have got it till now, then only that example means, because that is rank deciding example. If you are not able to understand till now, then that is not of any use to give you that example. If it is clear till now, then only I am going to give you. Yeah, I can see the fire in the chat section. That is indicating that it is clear to all of you. Now see, this is going to be the rank deciding example. Rank deciding example. Rank deciding example. Now just see to it, everyone. This is your example. See it properly. See to it, everyone. What do you think? Everyone just see to it. Everyone just see to it. What do you think? Its keto form will be more stable or enol, or it will not show tautomerism, or will show tautomerism? Will it show tautomerism? First question is, will it show tautomerism? Will it show tautomerism? This is the first question. Will it show tautomerism or not? What's your answer? Yes or no? I want to know yes or no, kids. Will it show tautomerism or not, kids? Let me check it out in the chat section. What's your answer? Will it show tautomerism or not, kids? Everyone, I'm waiting your answer. Waiting for your answer. Everyone. Okay. So everyone is saying yes, it will show tautomerism. So I want to make it more clear. Let me say these are maroon hydrogens and these are yellow hydrogens. Which hydrogens will participate? Maroon or yellow? Maroon or yellow? Which hydrogens will participate? Maroon or yellow? In the tautomerism, which hydrogens? Yellow. Oh my great. Oh my God, kids. You are great. Really great. Fantabulous. Marvelous, kids. Stupendous performance. Oh my God. Oh my God, kids. Really, you have proved it. That you are genius. Now, this hydrogen, yellow hydrogen will move. This is allylic. Allylic hydrogen loosely bonded. Allylic hydrogens. You can say allylic hydrogens, or you can say acidic hydrogens, or you can say whatever. Now these red ones, maroon ones are vinylic hydrogens. Vinylic. Strongly bonded. Vinylic are strongly bonded. Strongly bonded. And these yellow ones are allylic, loosely bonded. Loosely bonded. Fantastic, kids. Loosely bonded. Now this hydrogen will move. This hydrogen will move 1, 2, 3. From 1 to 3, it will show direction. Its movement will be 1, 2, 3. Let me take another color. Another color. Yeah, this is fine. 1, 2, 3, it will move. And in the same position, the bond will move in between 1 and 2. So it will look like, let me take another page, or should I draw it over here? Let me make it over here. So it will be like this. The bond will come over here and the hydrogens. Now which hydrogens are acidic? These are acidic. So this hydrogen will move from 1, 2, 3. So it will move from 1 to 3. 1 to 3 it will go, and the double bond will come in between this. Just see, this was the tautomerism. It was moving that side. Now this hydrogen will go at 3 and double bond will come in between 1 and 2, and the equilibria will go more towards the right hand side because it has gained what? It has gained aromaticity. And see, finally I would like to say this is aromatic, and aromatic will be 99.99%. Now let me tell you one thing. Just see the journey. This hydrogen has grown from here to there. If I count 1, 2, 3, 4, 5, that means from this position it has gone to the 5th atom. And this is an example of Pentad system. Which system? Pentad system. Remember that I have told you, Pentad system. Pentad. Have you got it, kids? Everyone got it? Do let me know everyone got it. Now I'm going to give you one break, short break. Are you ready for the break? Sir, yes, sir. Of course, why not? We are ready. Till now, you enjoyed it, kids. Do let me know after this. I will tell you more factors, and after that, GI and then optical isomerism. Kids, optical isomerism and GI, they are the backbone of this isomerism. So we cannot skip it. You have to remain energetic, and you need to have dinner and do it properly. Don't eat too much, otherwise you will feel sleepy. I'm to not going to eat anything. I will take some fruits or whatever the thing. So I want to be energetic. But kids, take care of yourself. And let me love from Telangana. Thank you. Thank you. Oh my God. Kids, first I want to see your promise. Then only I'm going to give you a break. Will you be that much energetic, and will you come with the same energy? First, make a promise. God promise, Brahma's promise, Vishnu's promise. I want to see promise. First, I want to see promise, kids. Everyone, you will come with the same energy, and I'm giving you break. Break. Short break. Break to get ATPs. ATP means form of energy, and right now it is 8:10. 8:10, from 8:10 to 8:10 to 8:40. Okay. Okay, 30 minutes break. We will meet at 8:40. Is it clear to all of you? We will meet at 8:40. Clear, kids? Show me some thumbs up if you got it. Okay, kids. Okay, we will meet just after a short break. Yeah, this is the dinner break. Yes, kids, dinner break. Okay. Hey kids, welcome back. See the punctuality of Baba HSP. Once again, welcome you back to yours Unacademy NEET English channel. So can you hear me? Can you see me? Once again, do let me know. Baba is very punctual. I want to see in the chat section the fire, full on energy. Once again, yes, do let me know, my dear friends. If everyone is with full on energy, once again, I want to see that yes, you are with energy. And see kids, I have not eaten. I have not taken dinner because I will feel sleepy. Then who is going to teach? So Baba has not eaten anything. The break I have given to you just to have something. So end game batch is here. Avengers, are you there? All my fantastic, super awesome students are there. And game batch students, you have to make a promise that you will remain up to the last. How's the Josh? Everyone, Josh is high. Do let me know. Oh, from Jaipur, welcome. Welcome to all people from Pink City. I welcome you to this channel of Unacademy Avengers batch. All students, those who are preparing for NEET or for IIT. Now, after completing this Tautomerism, Baba will let you know about the GI, optical and conformational. So I want to see the Josh once again in the chat section. All NEET endgame students, all IIT students, all students from the Pink City, whether you are preparing for NEET, now that's NEET, or IIT, NIIT, that's NEET and IIT, new name, NIIT, that's NEET and IIT. Yeah, so Baba is going to start with. Now see, the factor number 2. The first factor I have told you, the Tautomerism. In the Tautomerism, the first factor I have told you kids, that the enol, if the enol is aromatic, this was the Tautomerism topic is going on in the isomerism. Those the kids who have joined right now, let me tell you, isomerism is going on in the isomerism, complete isomerism. I taught about the structural isomerism. The part which is in continuation, that is being Tautomerism. After Tautomerism, I will start stereoisomerism. So those who have not gone through the structural isomerism, no worries. You will be able to understand GI and OI because there is no connection of GI and OI with structural isomerism. So everyone will be able to understand. So is everyone ready? Ready. Now, let me move ahead. Now see kids, Baba is going towards factor number 2. Factor number 2. So let's see what is the factor number 2. Factor number 2, just a second kids. Factor number 2 is active methylene group. If compound is having active methylene group, active methylene group, then remember that its enolic content will be 76% to 99%. its enolic content will be in between this. That means more than 50%. More than 50%. So if the examiner is asking whether its keto content is more or its enolic content is more, so definitely you can write its enolic content is more, because that will be more than 50%. So let's see what is this active methylene group. Now we are interested in knowing what is this active methylene group. So let's see what is this active methylene group. My dear students, let me tell you the active methylene group. Let me add some slides, kids. Let me add some slides. So kids, how to find out active methylene group? So everyone ready to find out active methylene group? Just see. If we are having compound with CH2, and this CH2 is surrounded by C double bond O R, C double bond O R. So this CH2 will be known as active methylene. Active methylene. Now question arises, why this CH2 is known as active methylene? What is there? Why it is known as active methylene? So one thing is that you can remember that the CH2 which is surrounded by carbonyl group, two carbonyl groups, that is known as active methylene group. One is the cramming part and another is being the knowledge. So with both the two ways I will let you know. Now my dear student, what should be R? R can be hydrogen alkyl or aryl. Aryl. Now why this is active methylene? Let me tell you. If this proton is being eliminated out, means if it is going to donate this proton, then the compound will look like this. R, C double bond O, CH negative, C double bond O, R. This hydrogen is highly acidic hydrogen. Highly acidic, and that's why it is known as active methylene. See, just see, this negative charge is pulled by this minus I. This is having minus I. This is withdrawing this electron. So the charge is getting decreased, and that is also withdrawing this electron through minus I. Two minus I groups are decreasing the charge and they are increasing the stability. And second thing is that this is doing resonance. Just see, this is doing resonance with this, and this is doing resonance with this also. Left hand side also resonance and right hand side also resonance. So stabilized by resonance, SBR. What is the full form of SBR? Stabilized by resonance. So charge decreased very much. So this conjugate base is highly stable. Conjugate base is highly stable, and the one whose conjugate base is stable, that acid is highly acidic, and that's why it is known as active methylene. Till now this much is clear. Now let me tell you why the enolic content is more. Just wait. See, if this much is clear, why this is known as active methylene? Show me the green signal. You have forgotten the criteria, kids. I have told you one thing. Once the things are clear to you, show me thumbs up or the hearts or the fire. That should not get stopped. Now see, kids. Let me take the favorite example of any examiner. Just see, R, C double bond O, CH2, C double bond O, R, and this hydrogen is moving from 1, 2, 3. It is going towards third carbon atom. It will go over there, and this double bond, pi bond, will come over here. So its enolic form will look like this. See how its enolic form will look like. R C double bond O C H double bond C O H R. Now kids, just see, this form is just 24%. Experimentally it has been found, and this is 76%. Now why is this? Let me tell you kids. This was the pi bond, and this is the pi bond. In between these two pi bonds there are two sigma bonds. So the keto form is having any resonance? The answer is no. Keto form is not having any resonance. No resonance. No resonance. Now here see, this is pi bond, sigma bond, then pi bond, and then lone pair. Can you see the conjugation is from where to where? This is having resonance from this place to this place. This much of the resonance is having. See, pi, sigma, pi. This is known as conjugated system. Then once again pi. This is known as extended conjugation. When you purchase any vehicle, they give you warranty, and they say that give some more fund or rupees, we will extend it. Means 2-year warranty will get converted to 5 years. Extended warranty. So this is stabilized by extended conjugation. Enolic form is stabilized by which word we are going to use? Extended conjugation. Means here to here conjugation, and that conjugation got extended. Extended conjugation. Extended conjugation. Extended conjugation. This is the dominating factor. This one is being the dominating factor. Now the second factor is less dominating. You can see something, you can smell something, you can sense something, that oxygen and hydrogen, they are forming bond. This type of bonding is known as intramolecular hydrogen bonding. So chelate formation. Whenever cyclization due to intramolecular hydrogen bonding, this is chelate formation. Chelation, that is intramolecular hydrogen bonding. Intramolecular hydrogen bonding. So these are the two factors which are responsible for this. Now when this is going to be 99% and when this is going to be 77%, when this is going to be 76%, I will let you know each and everything. But I hope that this you are able to understand. This is less and that is more. This is just 24% and that is being 76%. Now my dear friends, let me tell you, in this was your compound R C double bond O CH2 C double bond O R. Its enolic content, if I talk about its enolic content, my dear friends, then I would like to say, first point, if both are phenyl, see, if they are phenyl this side and that side, this side and that side, that means this side or that side, then the resonance will be over the entire ring. Then its enolic content will be 99%. Second point, if one R is phenyl, then it will be 90%. Experimentally determined, if both are hydrogen, then it will be 77%. and if both are alkyl, then it will be 76%. No need to remember these percentage, but you can say one thing for sure, that they are more than 50%. That means in all these forms, enolic content is more. No need to remember the percentage, enolic content is more. If this point clear to all of you, show me some fire in the chat section that yes, so this point is clear, that we got it. So these are the two factors where enolic content is more, and you have to remember this. Then I will let you know questions, so what type of questions they have asked in IIT JEE and NEET. All my dear students, if this much is clear, show me some fire in the chat section. Yes, that's really awesome, really awesome. Everyone is able to understand. Fantastic. Jesse is there, everyone is there, all my dear students are there. Madhu is there. Now my dear student, just see one note. Let me tell you one note. This point to be noted, my lord. Very, very important point. Esters do not tautomerize. Do not tautomerize. Or in other words, you can say, one ester out of 1 million esters, out of 1 million esters, do undergo tautomerization. Do undergo tautomerization. Now, my dear friends, if somebody is eating fruits, let's say grapes, that person is having 1 million grapes, and that person has distributed those million grapes to everyone, but only one grape he has given to you, or that person has given to you. What will you say? Rest of the other people, they have got 1 million esters, and you got just one grape. Will you say that you have got something to eat? Or your friend has gone to, say, just to have dinner, and he's saying, oh, let's have fried rice. So one full plate he has eaten and just given one rice to you. Will you say that you have got something to eat? So it's like that. Out of one ester out of 1 million ester do undergo tautomerization. That means we will say that esters do not undergo tautomerization. Now the question arises, $1 million question arises, why is like that? So how many of you want to understand? Just see, this is one ester. Let me take, this is an ester. And OH negative has come, and OH negative is asking, hey proton, let's go party. So if by chance this proton is going along with this OH negative, then this carbon will develop negative charge and it will look like this. Now this carbon got negative charge, and carbon is asking to this carbonyl carbon, hey, let's have resonance. Let's do resonance. I got negative charge. I'm feeling unhappy. But that oxygen is saying, I can't do resonance with you because I'm busy with someone else. This is doing resonance with this oxygen. This is doing better resonance because two oxygens are same, and this is the best resonance. Best resonance. So this is unstable. This is feeling unstable, and it will say, let me go back. I don't want to donate my H. So this hydrogen is not acidic. Not acidic, or I can say very slightly acidic, very slightly acidic, very slightly acidic. So when this is not going to donate proton, it will not tautomerize, and that's the reason esters hydrogens are not acidic or very less acidic. Everyone, if you got it, do let me know in the chat section. Thumbs up if everyone got it, kids. Do let me know. I want to see in the chat section. Now the twist is that if ester is having active methylene group, another note, second point, just see note, second point of note. Second point, my dear friends, second point, ester with active methylene group, ester with active methylene group will undergo tautomerization, and its enolic content will be just think about how much should be the enolic content. What is your expectation? How much do you think that enolic content will be? It's 7%. Now question arises, when esters, they do not show tautomerization, why this ester with active methylene group is showing tautomerization? Let me show you, kids. There is well-known example, acetoacetic ester. This ester, the students who have studied class 12, they know Claisen condensation. This is formed during Claisen condensation. And this ester, let me write down its name, very famous compound, CH3CO, acetoacetic ester. Now this compound is having active methylene group. See, this is active. Why? This is carbonyl, flanked by two carbonyl groups. So this is active methylene group. Now kids, this is already resonance stabilized. See, in between this oxygen and this oxygen there is resonance, so it is already stabilized by resonance. Then why it is converting into enol? Just see why it is being converting into enol. First carbon, second carbon, third atom. So the hydrogen will move from 1 to 3 and bond will come in between 1 and 2. So you will get compound like this, CH3, C double bond O, CH double bond C, OH and R. It is getting benefit of intramolecular hydrogen bonding. That is known as chelation. Chelation is there, and my dear friend, due to chelation, see how many membered ring is formed. Whenever 6-membered ring, 7-membered ring, 5-membered ring, most stable is 6-membered ring, then 5-membered ring, and then 7-membered ring. By intramolecular hydrogen bonding, if this is happening, let it happen. Thermodynamics says that one molecule is forming ring, then change in entropy is approximately 0, but because the bond is getting formed, delta H is negative, delta S approximately 0, delta H is negative, then Gibbs-Helmholtz equation delta G is equal to delta H minus T delta S, that will come out negative. So spontaneous process. See, 1 atom, 2 atom, 3 atom, 4 atom, 5 atom, 6 atom, 6-membered ring due to chelation, and that's why this is undergoing tautomerization. Till now, if it is clear, then I will give you question. Are you ready for the questions, my dear friends? Do let me know. Is everyone ready for the questions? based on tautomerism, what type of question they can ask, what type of questions. So everyone ready? Ready. Now see, question is, first question, which will not tautomerize, which will not tautomerize. Option A, option B, option C. Option D. So what's your answer? I'm waiting for your answer, kids. What's your answer? Very good. I can see the answer given by Twinkle. D. Everyone has given correct answer. D. Fantastic. Kids, you are rocking. Rocking. There is no alpha hydrogen. See, in this compound, there are 4 alpha hydrogen atoms, 4 acidic alpha hydrogen atoms. This compound, there are 2 acidic alpha hydrogen atoms, 2 acidic alpha hydrogen atoms. And this compound, these 2 and these 3, 5 alpha hydrogen atoms which are being acidic, and this is not having 0 acidic alpha hydrogen atoms, 0. Clear? Now, are you ready for another question? Just see to it. Another question. Question is fantastic, awesome question. See, question is, which compound will have maximum enolic content? Maximum enolic content. Which compound will have maximum enolic content? A is CH3, C double bond O, OCH3. B is CH3, C double bond O, CH3. C is CH3, CH2, CH double bond O. D is CH3, C double bond O, CH2, C double bond O, CH3. Yes, I'm waiting for your answer, kids. Do let me know. What's the correct answer? Oh my God, kids, rocking. You people are rocking. Who is giving so fastly the answer? Ramesh, Shubhashri, Samriya, Nikita. Oh my God, Nawab's what? Everyone, kids, salute, salute. You kids are rocking. So awesome. Absolutely correct. See, its enolic content will be 76%. Its enolic content will be less than 1%. Less than 1%, and it should be 0.000000001%. See, this is the order. My God, rocking, kids, rocking. Now another question. This is a bit tough question. I will give you all type of questions which can be asked in your examination, or which would have been asked in your examination. Just see. Arrange, this is tough question. Arrange the following in decreasing order of their enolic content. Take care, okay? Their enolic content. So A is CH3, C double bond O, CH2, CH double bond O. Take care. This question is bit tough, okay? B is CH3, CH2, COO, C2H5. C is D is CH3, C double bond O, CH2, C double bond O, pH. pH means phenyl. pH means C6H5 phenyl, or like this. So options I am giving you. I am giving you options. A option, B option, C option, D option. Let me write down. A, B, C, D. C, A, B, D, C, D, A, B, B, A, C, D. Just see to it. Kids, who is there? Who is giving fantastic answer? Ravi Kumar, Jesse, Umesh, Karishma. Oh my God. Pranam, Pranam, kids. Your rank, I can see your rank. You kids are rocking. Kids, you kids are really rocking. Oh my God. It's really fantastic. Now, this is absolutely correct answer. Why? See, this is flanked by, means its enolic content will be 76%. Its enolic content will be ester 0.000000001. It will be 99.99%, and it will be 90%. If you have solved this question, that means you can solve any question. If you have solved this question, that indicates that you can solve any question of the world. My dear friends, really. Now, how many of you got the correct answer? Dhanvant Raj Bond. Have you got the correct answer? Kids, the one whose answer is correct, show me the thumbs up. I want to see thumbs up. Those who have got the correct answer, their answers is being correct. Now, something, let me tell you about tautomerism, then I will come to GI. Okay, see, some compounds and their tautomerism. Some compounds and their tautomers. Some compounds, some important compounds with their tautomers. With their tautomers. Just see, some important compounds with their tautomers. Once this question was asked, urea, will it show tautomerism? Now, no teacher was teaching whether it will show or not. So kids, just see to it. This hydrogen is acidic because its electronegativity is 3.0, and this is adjacent to this. If it is losing proton, this will get resonance stabilized. If this is losing proton, this negative charge will do resonance. So it will convert into like this. NH2 COH double bond NH, and these two forms are known as urea and isourea. This is urea, this is isourea. Now let me tell you another compound. If they are going to give you compound like this, CH3 CONH2. Now see, this is alpha acidic, that is also alpha acidic. Acidic hydrogens, this side also, that side also acidic hydrogen, but its electronegativity is 2.5 and its electronegativity is 3. This is more electronegative. So more electronegative means size is approximately same. Carbon and nitrogen size is approximately same. So negative charge is more stable on more electronegative atom. Negative charge is more stable on more electronegative atom. Now see, this will go because size is same. This I am telling you because size is same, that's why I am telling you. Otherwise negative charge is more stable on bigger atom. Now see, CH3 COH double bond NH, this was amide, so this is known as amido. This is known as amido, and that is known as imido. Imido. So they can ask you amido and imido. Can you see amido and imido? Now, so this is all about tautomerism. I've told you each and everything about tautomerism, my dear students. Now we are going towards stereoisomerism. Let's welcome stereoisomerism, the GI and OI. I am going to tell you, kids. Let's welcome our hero of stereoisomerism. Stereoisomerism. This is also known as space isomerism. So we will divide it into two parts. First part we are going to deal with. The one is configurational isomerism. And under the category of configurational, there are two: GI, geometrical isomerism, and optical isomerism. And then I will teach you what? After this, I will let you know conformational isomerism. After that, I will let you know at the last conformational isomerism. Conformational is easy, kids. Not that much tough, but you can't ignore GI and OI, geometrical isomerism and optical isomerism. That requires visualization. Basically, let me tell you, categorically I'm telling you that optical isomerism is more demanding, and maximum number of questions they are going to ask from optical isomerism. GI is a bit easy, not I'm saying that much easy, but a bit easy. But optical isomerism requires a lot of visualization. So are you ready for that, everyone? Is you? Yes, kids. Now see, let me start with geometrical isomerism. Geometrical isomerism. Geometrical isomerism. See, for this, what is required? You must have studied geometrical isomerism simply in alkenes, but I will teach. Let me tell you the way or the flow, what things I will cover in this, so that you should know what things I am going to cover in this, because that is very, very important. First, I will let you know in alkenes. Then I will tell you in cycloalkenes, then in cycloalkanes, then I will tell you in the AJA system, in AJA, or you can say, leave this, that combined of all these things and EZ system, E and Z system. This is very, very important. Without this EZ system, you can't even understand what? The optical isomerism. So this is required for both optical isomerism as well as GI kits. Okay. So this is my flow, and I will let you know in this direction each and everything. Okay. So I hope that everyone is ready. Everyone is full of energy kits. So let me start with alkene. And before that, let me tell you one more thing. Here, allenes also, allenes, GI in allenes, this is also important. So fifth and sixth, these are the 6 types of GI which I am going to discuss right now. I will tell you each and everything in detail. So I hope that everyone is ready. Now see kids, just see to it. GI in alkene, GI in alkene, GI in alkene. Now question arises, why alkane does not show? This alkene can show, may show GI. Why this alkane can never show GI? What's the reason? Why alkanes do not show GI? Now see, the alkanes, they have single bond, and single bond has free rotation. If I say kids, if I say that I am having this single bond, can you see? This is free to move. So always single bonded compound, they will show conformational isomerism. They have no restricted rotation. They are free to move. Bond is free to move. Bond is free to move. No restriction is there. No restricted rotation is there. No restricted rotation is there. That means I can say there is symmetrical geometry. Symmetry is there everywhere. Now, if you see this alkene, this is the pi bond, and the pi bond is like this, above the plane and below the plane, and they are bonded like this. Now, if I say kids, if I say there is CH3, there is hydrogen, there is hydrogen, there is CH3. If you want to rotate the whole compound, see, if I get rotated, am I got changed? I am the same HSP, can you see? I am the same HSP. I am the same HSP, can you see? Same HSP. But what if anyone can do, I remain like this and somebody is rotating my head, the eye should go at the back side and I should remain this side. Everyone will start saying, oh, what is this? What happened? Some ghost is there. So my dear students, if you rotate the whole compound, it will look like this. H will come over here. H will come over here, CS3. The same thing. 2 hydrogens are on same side. This is cis. That will also known as cis. Nothing got changed. So they are not GI. But if you keep this one fixed, and if you're going to rotate that, if you want to rotate that, for example, if you keep me fixed and if you want to rotate my hand, so see, if anyone keeping myself fixed, and if he is trying to rotate this hand little bit, you can rotate, but 360 degree if you want to rotate, pain is there, too much pain. And if by chance, if anyone applying too much force, then my hand will be in broken condition, right? So kids, if by any force, if you want to rotate it, this pi bond will remain vertical like this. One pi bond will remain vertical like this. Right now they are like this, they are forming bond. They are forming bond parallel to each other. But if you fix one and rotate another one, their bonding will break and no one wants to break the bond, because in that form they will feel energetic and stability will get lost, because pi bond is parallel bond, sidewise overlapping, and if this is going in this plane and this is in this plane, pi bond will break, and by itself at the room temperature they are not going to do that. Any chemical can do that. If you heat that, they can do. That's why doctor always says keep your medicines away from sunlight, from chemicals, because the cis form can get converted into trans form, or dextro can convert into levo, and they will be not metabolically active, and then they can give you pain or sometimes death also. Everyone, is this point clear to all of you? Is this point clear to all of you? So pi bond, due to pi bond there is restricted rotation. Due to pi bond there is restricted rotation. Due to pi bond, restricted rotation is there. So if anyone is going to ask why this compound cannot convert into cis or trans cannot convert into cis. Now my dear students, this is different from this and this is different from that. Let me come to the next page. This I am going to explain. So what condition is required if the double bond is there? Two conditions are necessary. Two conditions are necessary to show GI. To show GI. Number one, presence of double bond, presence of olefinic bond, second thing is required, each sp2 hybridized carbon must be attached with different atoms or groups. This is $1 million point, and I'm going to focus on this. Is everyone ready? This is $1 million point, and let me focus on this point. This point is very, very important, kids. Very, very important. Just see to it and let's try to understand it. Let's try to understand it. Just see. If I say this is double bonded carbon, it is having valency like this because it is sp2 hybridized 120 degree. If I say there is A, and if there is also A, this sp2 hybridized carbon is attached with same atoms, these atoms are being same, it can't show GI. It can't show GI because two atoms are same. Now, if I give you another compound like this, if I say here is A, here is B, could you please let me know this compound can show GI? I have seen that these two atoms are different, but the definition is saying each sp2, each means both of them. If I write here D and D, now they are same. It can't show GI. It can't show GI. Are you getting my point? In this, these were same. No need to consider that. They are different, but they are same. So can't show GI. In this condition, if they can't show GI, we will say that double bond is dead. Double bond is dead. I will use this term. Double bond is dead. What do you mean by dead? If any father says, hey, my son, you are dead for me. That means that son is not dead for everyone, that for him only. Okay, in movies you must have seen this dialogue. So this double bond is dead to show GI, can't show GI. So for with respect to GI, it is dead. Now my dear students, if the compound is like this, just see, if the compound is being like this, C double bond C, if I say here is A, here is B, here is D, here is E, what do you say? Will it show GI or not? Will it show GI or not, my dear friend? Do let me know if you are able to understand. Do let me know. Will it show GI or not? I want to see in the chat section. Will it show? Yes. Very good. Victor, very good. It will show GI. It will show GI. Why it will show GI? These two are different from each other. These two are different from each other. Now, if another question, if I ask that C double bond C, if the compound is like this is A, this is B, and this is also A, and this is B, will it show GI? Will it show GI, kids? Do let me know. Will it show GI? Everyone do let me know. Will it show GI? Yes, it will show GI because this is different from this. And that is different from this. This is different from this. It doesn't matter what is the relationship of these atoms with those atoms. No relation or the same relation doesn't matter. Nothing to see with these atoms with those atoms. They can be same, they can be different, but you have to see these should be different on this sp2. These two atoms should be different, or group should be different, and on this sp2 they should be different, right? Now let me give you question. If you are able to understand, then you can do question. See, question is, which compound will not show GI? Which compound will not show GI? A is B is C is D is yes. Your time starts now. Do let me know, everyone. Some are writing A, some are writing, most of these students are going for A. Kids, this was really good question. Maximum students are going for A. Very few, oh my god, more than one also. See, kids, this question once again I will ask. I'm not going to tell you the answer. I'm going to give you one logic. In front of God, if you have added two candles, one is still burning, one got, means it has fallen down. Now God is able to see the light or not? Even one candle is sufficient to show the light. If in your room there are 6 bulbs, if only one bulb is working, rest of the others are not working, can you see the light? Yes. So the logic is, If you see this double bond, this is dead. Why this is being dead? Because these two hydrogens are same. So this cannot show GI, but you see there is one more double bond, and in this, with respect to this double bond, this methyl and this hydrogen, they are different. They are different. And on this carbon, there is one long chain. This long chain is attached on with this carbon, and another one is hydrogen attached. Both of them are different. So this is active, and this will show GI. This is active. First point is clear to all of you. Do let me know. First point is clear to all of you. Kids, do let me know. Is this point clear to all of you? So here, these two are different. They are different. So this is active. Now you got the answer. Everyone is writing. Now here, this is dead, but this is active, because all of them, they are being different. This is different from this. So this is active. This is dead. But here, this is dead, they are being same, and that is dead, they are being same. So this is the answer D. How many of you are able to understand? This was really a nice question for both JEE as well as NEET. Anywhere, anyone can ask. Show me some fire in the chat section if you got it. If you are able to understand it, I want to see some green signal in the chat section. Kids, keep yourself hydrated. Have some water. Have some water. Have some water, kids. Fantastic. Fantastic, kids. Fantastic. Okay, that's really fantastic. Now, my dear students, before moving ahead, let me tell you cis and trans. Now, if you see this compound, now everyone will ask, this compound will show GI? Yes, it will show GI. Now, how many forms? It will exist in two forms. It will exist in two forms. What are these two forms? One form is CH3, CH3, and another form is CH3, CH3. So people call it this form. People will say because both hydrogens are on same side, here they are on different sides, so they will call it cis, and this form trans. Now both are talking with each other. Hey, who are you? Do we have any relation? Do we have any relation? Are you my brother or my sister? They are talking like this. So they are saying, oh no, we are having same name, butene. Our father is butene. Both of us are butene. Only the arrangement in space is different. Your two methyls are on same side. Here two methyls are on different side. That's why we call trans and we call as cis. So we are GI. What relationship we are holding? We are GI. And remember that. Are they mirror images of each other? What do you think? These two are mirror images of each other? Do let me know. Are they mirror images of each other? The answer is no. They are not mirror images of each other. They are not. They are not mirror images of each other. They are not mirror images of each other. So always remember that, my dear friend. The point which I am going to tell you holds a whole lot of weightage. This point is really very, very important. The stereoisomers which are not mirror images of each other, they are known as distereomers. What I'm saying, let me write down the definition over here, then I will come back. Let me write down the definition over here because this is very, very important point. All those stereoisomers which are not, because this is the mistake most often, most of the students, they are doing this mistake. All those stereoisomers which are not mirror images of each other are known as distereomers. What I'm saying, kids, are known as distereomers. Distereomers. Remember, mark my words. Very, very important. Distereomers. And remember one more point, kids. All GI are distereomers. But all distereomers need not to be GI. My dear friends, why I'm telling you this point, very, very important point. Why I'm telling you? Because 99% students, they think that distereomers are in optical isomerism. They have just studied in optical isomerism only distereomers. But my dear students, remember my point, remember my words, mark my words. Categorically, I'm telling you this particular thing, that all GI are always distereomers. Or you can say all those stereoisomers which are not enantiomers are always distereomers. No, you must get confused. Let me write down this point also. See how many points I'm going to tell you which holds a hell lot of weightage. See, kids, this point is $1 million point. All the exams, they are going to ask this point. All stereoisomers which are not enantiomers. Now, what are enantiomers? Enantiomers you will study in optical isomerism. All stereoisomers which are not enantiomers, are distereomers. So this point is very, very important point, kids. Mark my words. Keep it in your brain. Always remember it, that this is $1 million point. This can make you win the race. Now, so all GI are always distereomers. Now, let me move ahead. So everyone, now see, if I ask you this compound, if I'm giving you this compound CH3, C2H5 and chlorine, what do you think? Is this cis or trans? Is this cis or trans? Or cis-trans is not defined. This is cis. First option cis. Second option trans. Third option cis-trans is not defined for this. Cis and trans is not defined for this. Is not defined for this. Which option will you mark for this option, this question, kids? Yes, very good. Who is this? Prithvi Raj LP. Fantastic, fantastic, Prithvi Raj. Your answer is absolutely correct. That This is the answer. Will show GI, but that GI will be named as E and Z type. E and Z type. But I will come to this point later on. Before telling you each and everything about alkene, I will come to E and Z type of GI later on, right? Now, my concern is that if in a compound in alkene, because we were dealing with alkene, if in alkene there are more than one pi bonds, multiple active bonds, then how many GI will be there? Because the examiner will ask you question that how many GI are possible for this compound. So are you ready for that? Calculation of number of GI, formula to find out how to calculate total number of GI in multiple double bonds. So kids, one thing I have told you, that formula increases the speed but has nothing to do with accuracy. So how many of you want to see the accuracy as well as speed? I will tell you first the accuracy, the visualization, and then I will give you the formula to increase the speed. I want to see some fire in the chat section. I'm going to give you both. The accuracy means the visualization. We will deal with visualization. We will deal with visualization. First we will visualize and then formula for speed. Remember that formula is only for speed. Formula for speed. Formula for speed. Yeah, my dear friends, that's really awesome. That's really awesome. Now let me see how many likes are there. More than 350 or less than 350? Let me check it out. 374. Let's make it 400. Okay, now see kids. Suppose if I say this is the compound. This is the compound. And do let me know, this compound will show GI or not? Will it show GI or not? This is the compound in front of your screen. Do let me know, will this compound show GI or not? First, let me check it out, whether you are able to understand or not. Will this compound show GI or not, my dear friend? Do let me know. Many students are writing no. See kids, this double bond is dead. Why it is being dead? Because these two are same atoms. This double bond is also dead. Why this is being dead? Because two hydrogen atoms are being same. But if you see this is being active. This is being active. Why this is being active? If I show you, it is like this, and CH double bond CH2. CH double bond CH2. Just see on this sp2 hybridized carbon, these two are being different, and on that sp2 hybridized carbon, these two are being different. Am I right or wrong, kids? So will show GI. You got failed? You got failed or not? Got it? Very good. Now the chat is started running. Always keep on writing so that I can understand whether you are able to understand or not. Now see, my dear friends. Case number one. Case number one. Case number one. Case number one. This case indicates when terminal atoms, atoms or groups are different, when terminal atoms or groups are different, number of double bonds can be even or odd. Number of active double bonds can be even or odd. When terminal atoms groups are different, then total number of GI will be equal to 2 raised to power whole n, where n is number of active double bonds. Now, my dear friends, let's see the meaning of this. Is everyone ready? Is everyone ready to understand how to see to it and how to apply the formula, this formula? Now see, kids, try to understand it. If I write down this compound like this, CH3, CH, proper attention must be applied, then only you can understand. CH, double bond CH, and if I write down C2H5. First of all, everyone just see these two double bonds, both of them are active, or one is dead, one is active. Just see this double bond, first double bond is active or dead. So this is active. If I talk about this double bond, this is also active. So just see to it from where to where it is responsible for showing GI. This is from here to here, and its boundary is from here to here. Just see. And whatever is remaining, whatever the part is remaining, this part is remaining, this is R1, and here this part is remaining, this is R2. What do you think? R1 and R2 are same or different? Do let me know in the chat section. R1 and R2 different. So R1 is not equal to R2. Why? Because R1 is methyl, R1 is being methyl, and R2 is being ethyl. They are being different. So this belongs to case number 1. Because in the examination, no one will give you whether it belongs to case number 1 or case number 2. It is only you. You have to find out whether it is case number 1 or 2. Once this thing is clear, you can directly apply formula, but first I will not apply the formula, or let me apply the formula, then I will make it visualize. Okay, just apply the formula. Total number of GI will be, total number of GI will be, apply the formula, 2 raised to power 2, that is equal to how much? 2 raised to power 2 is how much? Do let me know. 4. You got it, the answer you got very speedily. The answer is there, but you haven't understood anything. Now, how many of you want to understand it actually? Just see, this is the compound, and they are talking in the party first form. C, CH3, CH, double bond CH, then CH, double bond CH, and ethyl. So kids, do let me know what you say. Both the double bonds are cis and cis. This here is 2 hydrogens same side, so cis. They are also same side, cis. Any other possibility is there? Just apply maths, a bit of maths. The possibility is that this methyl is saying my hydrogens have gone trans, like see, this hydrogen on this side, that hydrogen has gone on that side. Now CH, CH and C2H5. Now just see to it. This hydrogen and this hydrogen has gone that trans, and these are two same side cis. Another form, this is different because this was CC and this is TC. Now should I draw other two more forms, or you are able to understand? Let me draw it, otherwise you won't be able to understand. Just see. Now I can draw like this: CH3, this is H and H same side. Now its hydrogens have gone different. Now see, this is cis, methyl one is cis, but that has gone trans. Ethyl one saying, oh, my has gone trans. So this is CT. Now the fourth option, these are the three. Now fourth one is, if you are intelligent, you can assume what must be going to happen, that both are going to be trans. Just see to it. This is trans, opposite trans, and that is also trans. These are the four forms. This is TT. Now if I make it fast, because I have taken too much time, let me make it very fast. See, this was your compound CH3, CH double bond CH, CH double bond CH, C2H5. So what I can do, this is, that is, this trans, that trans, this is, but that trans, this trans, but that is. How many are these? 1, 2, 3, 4. 4. So this is the visualization, or you can find out total GI is equal to 2 raised to power 2, that is 4. This is the formula, and this is visualization, which is giving you knowledge. Do let me know the visualization or the formula. If I say visualization is X, formula, no, visualization is V, V for victory, and formula is F. Who is giving you more clarity, V or F? Write down in the chat section. Do let me know which is giving you more clarity, my dear students. Formula or visualization? Visualization. If everyone is, now let me give you another example, then you can clap for it. Another example, just see to it. CH3, CH double bond CH, CH double bond CH, CH double bond CH, and C2H5. How many double bonds are active? Do let me know how many double bonds are active, kids. How many double bonds are active? How many double bonds are active? 3. Very good, kids. You are really gem. 1, 2, 3. From where to where they are responsible for showing GI? This is showing GI. This is showing GI. This is also showing GI. So who is R1? Who is being R2? This is being R1 methyl. This is being R2. Are they same or different? Right now, so we are studying under the category of case 1, so we can understand. But in the examination, no one will be there to tell you whether this is case 1 or case 2, blah, blah, blah. So R1 is not equal to R2, so that indicates this is belongs to case number 1. Now, you can directly apply formula, total number of GI. Two raised to power 3, that is 8. 8 is the answer. Now, if you want to visualize, how can you do that? 3 double bonds. So C, C, C. T T T. C C T. T T C. C T T. T C C. C T C. T C T. How many are they? 1, 2, 3, 4, 5, 6, 7, 8. That's why scientists have gone for formula, because if more than 3 double bonds are there, then how many times they will do CTT, TTC, CTT? They will get confused. That's why they have gone for the formula. Everyone, are you able to understand? You got it? Now, let's see the case number 2. Everyone ready? Everyone ready? But before that, let me give you one question. Let me check it out whether you are able to understand or not. Find out total number of GI. Question is, find out total number of GI. The compound is okay. This is your compound. Tell me what's your answer. Yes. Total number of GI. What's your answer? I'm looking in the chat section. Thank you, Nawab's World. Thank you. Thank you. Now see, kids, I can see your answer. This is dead. This is active. This is active. And this is R1. From here to here, this is R1. And that is R2. It is saturated alkyl. That is unsaturated. So R1 is not equal to R2. So you can apply formula 2 raised to power 2. That is 4 GI. Everyone able to understand? Have you got it? Have you understood, kids? Do let me know. Everyone, you got it? 4 GI. Now, let me take case number 2. Let me take case number 2, kids. Let me add slides. Yes. So case number 2, kids. Are you ready? First of all, do let me know. Is everyone active? How many kids are from NEET Endgame? Show me the thumbs up. Let me check it out. How many of you are from NEET Endgame? Show me the green hearts. Those who are from NEET Endgame. Let me check it out. Fantastic. Now see case number 2, everyone. When terminal atoms or groups are same. When terminal atoms or groups are same, then two subcases arises. Then two subcases arises. Subcase A and subcase B. Do remember, subcase A and subcase B. Just think about subcase A, what it could be. Number of active pi bonds, even number of active pi bonds. Subcase B, number of pi bonds odd. These are the two subcases, and we will discuss these two subcases because this type of question, most of the students, they are getting negative marks in such type of questions. So my dear students, I can see all my dear students. Now see, this is the very important point. Always remember this. So let me enclose it inside the box. This point and that point, they are very two important points. Just see to it, kids. This point and that point. These two are very important case because most of the students, they are making mistake at these places only. So let me tell you, let me show you, let me explain it. Just see to it. If I write down subcase A, CH3, CH double bond CH, CH double bond CH, and CH3. Do let me know how many active double bonds are there in this compound. How many active double bonds? If you are able to understand. So your answer is one active, another active, two active. Let me enclose it inside the box from where it is showing GI. This is showing GI and this is also active for GI. Now what is the remaining part, kids? This is the left part. This is R1. This is R2. My dear students, is R1 and R2 same or they are different? R1 and R2 being same or different? R1 is equal to R2. They are same. Now the formula will get changed. But before showing you the formula, I want to make it visualization. Just see, if I write down over here CC, TT, CT and TC, what do you think? This is first, this is second, but these two are identical. Why they are identical? Just apply your brain. I'm saying these two are identical. Why these two are identical? Then definitely the answer will be because with respect to this methyl, if I say this is trans and that is cis, that side also there is CS3. So these two are definitely identical. So I will say these are like 1, 2 and 3. 1, 2 and 3. Only 3 GI are there. This I am telling you from my visualization. You are able to understand. Now, if anyone wants to apply the formula, I can tell you the formula also. Should I tell you the formula? So see, for this, I'm going to tell you the formula. Total number of GI for such type of compound is equal to 2 raised to power n minus 1 plus 2 raised to power p minus 1, where p is equal to, where p is equal to n by 2, n by 2. And what is n? N is equal to number of active double bonds. Now, my dear friends, let's apply the formula. Total number of GI, just see to it. Two raised to power n minus 1 means 2 minus 1 plus 2 raised to power n by 2. P is equal to n by 2. So 2 by 2 minus 1. So 2 raised to power 1 and 2 raised to power 2 by 2, 1 minus 1, 0. 2 raised to power 0. So 2 plus anything raised to power 0 is 1. That the answer is coming out to be 3. Can you see, kids? This I have applied formula. Which is better way? The visualization should be required. If there is no visualization, if you are not able to understand what the formula you are going to apply, so which is better? The formula is better or the visualization was better? Both are better. Both the two type of things you are required to go through so that you can do all the questions. If you got it, show me some fire in the chat section. I want to see some hearts in the chat section that yes, sir, we are able to understand it. We got it. We got it, kids. Now, second break I will give you at 11. Okay. Second break I will give you at 11. Okay, kids. Now, just see. Sub case number B. Sub case number B. Case 2 sub case B. Case 2 sub case B. CH3 CH double bond CH CH double bond CH CH double bond CH CH3. How many active double bonds are there, kids? Do let me know. How many active double bonds are there, my dear friends? Do let me know. This is active. This is being active. This is also being active. 3. Can I see? Very good. Very good, kids. 3. Now, it will show GI from here to here. Here to here. Its boundary to show GI is from here to here. And its boundary to show GI from here to here. Now, what is being left? This is being R1. That is being your R2. What do you think? R1, R2 are being same or different? Let me find out. R1, R2 being same or different? Yes, kids. I can see. Yeah, very good. R1 is equal to R2. I can see in the chat section. So, now total number of GI formula is total number of GI 2 raised to power n minus 1 plus 2 raised to power p minus 1. Now, my dear friends, this formula is same or not? This I have applied for case number 2 and sub case A, same. But kids, I have done this just to make it easy. Here the value of p is equal to n plus 1 by 2. The p value is different. Now let's apply the formula. Total number of GI kits 3 active double bonds. So 2 raised to power 3 minus 1 plus 2 raised to power. The value of P is n plus 1. N is 3. That means 3 plus 1 divided by 2. This 1 and minus 1. So we will get 2 raised to power 2 plus 2 raised to power 3 plus 1. 4 by 2. 2 minus 1. 1. So 4 plus 2 is how much? 6 is the answer. 6 is the answer. Now, my dear friends, by chance, if you forget this formula, let me tell you something very, very important. Why are they identical? See, this is methyl. One student has asked why they are identical. This is methyl. Left hand side is being methyl, and the right hand side is also extreme of my right hand side. This is also methyl. So two methyls are being same. That's why they are same. You got it? That's why they are same. Everyone got it? Now, let me tell you kids, if such type of question is coming in your examination, then how to crack it? How to crack it? Just see. I'm going to tell you the trick. We have to work smartly. Question is, find out total number of GI for compound is CH3, CH double bond CH, CH double bond CH, CH double bond CH, CH3, and the options given are A option 2, B option 10, C option 8, D option 6. What should be the answer, kids? What should be the answer? Do let me know. Definitely you know very well. This is the answer. Now, no need to apply the formula. Just apply brain. What I'm saying? Just apply brain. Do not apply formula. Why? Why? Kids, ask me why. Ask me why, kids. Ask me why. I will let you know. I will let you know. See, if these two alkyl groups would have been different, if these two alkyl groups R1 and R2 would have been different, then you must have got 2 raised to power 3, 8. 8. But they are same. Right now they are same. So answer will be less than 8. Are you getting my point? Answer will be less than 8. Are you getting my point? Answer will be less than 8. So this can't be the answer and this can't be the answer. 2 have gone. Now it will be less than 8, but it can't be 2. At least more than 2. How it can be 2? So this has also been gone. So what is left? This gone, this gone, this gone. Only 6 is being left. This is known as smart work. If you liked my smart work, then I want to see some green signal, some hearts, some thumbs ups, some fire in the chat section, kids. If you liked my way, this is the way how to crack, how to find out the answer of questions. Wow. Now this is okay. Now I'm going to tell you, after this, Baba is going to tell you GI in cycloalkenes. Very, very important. Very, very important. GI in cycloalkenes. Remember that. Remember one thing very clearly. Cycloalkenes to 7 membered exist only in their cis form. They do not exist, they don't have their transform with respect to double bond. Now this definition holds a hell lot of weightage with respect to double bond, one thing. Second point, they don't have their transform. This is also important. They don't have their transform. So if they are not having their transform, that means they will not show GI. Now question arises, why only up to 7 membered? Why is like that? And why they have only cis form? Why they don't have their transform? We have to give logic. See, let me draw cyclobutane. Then how I will draw cyclobutane? I will draw cyclobutane like this. Cyclobutane, it's like this. Now if this bond is coming toward this side, that means its hydrogen is going up, this is coming down, hydrogen is going up, this is cis. Let me try to make it transform. See, if I want to draw transform, that means one hydrogen will go this side, so this valency has to come this side, and one hydrogen is going this side, this valency has to go that side. Now see, 4 carbons. I have drawn 4 carbons. 1, 2, 3, 4. Can I touch this carbon with this? If I'm not going to touch, it can't be cycle. And if I'm going to touch it, this bond length is very bigger. Is it possible that I'm here and my hands will come to you? Hey, you are not studying. I will remain over here and my hand will go to Tamil Nadu. Right now I'm at Pink City, Jaipur. Is it possible that my hands can go to Chennai? No. The bond length of hand is fixed. That cannot extend. Only this much is the bond length. So see, this bond's length is increased. So this is not possible. Not possible. They have fixed bond lengths. So only cis is possible. Cis is possible, no trans. So can't show GI. Are you agreed or not? Everyone agreed or not? Logic you are able to understand or not? Now why after 7 carbons they can show GI? See, first let me draw. These will always exist like this cis form. They will never have transform. They will exist like this only, cis form. They will never have their transform kits. No transform. Now see, if I make cyclooctane, this will have its cis form as well as transform. Cyclooctane. Right now just see, this is a cis form or transform. Right now see, this valency is going that side, hydrogen is over here, this is going up, hydrogen is here. This is cis form and it can exist in its transform also like this. Just see, this is its transform. How to find out trans? This is going that side, so hydrogen is on this side, this is going this side, so hydrogen is this side. Now how many of you are there who are not able to find out cis and trans immediately? You need some time to find out whether it is cis or trans. How many you want to visualize it? Just within fraction of second you can find out whether it is cis or trans. Now see, let me give you the trick. If on double bond C is there, if on double bond C is there, it is making C for cis, because its hydrogen are going on this side. Now if on double bond it is making Z, it is making Z on the double bond, Z on the double bond, it is trans. See, it is going that side, hydrogen is this side, that side. hydrogen is this side, trans. Now check it out. On the double bond it is making C, cis. On the double bond it is making C, cis. On the double bond it is making C, cis. On the double bond it is making C, cis. On the double bond it is making C, cis. On the double bond it is making Z, trans. You got it? Speed got increased or not? Is your speed increased or not? Do let me know in the chat section, kids. Do let me know. One bottle of water got completed. Now I'm going to have second bottle of water. Darshani, welcome, welcome, welcome. Super trick. Thank you, thank you. At least show some hearts, show some fire if you're liking it, and put likes also. Smash the like button also, kids. If you're able to understand, I want to see your likes. It's 392. Thank you from the internal core of my heart. Make it 400, kids. Let's make it 400 right now. 392. So let me check one question for you kids. Find out cis and trans. If the compound is like this, if I say this is A, B, C, D, E. Now let's start with A. Let's see whether you are able to understand. A, quick, fast, A. In the chat section, A, cis or trans? Cis, very good. A, cis. B, 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 B. Trans, very good. C, 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 C. So write down all, write down all, all. So see, is it correct? If you are able to understand, do let me know. Let me check it out, whether trick is working or not. Your speed got increased or not. Has the speed got increased or not? It's been increased or not, kids? Do let me know it's been increased or not. Thank you, kids. Thank you. That's really awesome. That's really awesome. That's really awesome. Now, very good question I'm going to show you. But before that, GIN substituted cycloalkanes. GIN substituted cycloalkanes. But before dealing with this, kids, wherever the place you are seated, you must be thinking the whole world is sleeping. How to watch this lecture, how to complete this lecture. So remember that when the whole world is sleeping or busy with something else or enjoying or doing party, remember that your success is waiting. Your success is just on the other side of mountain, and success is saying, let's see who can study, I will be yours, I will be yours. So I want success. You are just on the other side of mountain. Obstacle is very high. This activation energy is required. Baba is over here. Baba will provide this activation energy and you will meet with the success. Yes, see, yes, Darshani's point is very much clear that if you are in comfort zone, you can't do anything. So just get out of that comfort zone to study, to get success. Now see, GI in substituted cycloalkanes. Just see to it. If I say, let me show you here only. If I say this is cyclobutane, can you see? This is AC remote. If I say this is cyclobutane, and if I put two different color bottles like this, can you see? Now both the bottles are on the same side. Can you see? So both the bottles are on the same side. Though this is cis and this was the cyclobutane, this is cis. Now if I put one bottle downward side, now this is what? Trans. If I make it this like this, then also trans. If I make it like this, trans. Then if I make it like this is trans. Let me explain better in a better way. Suppose right now this is Baba, this is cis, your Baba HSP, right now also cis, but if I say one hand going up, one down, this is trans, can you see? So if I make this thing over here, the same thing, if I want to draw at this place, and if I say that compounds like this, hydrogen and methyl, you can see very clearly these two methyls are going downside and they are going upside. So up and up same, down and down same. So this is cis form. Even I can draw this compound like this. If I would have drawn this compound like this, just see to it that both the methyls are going up, then also it is being cis. That means this cis and that cis, they are identical. Can you see, kids? They are being identical. These two are identical. But if I would have drawn it like this, just see to it. If I have gone like this, that one methyl up, hydrogen down, another methyl down, hydrogen up. It's not in a better way. Let me draw it once again so that you can understand. On another page, let me take another page. If I have gone like this, so this was cis and this is, let's see, CH3 up, hydrogen down, and hydrogen up, CH3 down. What do you say? This is being transformed. This is being transformed. And this is being cis form. So what type of relationship they are holding? H, CH3, H, CH3. This is being trans. So they are GI to each other. No, this is trans, this is cis. So they are GI. They are GI of each other. Have you got it? Should I give you a little bit tough question? Thank you, Kaushik Raj. Thank you, Kaushik Raj. Thank you, Kaushik Raj. Now see, kids. I'm going to give you one question. Just see to it. If I give you like this, question like this, that this is CH3, this is CH3, and this is CH3 up, hydrogen down, this is hydrogen up, CH3 down. What type of relationship is there in between these two compounds? Find out the type of relation. Question is, find out the type of isomerism. In between A and B. What type of isomerism, kids? Fast, fast. I want to see the answer. Fast, kids. Fast. GI. Everyone is saying GI. But remember that examiner will give you big 0. If you're writing, if you're going for GI, examiner will give you big 0. Ask me why. See, kids. These two methyls are going up. Up. So this is cis form. Here one methyl is going up, one is going down, that is being trans. But in the starting, Baba has told you, first see the molecular formula. If the molecular formula is same, then go into the town of structural isomerism and just see, this is at 1 2 position, this is 1 position, this is 2 1 2 dimethyl, and that is see 1 2 3 1 3 dimethyl. So they are what? Structural isomers. They are structural isomers. They can never show GI. They are position isomers. They are structural isomers. That means they are PI, position isomers. Kids, how was the question? Excellent question. Excellent. Excellent question, kids. Excellent question. Am I right or wrong, kids? Do let me know. So, GI, you cannot say cis and trans are always GI. Cis and trans, if they are not structural isomer, their molecular formula is same, but they are not structural isomers, then they can be GI. Then they are GI. If they are structural isomers, then cis and trans are not going to be GI. Everyone got it? Everyone got it? Do let me know. Now, brilliant question I am going to show you, kids. Brilliant question. Just see. Fantastic rank deciding question. Question is, which compound will show GI? So I am going to give you compounds. Just see to it. 1, 1, 2, 3, 4. A, B, C, D. Brilliant question. Just see to it. A, B, C, D. I want to see who is going to give the correct answer. A, B, C, D. Yes, kids. I'm waiting for your answer. Let me check it out. Yes, kids. Baba is waiting for your answer. C. Kids, you are so intelligent. I can't understand. You are studying from anywhere else. Who is going to give you this much of knowledge? I too can't. I think you are studying somewhere else also, kids. How great people you are, kids. Really, hats off to you. Now see, its double bond is dead. 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 Neither of these four will show GI with respect to double bond. But see, this will show with respect to methyl. Once it will be like this. Once it will be like this. What is this, sir? Once will be like this. C, CH3 up, hydrogen down, CH3 up, hydrogen down, and CH3 up, hydrogen down, hydrogen up, CH3 down. With respect to alkyl, this is being cis, and that is being trans. Everyone, you got it? So this compound will exist in two forms, cis and trans. Is this clear to all of you, my dear friends? Do let me know first of all. Everyone, do let me know. Is it clear? Okay, now see, allenes, GI in allenes. That is really very important. Rank deciding. GI in cumulated system, that is allene. GI in allenes, that is cumulated system. Cumulated system. What is cumulated system? Cumulated system means when there is no single bond in between pi bonds. Let's see how it will look like. If I write compound like this, C double bond C double bond C double bond C, this is cumulated system. Can you see? Pi bonds are not separated. This is pi, this is pi, this is pi. All together they are being pi. This is cumulated system. But in the examination, how to find out which cumulated system will show GI and which cumulated system will not show GI? Okay, kids, don't worry. At 11, I will give you one. I will give one break at 11. Okay, don't worry, kids. Now see, the conditions required by this compound to show GI, two conditions are required. Let's see what are these two conditions. Condition number 1, each sp2 hybridized carbon must be attached with different atoms or groups. This is the same condition as earlier one. This is the same condition. Now new condition is number of pi bonds must be odd. Number of pi bond must be odd. Now my dear friend, two things are required. One thing is that how to cram it, and second thing is that how to visualize it. The one who is working on all these two fundas, that visualization means accuracy and cramming means speed. Combo of both will give you the rank. So everyone ready? Ready? How to cram it? Whenever you are not able to remember anything, just remember God, God. Just remember God, God, God. To show GI, to show GI, to show GI, number of pi bonds must be odd, odd, odd. God, God, God. Whenever you are not able to understand anything, time is less, just remember God. To show GI, number of double bonds, pi bond must be odd. Gets everyone able to understand? Do let me know, my dear friends. Now, how many of you want to visualize it? Why is this so? That only odd number one will show GI, even one will not show GI. How many of you are interested? Do let me know, kids. But kids, hit the like button. Hit the like button. Make it 400. It's 397. Only 3 more likes I require to get up to 400. Okay, already liked. Okay, now see, kids. See. If I have only 2 pi bonds, this hydrogen is coming towards your side. Just try to understand. This hydrogen is coming towards observer side, and that methyl is going away from observer. So let me say this is on horizontal. Then this is also horizontal. Then the pi bond, you know, sigma. If this is sigma bond, the relationship of sigma and pi bond is being vertical. Can you see vertical? So if sigma bond is horizontal, then pi bond will go vertical. Then this will be vertical. When they are being vertical, then it is having another pi bond. If I say this is sigma bond, one pi bond is going vertical, then another pi bond will go perpendicular to both of these, will go like this. Now see, another pi bond, because this is having 2 pi bonds, it's another pi bond will go like this, horizontal. So this will form bond with this horizontal. Now if pi bond is being horizontal, then the sigma bond will go vertical. So hydrogen at this place and CH3 at this place, this hydrogen is perpendicular vertical and that hydrogen is horizontal. So they are not in same plane. One hydrogen is on the bed, another hydrogen is going above the bed. So their plane is different. So they cannot show GI. This hydrogen and this hydrogen, they are in different plane. Plane should be same. To show GI, they must be, both hydrogens should be in same plane, but they are being in different plane. Actually they are being in, but they are in different plane. But two hydrogens are in different plane, are in different plane. Everyone able to understand? Do let me know. So they can't show GI. Their plane should be same. Now if the number of pi bonds are odd, let me show you, kids. If they would have been odd, then see, C double bond C, double bond C, double bond C, 1, 2, 3. And let me draw this hydrogen coming towards observer side, means towards your side. Then this is going away from you. Let us suppose, like earlier, if this is being horizontal, then this will be horizontal, then the pi bond will be vertical. This pi bond will be vertical. Vertical, vertical. Now another pi bond will be horizontal. Another pi bond will be horizontal. It's another pi bond will be horizontal. Horizontal, horizontal. Now it's another pi bond will be vertical. Vertical. So this will be vertical. VT, VT. Now its sigma bond will be horizontal. Its sigma bond will be horizontal. Now just see, both the hydrogens are horizontal. Can you see, kids? This is horizontal, that is also horizontal. So these two hydrogens, they are being in same plane. Can you see? Two hydrogens are in same plane. And that's why we'll show GI. Everyone able to understand? I have given you each and everything how to understand it, kids. No hydride shift will be there. In alkene, hydride shift is not possible. Hydride shift is possible only in carbocation. Who is asking about hydride shift? No hydride shift, kids. That is only possible in case of carbocations, right? This thing is clear to each and everyone. Now, after telling you each and everything, Baba is going to tell you E and Z system. Baba has explained each and everything. Now, Baba is going to deal with, yes, Baba is going to deal with your E and Z system, the backbone of GI. Kids, everyone ready? Is everyone ready, kids? Do let me know. Is everyone ready? How's the Josh? Baba wanna see Josh. Baba wants to see the Josh, kids. Josh in the chat section. Yes. See. Let me add some slides, kids. See, kids. E and Z. E stands for anti-Gagan. Z stands for Jusaman. No need to learn what E and Z stands for. Just know Z means pair. Z means pair. The meaning of this Z is pair. Now I will let you know how to find out E and Z. Okay. Now see, kids, if I draw compound like this, C double bond C, and if I say this group is senior and this group is also senior, and definitely the other side they will be junior. This side group is junior, This side group is junior. Now senior are on same side. Senior are on same side. We will say it is Z. Z configuration. Z configuration. And if it is like this, C double bond C, one group senior on this side, another group senior on another side. So we'll say enemy. They have become enemy. That means E for enemy. You can remember E for enemy. They have gone opposite side. Enemy. E. This is Z. Z. Only this much. Now kids, you are very intelligent. Only the problem is that how to find out who is senior and who is being junior. Are you getting my point? Now the problem is only what the problem is left, kids. What the problem is left? How to find out senior and junior. How to find out senior, who is senior. How to find out who is senior. So this problem was solved by 3 scientists. Seniority order was decided by 3 scientists. Let's see which scientist. Seniority order was decided by CIP rule. Which rule, kids? Say everyone. CIP rule. CIP rule. C was one scientist. C stands for Kahan scientist. Kahan. I stands for one more scientist. In gold. See the names. What type of names they are having. In gold. And P stands for pre-log. Just before log. Pre-log. These are the 3 scientists. No need to remember their names. Just remember their initials. CIP rule. Will you be able to remember CIP rule? So, now our interest is to understand CIP rule. Is everyone ready, kids? Is everyone ready for understanding CIP rule? Is everyone ready? So, after the break, we will understand CIP rule. We are going to understand CIP rule after the break. So kids, we are going to understand the CIP rule after the break. Is everyone agreed? Is everyone agreed, kids? So let's have a break. Break time. It's 11 to 11:20 p.m. Come with full of energy. Come with full of energy. It's a promise. Just otherwise I will not give break. Will you come with full on energy? Make a promise, kids. Thank you, Nandini. Thank you, everyone. Okay. And tell everyone, because after geometrical isomerism, Baba is going to tell you optical isomerism. This EZ system is also required for optical isomerism. Without EZ system, no one can understand. Oh, attendance from Jaipur. Wow. Garvit Jain, thank you. Garvit Jain, tell everyone. Tell all Jaipur students to join it. All Jaipur should know what is optical isomerism. Okay, kids? Garvit Jain? Okay, that's fantastic, Shreya Gupta. Shreya Gupta, thank you. Okay, let's meet after a short break. Okay. Welcome back again to yours Unacademy NEET English channel. Your Baba, HSP, and all my future doctor engineers, ERDR. So, if I'm perfectly audible as well as visible to all of you, just do let me know in the chat section. I want to see my dear friends. Can you? Yeah, Baba is very punctual. Baba is very punctual. Kids, I want to see some hearts and fire so that we can start, my dear friends. Wow, I can see still the energy level is awesome. Your as well as Baba's. Baba is full on energy. You kids are full on energy. Let me see. All my dear friend. Jyoti is also there. I can see. Wow, that's really fantastic. So let's start. And kids, this lecture will change your life. Let me check it out in the chat section. Who is watching? Darshini is there, Nandana Devi is there, Jackson Ekman is there, Shakti Sanjay is there, Suchitra is there, and Samriya is there. I can see everyone. Oh, great, great, great. Muhammad Ashik is there, Prithvi Raj is there, Swet Prasad is there, Suchitra, Darun Joseph, Karun Pahila. Yes, 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 kids. That's really fantastic. Really, really fantastic. Let's start. Let's start. Let's start, kids. Let me check. Yeah, this is over here. Now, I was telling you before this. CIP rule. Oh, yeah. We are going to deal with CIP rule. This is not only important for your GI. This is equally good and holds a hell lot of weightage for your optical isomerism only. So, we are HSP and Army. We means including me. And for us, this is morning time. See, the sun rays are coming. Just feel like that. Don't feel sleepy. Think like that. Sun rays are coming. We are all together. We are company. We are one circle. Okay. So we are not alone. We are with each and everyone. Now let's see CIP rule. CIP rule. Everyone just see to it. CIP rule. So CIP rule number 1. CIP rule number 1, kids. This rule says atom directly attached to sp2 hybridized carbon means we are talking about which atom? The atom which is directly attached to sp2 hybridized carbon with maximum atomic number will be senior most. Which atom is going to be senior most, kids? The atom which is directly attached to the sp2 hybridized carbon with maximum atomic number, the one who is having maximum atomic number. Now you're not able to understand. Let me make it clear that you know the periodic table. So you will say, sir, we don't know periodic table. No problems at all. Just see, if I talk about hydrogen, carbon, nitrogen, oxygen, fluorine, bromine, iodine. This much you know, that in the long form of periodic table, atomic number increases in this order. This much you know, then we can do all the questions if you know this much. And I think this is really very, very simple and everyone should know this much. Right, kids? Now see, let me give you one example of it. If I say I am provided with this compound, this side iodine, this side hydrogen, this side bromide, this side chloride. Just while doing this question, what you're supposed to do, hide this carbon. Don't see this carbon. Just see this carbon. Out of hydrogen and iodine, who's senior? Iodine is senior. Now hide that carbon and see in this, out of chlorine and bromine, which is senior? Bromine is senior. Now senior, senior on the same side. Can you see what I'm trying to tell you? Senior, senior on the same side. So what I will say, if they are on same side, I will say this is Z configuration. Z configuration. I hope everyone got it. Everyone got it. Now if I give you this compound like this, C double bond C, here is iodine, here is hydrogen, here is bromide, here is chloride. Just see. If I say out of hydrogen and iodine, iodine is having more atomic numbers, senior. Bromine and chlorine, bromine is having more atomic numbers, so they are opposite. If you compare with respect to double bond, this is upside, this is downside, so this is enemy E configuration. First rule you are able to understand. If yes, do let me know. Do let me know. Now one more thing I would like to tell you. Let me tell you, see kids. So fantastic example I'm going to tell you. This example is like this. If I say this is carbon, here is iodine, here is hydrogen, here is hydrogen, and there is iodine. Now see, if I say on this carbon, this is senior, on this carbon, this is senior, 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 same side, this is senior, same side. So this is Z configuration. But you will say, sir, earlier you taught us that same atoms are on same side, then they are cis. Yes, kids, this is cis also. Now you will say, this is one compound or two compound? Kids, suppose if my name is HSP and if anyone is saying Harry, your name is Harry. So I am HSP, I am Harry. I have got two names, but I am only one. So it has got two names. Cis and trans is also defined. Either you say Z or you say cis. The compound is only one. Now, if I say this compound, just see. If I say there is iodine and there is iodine. Here is hydrogen. Here is hydrogen. If you say EZ system, then this is senior, E. Or you can say with respect to cis-trans, they are opposite. So this is trans. So compound is one, names are two. So there are two GI. These are two GI. You can say EZ, either you can say E and Z, or you can say cis and trans. If everyone is able to understand, do let me know with the some thumbs ups. So either you can say they are cis-trans or you can say they are EZ. Everyone do let me know. Everyone able to understand? If yes, I want to see in the chat section that yes, you got it. Now, after this, I'm going to tell you CIP rule number 2. CIP rule number 2. CIP rule number 2, kids. In case of isotopes, the atom with maximum mass will be senior most. Now see kids, if I say I'm having protium, deuterium, tritium, hydrogen isotopes, hydrogens isotopes, so very frankly I can say that tritium 1,3, deuterium 1,2, protium 1,1. It should be like this. If I say carbon isotopes, carbon 14, 614, carbon 613, then carbon 612. It should be like this. Are you getting my point, kids? I hope this is clear to all of you. This is being the priority order. Now, if this is clear, I'm going to give one question based on this. Just see to it. If I give you compound like this, C double bond C, here is hydrogen, here is deuterium, here is iodine, here is chlorine. Just see to it. If I talk about out of deuterium and hydrogen, deuterium is senior, iodine and chlorine, iodine is senior. E or Z? Do let me know in the chat section. It's E or Z. I want to see kids whether you are active or not active. E or Z? Do let me know. E or Z? E. Very good. Very good. It's E. E configuration. Now this means it's clear to each and everyone. This point is clear to each and everyone. Now cis and trans is defined? No. No atom same. So cis and trans not defined for this. Cis and trans not defined. Not defined. Now after this, let me tell you CIP rule number 3. CIP rule number 3, kids. Just see to it. CIP rule number 3. When first atom is not able to decide, then C second atom for seniority. For seniority. What is this? See kids, let me give you one question, then you can understand clearly. If I give you this question, C double bond C, CH2I, CH3. If I say here is CH2Br and this is Cl, just try to understand. First, don't give the answer. Right now, you have to understand what's going on. Kids, I think your energy level is going down. Everyone do let me know how is the Josh. I want to see how is the Josh, kids. Your Josh is getting decreased, I think. Call everyone. Optical isomerism. I'm going to start with optical isomerism. That is the backbone of isomerism. The most important thing. How your Josh can be so low. Now see, if I say the first atom attached is carbon, this is saying I'm carbon, this is saying I'm also carbon. Both are saying I'm being carbon, carbon. So this is saying my senior most second atom, this is the first atom, this is its first atom. What is senior most is iodine. He is saying, oh, I'm not having any senior one. So the first atom, carbon, carbon is same. So this is senior. Now here in this case, the first atom is chlorine and its first atom is carbon. Don't see bromine, don't see bromine. Why? That is the second atom. It is decided by the first atom only. First atom is chlorine and its first atom is carbon. So this is the winner. This is senior. Are you able to understand? There, this is senior. So its configuration is E configuration. Those who are not able to understand it, I will give another problem. Those who are unable to understand it, see kids, I'm going to give you another problem. See, just see to it. If I give you compound like this is attached with OH, this is attached with CH2I, this is attached with chlorine, and that is attached with CH2Br. Just see, its first atom is carbon, its first atom is oxygen, and most of the students, they start thinking iodine. Don't see that. Compare first with first. This is winner, oxygen is winner. Here first, this is carbon, this is chlorine, this is winner. Don't see bromine. Don't go and see that is the second atom of this carbon. Here it is the second atom. When the first atom is able to decide, this is being the first atom. When first atom is able to decide, don't go for the second atom. Are you getting? So this is senior Z configuration. Yes, if the compound is given like this, see, if it is given like this, CH2I, CH2Br, CH2Cl, CH2Br. Now the first atom is carbon, its first atom is carbon, can't decide, then you go to see the second atom, senior. First atom carbon, can't decide, then go for senior. So this is there, that senior, here this is senior. Oh my god, this is senior opposite E, and these two groups are same, E and cis. Now my dear friend, those who are thinking that E is going to be trans, it's no relation. E can be cis or E can be trans, no such relation. See here, E and cis, there earlier it was C, not here. Here this was, where it's gone. See, Z was cis, Z cis. So E was trans. There is no such type of relation. Z will be trans or cis. It can be anything. Is it clear to all of you? Now the energy is high. That's really fantastic. Now my dear friends, let's move ahead towards the CIP rule number 4. Very, very important. CIP rule number 4. Everyone ready? This is tough one, toughest one. CIP rule number 4. Is everyone ready, kids? For the CIP rule number 4. This is really tough. In case of multiple bonds, we have to draw hypothetical structures. Now kids, this is very tough thing, and if you understand it clearly, you can easily understand, no problem. And if you not apply your attention, if you're going to skip it, you won't be able to understand. So is everyone ready with full on Josh? Suppose if I give you one compound like this, to find out its EZ, CN and CH, NH2, NH2, and if I say here is chlorine and here is iodine, so definitely this is easy to get compared. This is senior, but here it's looking like this is carbon, okay, this is carbon, okay, and now it is looking like that this is attached only with one nitrogen and this is attached with two nitrogens. It's looking like that. and we are expecting this is going to be senior most, but it's not like that. It's not like that. So we have to draw their hypothetical structures. How to draw their hypothetical structures? Let me tell you. The cyanide is like this. Cyanide is like this. Can you get it? Cyanide is like this. This is cyanide. And cyanide is having 1 sigma and 2 pi bonds. So how to draw their hypothetical structures? Let me tell you. The sigma bond, let it remain like that only. The sigma bond, let it remain in that form only. Now break the 2 pi bonds. This carbon was attached with 2 pi bonds. I have broken down its 2 pi bonds. Nitrogen was attached with 2 pi bonds. I have broken down its 2 pi bonds. This much is clear because here you have to pay attention. Now, carbon is saying you have broken down my pi bonds. I was attached with nitrogen. So take nitrogen, and nitrogen is saying my pi bonds were attached with carbon. Give it carbon. This is its hypothetical structure. How many of you got it? This hypothetical structure. How many of you got it? Hypothetical. Now, after drawing hypothetical structure, you can understand that this carbon is attached finally with how many nitrogens? This carbon is attached with 1, 2, and 3 nitrogens. It was looking like attached with 1 nitrogen. If you draw it, see 1, 2, 3. For its polyvalent bond, it is attached with 3 nitrogens. Attached with 3 nitrogens. 3 nitrogens. And this is attached only with 2 nitrogens. So who is senior, upper one or lower one? Who is senior, upper one or lower one? Do let me know. Definitely the upper one is senior. This is senior. This is senior. So it is E configuration. Now you kids must be thinking, sir, it's very tough. Give one more example. How many of you want more example? Just to understand it. How many of you want more examples? Do let me know. I will give you more examples. See, if I draw like this, C double bond C, CHO, COOH, hydrogen and methyl. So let's see who is senior. CHO, how to draw CHO? I will draw CHO like this. Once I have drawn how to draw hypothetical structure, it's hypothetical structure. There is 1 sigma bond and 1 pi bond. Let's make sigma bond as it is. CHO, this is sigma bond. I have broken down pi bond. This pi bond is attached with carbon as well as with oxygen. I have done dung dung dung, dung dung dung, anaconda like this. Now carbon is saying, hey, my pi bond was attached with oxygen. Take oxygen. My pi bond was attached with carbon. Take carbon. It's hypothetical structure we have drawn. Now COOH. COOH is like this. So C sigma and pi bonds. The first one is sigma, 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 and this is being pi. Let's make sigma bond as it is like this. Now we have broken down pi bond. Carbon has started crying, my pi bond. Oxygen has started crying, my pi bond. Oh, carbon, your pi bond was attached with oxygen. Take oxygen. Oxygen, your pi bond was attached with carbon. Take carbon. Kids, how many of you are able to understand? Show me some fire, some hearts, so that I can understand. Yes, you got it. Then only I can explain cis-trans, optical isomerism, each and everything. First of all, do let me know that everyone got it or not. You like the way I'm telling you, kids? Have you liked the way I'm telling you? Are you enjoying it? This was really tough. No one is going to teach you like this. No one. Baba is very funny. Yes, now see. There is a fight in between these two. Now let's see who is going to be the senior one. Here it is senior. This is carbon. That's it, hydrogen. So senior. Now this carbon is saying I'm carbon. This is saying, hey, I'm also carbon. Both are carbon. This carbon is saying I'm attached with 2 oxygens. Hey, this carbon is saying I'm attached with 3 oxygens. So who is going to be senior? The 3 oxygen. 3 oxygen one is winner by 1 oxygen. So definitely this is senior. Am I right, kids? So this is Z configuration. Z configuration. Is it clear to each and everyone? Do let me know, kids. I'm waiting. Thank you, Nawab's World. Oh, you are still there, Nawab's World. Wow, that's really awesome. That's really awesome. Kids, do let me know. Everyone got it? Now, the CIP rule number 5. Last CIP rule number 5. CIP rule number 5. Now see to it. Bonded or bond is senior to lone pair. Bond pair, you can say bond pair. Bond pair is senior to lone pair. Bond pair is senior to lone pair. How to find out secrets? If I write down compound like this, C double bond N OH CH3 H, what do you say? E or Z? So here this is carbon, this is hydrogen, this is senior, and there is this is bond, and that is lone pair. So bond pair is senior, this is senior, opposite, so E configuration. E configuration. That's it. This is all about GI. I have told you each and everything about GI. Now we are moving towards optical isomerism, the backbone of isomerism. Kids, we are going to enter into the world of optical isomerism. Is everyone ready? Optical isomerism, kids. Optical isomerism. Just see. Optical isomerism. Optical isomerism, kids. Optical isomerism. Optical isomerism. So see, kids, this is the backbone of isomerism. Maximum important questions. Backbone of isomerism. Maximum important for all type of examinations. Most important isomerism. Now the candidates, the students who know a little bit about optical isomerism, I will ask question and you have to answer it. So suppose if Baba is asking most important condition, most important one and only one condition for a compound to be optically active. Completed. To be optically active. What is that condition? Fill in the blanks. Do let me know. Fill in the blanks. Do let me know, kids. What's that? Fill in the blanks. Do let me know, kids. I want to see in the chat section what you're writing. Yes, do let me know. How many of you are able to give the correct answer? Let me check it out. Yes, kids, let me check it out. So, yes, the answer is compound must be asymmetric. Compound must be asymmetric. Compound must be asymmetric. And for a compound to be asymmetric, what is required? How the compound is going to be asymmetric? For that, I will tell you each and everything. But first of all, let me tell you what is optical isomerism and how optical isomerism is working, where big institutes like IITs, NBRI, CDRIs, ITRC, number of such type of institutes are there, where spectrophotometer is there, that machine which is going to measure whether the compound is optically active or optically inactive. That is an experimental concept, but in our paper we will just get compound on written on paper. We will neither have compound nor that machine, and we are supposed to find out whether the compound is optically active or inactive. So the scientists, they have given rules, but what actually is optical isomerism, how it is getting measured, let me show you that thing. See, there is plane polarized light, kids. There is plane polarized light. Have you heard this name, plane polarized light? What's that? What's that, kids? Plane polarized light. Before plane polarized light, let me tell you, the light which we see, the sunlight, that is multi-directional light. The light is multi-directional light. Multi-directional light. It is of no use. So we have to pass this light through Nicol prism. Which prism? Nicol prism. What I'm saying, kids? Nicol prism. This also known as calcite, because it is made up of calcium carbonate. It is made up of calcium carbonate. By passing through this Nicol prism, this light will become unidirectional. This light will become unidirectional, and this light will be known as plane polarized light. Means it will start moving only in one direction. That was multidirectional. It will start moving only in one direction. I am not saying that only upside. It will go downside also, like this, but unidirectional. The light has become unidirectional, kids. This is known as plane polarized light. Plane polarized light. Now this light, after passing through this Nicol prism, this light is passed through the solution. Which solution, kids? Which solution? The solution which is under observation. This is in a tube. The solution is in a tube. This is the tube. And the solution is filled over here. This is organic solution, kids. This is organic solution which is filled over here, kids. Now when the light is passing through this, if the compound is optically active, if it is optically active, then it will rotate the light either in clockwise direction. If the light has been rotated, this was the normal. From the normal, this was the normal. From the normal, if the light has rotated in the clockwise direction, this was the normal, kids. See what I'm saying? This is the normal one. From the normal, if the light is rotated in the clockwise direction, if the light has been rotated, we will say it is dextro. Who is dextro? Dextro rotated. This compound, no, this light is passing through this solution. This solution will be called as dextro rotated. If this solution is rotating this plane polarized light in the clockwise direction, we will say this compound is optically active and it is dextro rotatory. Can you see dextro rotatory? This is small d or plus sign, nothing to do with capital D. And if this light is found to be rotated in the anti-clockwise direction, kids, anti-clockwise direction, then everyone will say that this optically active compound is what? Everyone will say this compound is levorotatory, levorotatory, L or negative sign. This whole instrument which is used to measure is known as spectrophotometer. Everyone say spectrophotometer. Spectrophotometer. Everyone say spectrophotometer. Say kids, spectrophotometer. Its another name is polarimeter, or it is known as polarimeter. It's known as polarimeter. Either you can say polarimeter or you can say spectrophotometer. Got it, kids? The examiner will ask such type of things. But in the examination, neither we will be having the compound nor this instrument. We have to apply our brain the things which have been suggested by scientists. Are you ready? So let's see. For a compound to be asymmetric, what is required? Let me show you, kids. For a compound to be asymmetric, what is required? For a compound to be asymmetric, compound should not have or shouldn't have what? Center of symmetry and plane of symmetry. Cos means center of symmetry. Cos means plane of symmetry. Now, my dear friends, out of these two, this is very, very important. Plane of symmetry is very, very important because maximum questions will come on based on this only. So, now the thing which I am going to tell you will require some brain. Are you active? Cos, to understand cos is everyone active? If everyone ready, then only I am going to tell you, kids. Is everyone ready? Some bit of brain will be required, kids. Now, very good. I can see that everyone is active. Now see, let me tell you cos, plane of symmetry. Cos. Plane of symmetry is an imaginary plane, which divides whole compound in two equal parts, so that so that one part is the exact mirror image of second part. For example, if I draw A, let's draw a stylish A. Just see. This is A. So from where should I divide it so that I can get two equal parts? This is A. From where, imaginary, from where should I divide it so that I can get equal parts? Just see to it. I will divide it from here. So the left hand side is exactly equal to the right hand side. Can you see kids? Left hand side LHS is equal to RHS. Can I say like this? So this is vertical plane of symmetry. Vertical plane of symmetry. So this compound is optically inactive. Optically inactive. Now, if you're not able to understand, let me give you another example. Don't worry, don't cry. Baba is going to give you another example. Just see. If I draw B, do let me know from where should I divide so that I should get two equal parts. Do let me know, kids. How to divide it? Then you can say, Baba, you divide it from here. The upper part is exact the mirror image of lower part. So this is known as horizontal plane of symmetry. This compound is also optically inactive. Optically inactive. Now kids, how to understand in actual? These are the artificial compounds which I have shown you. How many of you want to understand? Just take your right hand. Everyone, just see your right hand. Don't cut it. Just try to imagine from where we should cut. Don't cut it. Only you have to see imaginary. From which side you cut it so that your right hand should get divided in two equal parts. Do let me know. Is it possible to divide this hand in two equal parts? Do let me know, kids. Is it possible to divide? No. Because if you divide it, thumb is this side. And if you divide like this, sandwich cut, the rough surface will be on the upper side and the smooth surface will be downside. That means this right hand is optically active because there is no plane of symmetry. And if you see this hand in the mirror, mirror will show you the left hand. So these two hands are different. They are not having plane of symmetry. But if you see this hand in the mirror, you will get mirror image of the left hand. So right hand and left hand, they are different. They are looking same, but they are not same. If you wear out gloves in the winter, the finger one gloves, the right hand one cannot fit into the left hand side. They are different. Two hands are different. Agreed or not? Two hands are different. The right hand and the left hand, they are being different. Good morning, kids. Good morning. It's morning. Now it's morning, kids. Morning. Good morning to all of you. So the two hands, they are optically active and they are mirror images of each other. And now if I try to put my right hand on the left hand and I keep on rotating, then this cannot superimpose each other. The right hand cannot superimpose on the left hand. They are non-superimposable mirror images of each other. Non-superimposable mirror images of each other, they are known as enantiomer. So the right hand is the enantiomer of left hand and the left hand is the enantiomer of right hand. Both are optically active, and the relation in between these two hands, we will say they are enantiomers. Now kids, let me tell you what is chiral carbon. Everyone must be waiting for the chiral carbon. Are you waiting for chiral carbon? Just see. Everyone must be waiting for chiral carbon, kids. Chiral carbon. What is this chiral carbon, kids? See. And what is the importance of chiral carbon? Carbon attached with four different atoms or groups Now, my dear students, if there is only one chiral carbon in the compound, then the compound will always be optically active. Let me tell you, my dear students, what I am telling you, if there is only one chiral carbon in the compound, if there is, this is the note, point to be noted, my lord, if there is only one chiral carbon in the compound, then the compound is always optically active. What does it mean, kids? The compound will never have cos and cos. This thing you must be knowing, kids. This thing you must be knowing. But you must always be searching for the reason of it. And Baba will let you know what's the reason. See, kids. What do you think? Which carbon is chiral? Carbon attached with A4, all same. Carbon attached with A3B. Carbon attached with A2B2. Carbon attached with ABCD, ABEF. Which is having chiral carbon? Do let me know. The first one, the second one, the third one, the fourth one. Who is having chiral carbon? Let me know in the chat section. First, fourth one is having chiral carbon. This carbon is chiral. Now, my dear students, let me give you the example. Its example is CH4, CCl4, like this. Example is CHCl3. Its example is CH2Cl2, CBr2Cl2, like this. Now, these are having plane of symmetry. They have plane of symmetry, and that's why they are optically inactive. and this is not having plane of symmetry, no pause, and that's why it is optically active. Now kids, how many of you want to know the reason? How many of you want to visualize it? Do let me know how many of you want to visualize it, that why they are having plane of symmetry and why that is not having plane of symmetry. How many of you want to visualize it? Show me some green hearts, thumbs ups, fire, then I will let you know. Then I will let you know. Let me arrange some pen. 1, 2, 3. 1, 2, 3. Okay. So let me take this. Suppose if I say yeah, I got it. Just see. First of all, try to understand what is the meaning of tetrahedral. Right now it is 90 degree. If I spread it a bit, now it is 108 degree. You can compare this as, think like this is 108 degree. V for victory. V for victory. If you are able to visualize tetrahedral, you can visualize anything. Are you ready for the visualization? This is V. You can see this is V. 1V, and suppose this is same carbon, means carbon having same atom, like one H, another H, both are two hydrogens, right? Now consider this is also 1B and they are hydrogen. Just for sake of simplicity, consider them to be hydrogen, from where you can cut to get the plane of symmetry. If you cut from this side, you will get same thing that side, same thing this side, and hydrogen is being spherical, half toward that side, half toward this side. This is the plane of symmetry, and you can cut like this. This is the plane of symmetry. You can cut from here, the plane of symmetry. Anywhere you can cut, there will be plane of symmetry. Can you see, kids? If this one you are able to understand, do let me know. Then I can move ahead. All the 4 atoms are same. There is plane of symmetry. From anywhere you can cut. Got it? Now if I say 3 atoms are same, one is different. So say this is different. This is red, rest are blue. Now from where you cut it, so to get the plane of symmetry, from where should we cut it? From where it should be cut it. So see, if you cut it from this side, half of the red will go towards right hand side, half will go left hand side, and these two things are same and this is same. So this one is also having plane of symmetry, that 3 are same, one is different. You are able to understand? Now if I say 2 are same, 2 are different. Let me take this example. 2 are same, 2 are different. Just let me say these 2 are same. This is 1V. Can you see this is 1V? These 2 are same. And these 2 are different. These 2 are same. These 2 are same. Okay, see. These 2 are same. These 2 are same. These 2 are same. And these 2 are different. These 2 are different. Now from where you cut to get the plane of symmetry, do let me know. If you cut it from here, this will go half toward that side, right hand side, half towards left hand side, and this red one will go half towards that side, half toward this side, and these 2 are same. Once again, plane of symmetry is there. But the problem will arise if all 4 are different. If all 4 are being different, just see, if all 4 are being different. Now this is different, this is different, this is different. These two are different. Just see, these two are different. Can you see? This is different. This red one is different. This red one is different. And this is also different. Now see, if you try to cut it, if you cut it from this side, red half will go towards right hand side, half toward left hand side. And this orange bottle will go half toward that side, half toward this side. But this side, right hand side, this is blue and this is stylus. They are not same. And if you try to cut it from here, if you try to cut it from here, that side red, this side orange, they are different. That means if 4 different groups are there, plane of symmetry will not be there. How many of you got it, kids? How many of you got it? Oh my God, how many of you got it that it will never have plane of symmetry? Kids, my hard work is working or not? You are able to visualize it. Let me have a glass of water. By seeing this water, I have started feeling thirsty. Nawab's world is there. Laharika is there. Everyone is there, kids. Thank you. Thank you for your great energy. I can see your comments. Fantastic. Thank you, kids. Thank you. Now see, kids, how to count. Okay, just see center of symmetry. First of all, we are going to see center of symmetry. See, center of symmetry. Cos. It is the point. It is an imaginary point in the center of the compound from where if we go opposite side, we will get same atmosphere at equidistance. At equidistance. I know that you are not able to understand anything from this, whatever I have written, but let me make it clear. It will get clear. See, let me show you something. If I draw this compound, see, NH CO CH2 CH2 CO NH CO. Now, what is the center of this compound? This is the center. This is the center. And if I go opposite side, means this side, what I have got CO. And if I move other side, I have got CO. This side NH, that side NH. This side CH2, this side CH2, this side bond, this side bond, that side also bond, this side bond, that side also bond. Can you see the symmetry is there from this point? Everything we are getting at same distance, same thing. So this compound is having center of symmetry. Compound will be optically inactive. Compound is optically inactive. Now, my dear students, these are the simple examples we have seen, and maximum 90% of questions examiner will ask from here only, but there are 10% of the compounds which are tough. How many of you want to deal with tough questions for rank deciding questions? Now, for rank deciding questions, we have to deal with tough questions. Now, see, rank deciding. Are you ready? Is everyone ready, kids? For rank deciding questions. So if I draw a compound like this, if I draw compound like this, here carbon, here carbon, here carbon, here carbon, and if I draw bond at this position and bond at this position, and if I put here bromine, hydrogen, bromine, hydrogen, what do you think? Apply your brain. Is there plane of symmetry? Do let me know, kids. What do you think? Is there plane of symmetry? Just go for it and do let me know. Let's see your visualization. Is there any plane of symmetry? Now it's a time to apply your brain. It's a time to apply your brain, kids. What do you think? Is there any plane of symmetry? It's a time to apply brain. Kids, I'm waiting for your answer. What do you think? Is there any plane of symmetry? No, no. Okay, see. There is plane of symmetry. Now, should I let you know why? Should I explain? There is plane of symmetry. Should I explain? How many of you want to visualize that there is being plane of symmetry? How many of you want to know, kids? Do let me know. How many of you want to know? Let me show you. Wait. Suppose this is your compound, cyclobutane. Can you see? This is cyclobutane. Can you see? Four sides. Four sides. Can you see cyclobutane? Now, if I say one bromine is going, see 1, 3, 1, 2, 3, 1, 3 position. One bromine is going up, this bromine, and another bromine is going like this. From where you should cut? You just see. If it is like this, you won't be able to see. But if I keep it like this, if I keep it like this, just in the straight, if you cut long knife like this, like my nose is there, my nose is knife, cut it. Don't cut nose, cut this compound. Are you getting diagonal plane of symmetry? The plane is moving like this. Catch, 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 catch. It is dividing the whole compound in two equal parts. Can you see, kids? Just see, just see. Diagonal plane of symmetry is there. Diagonal plane of symmetry. If you cut this compound, there is diagonal plane of symmetry. Let me show you. Let me show you. This is the plane of symmetry. If you cut it like this, in this way, if you cut it from here, it will divide it into two equal parts. Just see. It will divide it into two equal parts. You just see to it. If I cut it like this, the whole compound will get divided in two equal parts. Just see to it. Divided or not? Try to understand. It has been divided or not? Kids, do let me know. It has been divided in two equal parts or not with the plane of symmetry. Just try to understand. This is known as diagonal plane of symmetry. Everyone, I'm trying to make 3D diagram for giving best visualization, but you have to tell me that is it working or not? You are able to understand it or not? I'm trying my level best from all the directions. Just see to it. It has divided in two equal parts. Can you see, kids? Two triangles. Yes, two triangles. Absolutely correct. Absolutely correct. Now, just try to understand it. Got it. So this is having plane of symmetry, and this compound is optically inactive. Optically inactive. Now, this was the both the bromine on same side. This was the cis form. Cis form, because both the bromine were up and up. Now let me draw its transform. Let me draw its transform. Just try to understand. I'm going to draw its transform. Just see to it. If I draw one bromine going up, another bromine going down, just see to it. One bromine going up, another bromine going down. This is the transform. Trans. What do you think? Is there plane of symmetry or not? In the transform, there is plane of symmetry or not? Do let me know. In the transform, there is being plane of symmetry or not? Kids, do let me know, everyone. Let me check it out. What's your answer being? This is the transform. This transform is having plane of symmetry or not? Yes. Yes, kids. Yes, it is having plane of symmetry. See, the same diagonal plane of symmetry. The same diagonal plane of symmetry is being there. If you cut it in two equal parts, this will get divided in two equal parts. Just see to it. It will get divided in two equal parts. Can you see? Can you visualize, kids? Do let me know. This is getting divided into two equal parts. It will get divided in two equal parts. Can you see, kids? Clear to all of you? Is it clear? Are you getting it? So it is having diagonal plane of symmetry. So optically inactive. Optically inactive. Now see, my dear students, I'm going to give you another thing. Just see to it, everyone. If I make one compound like this, another compound like this, chlorine, hydrogen, chlorine, hydrogen. This is cis form. Chlorine, hydrogen, hydrogen, chlorine. This is transform. Do you think both are having, this is suppose A, that is B. What do you think? Both are having plane of symmetry, or only one is having plane of symmetry? Do let me know. Both of them are having plane of symmetry, or only one is having plane of symmetry? Kids, do let me know. One kid is saying both are having. Let me check it out. One. So see, if you cut it from here, vertical plane of symmetry, you can see clearly this compound is having vertical plane of symmetry. You can divide it from here. Vertical plane of symmetry. Vertical plane of symmetry is there. So this is declared to be optically inactive. But if you try to divide it into two parts from here, this is going upside, this is going downside. See, if you put here mirror, in front of this there is no chlorine, and in front of this there is no chlorine. If you cut it like, there is no plane of symmetry. No plane of symmetry, no center of symmetry even. See, if you try to see center of symmetry, you have to sit in the center of the compound, and from the center of compound, if you go that side, there is hydrogen. Here is upside chlorine, but downside there is no chlorine. So no pos, no cos. So this form is optically active, and this will help you a lot in coordination chemistry also, and understanding coordination chemistry also. No pos, no cos. That's why this is optically active. Till now everyone is able to understand. I've told you each and everything. It's all the tough questions you can do now. Everyone got it? Now, after this kids, let me tell you very important thing. Just see to it. If I draw this compound, one more question I'm going to give you. If I draw this compound, just see. Bromine, bromine, chlorine, bromine, chlorine. What do you think? This compound is having plane of symmetry, or this is having center of symmetry, or it is having both type of symmetries? This compound is having plane of symmetry, center of symmetry, or both the two symmetries? Now kids, see, it is having both the two symmetries. Both the two symmetries are there. Just see, if I see center of symmetry, I have to sit over here and I have to go vertically opposite. Just see, vertically opposite I have gone, I got bromine. Opposite side also I have got bromine. Vertically opposite I have gone, I got chlorine. Downside I have got chlorine. So center of symmetry is there. If I go diagonally, so diagonal plane of symmetry is also there. So anyways, compound is optically inactive. Got it? Now, after this, I will tell you what is enantiomer, what is racemic mixture, and then I will let you know how to calculate number of chiral carbons and number of other things, and then the Fischer RS configuration. Once I'm going to deal with RS configuration, then you will say, yes, Baba, now we are feeling confident. But it's 12:36 in the morning. It's half an hour past. Still, you are energetic or not? Do let me know. Still, are you energetic or not, kids? Do let me know, my dear students. Baba is too energetic. Very good. Very good. Sir, dinner. Baba will not do dinner. Today, Baba will keep on teaching, keep on teaching. Otherwise, I will feel sleepy. I have to complete this lecture. Kids, if anyone new, hit the like button and call everyone. I want your energy should not go down. For me, your energy matters a lot. Okay, now see kids. See kids, is everyone ready? Is everyone ready? Now see kids. I'm going to tell you about enantiomers. What are enantiomers? Enantiomers. Let me explain first. If I say lactic acid case CH3 CHOH COOH. What do you think? How many chiral carbons are there in this lactic acid? How many chiral carbons are there in the lactic acid? This is lactic acid. So one chiral carbon is there. Now if I put mirror in front of this, this is mirror. We know that mirror is not going to say something false, which is not true. Mirror is always transparent, so it will reflect this compound only, CH3 COOH OH H. This is chiral carbon. It's just like the case of our hands. One form is exactly the mirror image of second form, but they are non-superimposable mirror images. Now, how to visualize they are non-superimposable? Don't visualize non-superimposable. Just remember one thing: if they are not having plane of symmetry, then they will be non-superimposable. So, plane of symmetry, we can see there is only one chiral. Only one chiral carbon means what? I've told you earlier. Only one chiral carbon means only one chiral carbon indicates there is no plane of symmetry. When there is no plane of symmetry, then they are non-superimposable mirror images. Non-superimposable mirror images of each other. And these non-superimposable mirror images of each other, they are known as enantiomers. Enantiomers. And enantiomers are always optically active. Enantiomers are always optically active. Now kids, how to find out which compound will have how many enantiomers or enantiomeric pair? Just like this is one enantiomeric pair, these two are making one pair, so I can say this is enantiomeric pair. Now if this is dextrorotatory, no one can find out which one is dextrorotative, which one is levorotative. If I say if this is dextrorotatory, then definitely that is going to be levorotatory. This one will be levorotatory, my dear students. And if I say that is levorotatory, then that will be dextrorotatory. No one can say which one is dextro, which one is levo. To identify which one is dextro, which one is levo, there should be compound and there should be spectrophotometer. That only spectrophotometer can measure which one is what. Otherwise, we cannot measure. Now, how to calculate total number of optically active isomers? This is the question. Examiner is interested and he will ask calculation of total number of isomers, optical isomers. Now, my dear students, this is very, very important, very, very important. Just like we have studied GI, geometrical isomers, there were the cases. Here also we have got cases. See case number 1. How to find out which one is case number 1? That will play very, very important role. Case number 1. What is this case number 1? Just see to it, kids. Case number 1. If compounds any representation is not having pos or cos, then this is case number 1. Are you able to understand? If compounds any representation is not having pos or cos, then this is your case number 1. And in case number 1, number of optically active isomers, will be equal to number of optical isomers. Now you must be thinking, sir, what is the difference between optically active and optical isomers? This you will come to know whenever I'm going to tell you about the case number 2. But till now, it's it there in your brain so that we can understand. Now let's see. Their formula will be 2 raised to power n. 2 raised to power n. And what is n over here? N is gets number of chiral carbons. What is n? Here n stands for number of chiral carbons. Number of chiral carbons. N stands for number of chiral carbons. Are you ready, kids? Is everyone ready? Now let's see. If I say I have got this compound CH3, CHBr, CHCl, CH3. Could you please let me know what is the value of N? How many chiral carbons are there? If you're active, if you know, if you can find out, do let me know how many chiral carbons are there, kids. Then definitely the answer will be this carbon is attached with methyl, hydrogen, bromine, and this carbon that is different. One chiral carbon, this is also one chiral carbon. 2 chiral carbons are there. Everyone able to understand 2 chiral carbons are there? 2. So total number of N is equal to 2. Then optically active isomers will be equal to optical isomers will be equal to 2 raised to power 2. That is being 4. Now kids, you want to visualize it. How many of you want to visualize it? Do let me know. How many of you want to visualize it? Now if you want to visualize it, just see. The options are, it can be D, D, L, L, this D, this L, this L, this D. These are the 4 options possible. Now if you give another compound, like suppose if I give you another compound, kids, let me add some slides. Now see kids, if I write down this compound, now try to find out number of chiral carbons in this compound. Do let me know how many chiral carbons are there. If you're not able to find out number of chiral carbons, you won't be able to do the question. Fast in the chat section, do let me know how many chiral carbons are there. Hey kids, fast, I want to see. Do let me know kids, how many chiral carbons are there. Fast, fast, fast. Everyone, see, any atom attached with double bonded carbon or triple bonded carbon can't be chiral. Any atom attached to double bonded or triple bonded carbon can't be chiral. Why? Why it can't be chiral, kids? Why it can't be chiral? See, if it is attached with double bonded carbon, only see one hydrogen, only 3 valency is there. How it can be chiral? Not chiral. Now see, has anyone? Yeah, kids, good. 3 chiral carbon. This is chiral. This is chiral. And this is being chiral. 3 are being chiral. So how many optically active isomers and how many optical isomers? That is 2 raised to power n. That is 2 raised to power 3. Answer is being 8. Kids got it? Everyone got it? Now the examiner will ask one question. Fantastic question. Just see to it. He will ask, find out total number of optically active isomers in glucose. Question is, find out total number of optically active isomers in glucose. Now for that, you should know the structure of glucose. If you don't know the structure of glucose, you can't do anything. Now see the structure of glucose. Baba is going to tell you. 1, 2, 3, 4. Like this. CH double bond O, CH2OH, CHOH, 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 CHOH. How to find out number of chiral carbons? See, this is attached with double bond. It can't be chiral. This is chiral 1. This is chiral 2. This is chiral 3. This is chiral 4. So total number of optically active isomers is equal to total number of optical isomers. That is equal to raised to power 2 raised to power 4. 2 2s are 4, 2s are 8, 16. 16 is being done. So can you see? Everyone? Hey kids, do let me know. Can you see? Are you still awake? Oh my God. Very good. Correct answer. Correct. Now tell me for fructose. Fructose. Question for fructose. But if they are asking pyranose ring structure of glucose, let me tell you ring structure of glucose. Pyranose ring structure of glucose. Pyranose hemiacetal ring structure of glucose. How many chiral carbons? So it will look like this. See, everyone. One, two, three, four, four. CHOH, and this oxygen is bonded with this carbon. Now HOH, third number HOH, HOH, H, CH2OH. Now just see how many chiral carbons. 4, already 4 chiral carbons, 2, 3, 4. Now this has also become chiral, known as anomeric carbon. I will let you know in carbohydrate chemistry, anomeric carbon. So in the pyranose ring structure, there are 5 chiral carbons. 5 chiral carbons gets. 1 chiral carbon will get increased. 5 chiral carbons. So total number of optically active isomers is equal to optical isomers is raised to 2 raised to power 5. 2 to the 4 to the 8 to the 16 and 32. Its answer will be 32 kids. Now if anyone is asking what should be the answer in case of fructose, so let's see fructose case kids. Fructose, total number of optically active isomers in fructose. Fructose structure is kids. So see, fructose is like this. CH2OH, C double bond O, CHOH, 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 and CH2OH. Now see kids, how many chiral carbons are there? First is not chiral, second is not chiral. 1, 2, 3. So total number of optically active isomers is equal to number of optical isomers is equal to 2 raised to power 3. That the answer is being 8. Got it kids? And if you see the ring structure will have 4 chiral carbons. Ring structure will have, that is hemiketal ring structure, that will have n value is equal to 4. Then it will come out 16. This is clear to all of you. So kids, how is the Josh? Now after this, Baba is going to tell you Meso, case number 2. Baba is going to tell you case number 2. That is very, very important kids. But see kids, your energy is getting decreased. Students are also getting decreased. Now only 30 are watching, but Baba is there. Baba will complete it. Now, right now 30 students are there, but will you remain or will you also leave? First of all, do let me know, will you be there for the RS system or will you also leave? First of all, do let me know kids. 28, yeah, only 28. The journey started with 100, more than 100. Thank you, JC, Laharika, Suchitra. Very good, very good. So Baba is there to complete the whole isomerism. So let's see kids. It's one kids. It's one. Thank you for being with us. I think only 1 hour. Only 1 hour. Let me complete optical isomerism. If by chance we are not able to complete conformational isomerism, I will let you know conformational isomerism later on. But at least we should complete optical isomerism each and every point. We should not leave. I'm not leaving even a single point kids. That is very, very important. Thank you kids. Thank you kids. See, with your Josh, students got increased. They are now 35. Now see kids, Baba is going to tell you case number 2. Case number 2, just see to it. Case number 2. Very, very important case. Very, very important. Very, very important. Very, very important. This case means when compounds any form is having pos or cos along with chiral carbons. And this case number 2, is further divided in two parts. It is of two types. What are these two types? One is A case, subcase A, with even number of chiral carbons. B with odd number of chiral carbons. So these are the two subcases. Are you ready for this? Because here most of the students, they are going to lose marks. So let me take case number 2, subcase A. Case number 2, subcase A. Now, kids, you must be thinking how to find out whether any case belongs to case A or case B. See, if you see me, always starts thinking from the middle, go to the right hand side and go to the left hand side. This is my form and there is plane of symmetry. In this form, there is plane of symmetry. But if I stand like this, there is no plane of symmetry. So one form is having plane of symmetry, another form is not having plane of symmetry. That means I belong to case B. Now suppose if I am like this, one hand is having book. Now there will never be plane of symmetry because extreme right hand side, extreme left hand side, they are different. So this is going to be always case number 1. So in case number 1, one side should have something different, another side should have different. So always start moving from the middle, go extreme right, go extreme left. If both the things, if all the things are symmetrical, then that will belong to case number B, case number 2, otherwise case number 1. Are you getting my point? Now, in this case, let me take case of tartaric acid. Tartaric acid as an example. Now, kids, how to remember what is the formula of tartaric acid? Just see. CH3. Lactic acid, you know, lactic acid. This was lactic acid. CHOH, COOH. And repeat it. See in the mirror, what you will see in the mirror? CHOH, COOH. So this is your tartaric acid. Now let me draw number of forms of tartaric acid. Just see to it. Try to understand. One form, its mirror image. Second form. Third form, its mirror image. Just see. Kids, this is H, this is OH, this is H, this is OH, COOH, COOH. First of all, do let me know, this is having 2 chiral carbons, but this compound is having any plane of symmetry. If you divide it in 2 parts, see, if you divide it from here, upper side there is OH, downside it is H. No pause, no plane of symmetry, no plane of symmetry. That means it is optically active. If it is this being optically active, its mirror image, see, if you see it in the mirror, it will look like this. If that is optically active, its mirror image will always be optically active. So these two are optically active and these two are having relationship of mirror images with each other. So we will say they are enantiomeric pair. Is it clear? They are being enantiomeric pair, kids. Is it clear? But if I draw this compound, just see, have a focus on this. If I draw this compound, OH, OH, H, H, COOH, COOH. Just see, if I divide it from here, what can you see? Do let me know. You can see from here the plane of symmetry is going. It is having plane of symmetry. Can you see, kids? If I divide it from here, you see it is having plane of symmetry. Can you see? This is the plane of symmetry. This plane is dividing it into two equal parts. Can you see? This plane is dividing in two equal parts. So this compound is having plane of symmetry along with two chiral carbons. Two chiral carbons are there, but then also this is the plane of symmetry, and this plane of symmetry is dividing this compound in two equal parts. Just see to it, kids. This is the pause, that is plane of symmetry dividing in two equal parts. So what will you say? The half part of the compound is rotating the light in the clockwise direction. If I see from COH to OH and COH to OH, other half is dividing it, means rotating the light in anti-clockwise direction. Sir, what is this? We are not able to understand. Let me tell you, kids. Let me explain. See, if I see from COH to OH or OH to COH, whatever you want to see, you see OH to COH, light is going anti-clockwise. So from here also OH to COH, light is going anti-clockwise. There is no light, no compound, but let's, for the reference we are comparing. Then there also, let's say OH to COH, if I'm going from OH to COH, just see, light is going what? Anti-clockwise direction. But see here, OH to COH, the light is going from where to where? OH to COH, it is coming clockwise direction, clockwise direction. So cancellation is there. Are you able to understand? Everyone able to understand? So they are cancelling of light. Such type of compounds is known as optically inactive. Why optically inactive? See, half portion is rotating the light in clockwise direction. Another half is rotating the light in clockwise direction. So due to internal compensation, this compound has become optically inactive, my dear students. And such type of compounds are known as meso compound, mesotartric acid. It is optically inactive. But kids, are you still awake? Kids, now see, these compounds are rotating the light only in one direction. These two compounds are rotating the light only in one direction, but its half is rotating in clockwise and half is rotating anti-clockwise. And so due to internal compensation, this compound is optically inactive, and such compounds are known as meso. Now see, meso compounds are optical isomers. This is optical isomer. but not optically active. Sir, what is this? If any compound is rotating the light, that is optical isomer. If any compound is rotating the plane polarized light, it is optical isomer. This is rotating the light only in one direction, so this is optical as well as optically active. It is optical isomer as well as optically active. This is optical as well as optically active. This is optical isomer but not optically active. It is rotating the light, but half is rotating in clockwise, half is rotating anti-clockwise, so it is not optically active. And Meso's mirror image is also Meso. They are identical. Meso's mirror image is also Meso, and they are identical. So these two are identical. So total 1, 2, 3. They are identical. So 3 optical isomers out of 3. 2 are optically active and 1 is Meso. Now kids, this I have told you manually. What I have told you manually, that if anyone is going to ask about tartaric acid, the biodata of tartaric acid, so the answer for tartaric acid will be what? That tartaric acid is having total 3 optical isomers. Out of these 3 optical isomers, 2 are optically active, 1 is Meso. This is the biodata. Now, my dear student, you must be asking, sir, if by chance they are not asking tartaric acid, how to do it? Because this is going to take too much time. Is there any formula? Kids, do let me know. Do you want formula for this? So, Baba is going to give you formula for this. See, formula is case 2 subcase A total number of optical isomers is equal to 2 raised to power n minus 1 plus 2 raised to power p minus 1. Now kids, this formula you have seen somewhere in geometrical isomerism case number 2 subcase A. The same formula you have seen over there. Now here n is number of parallel carbons and p is equal to n by 2. P is equal to n by 2. Now for tartaric acid just apply. And one more thing, let me tell you kids, this is indicating optically active, and this is indicating Meso. Let's apply the formula. 2 raised to power 2 minus 1 plus 2 raised to power p is n by 2, 2 by 2 minus 1. So what will you get, kids? 2 raised to power 1 plus 2 raised to power 1 minus 1, 0. So just see, 2 are optically active and 1 is being Meso. Hence, declared each and everything is clear, kids. Is it clear to all of you? Each and everything is clear, kids. Now, kids, the most important thing Baba is going to tell you. Are you ready? Are you ready for that? Is everyone ready? The case number 2, subcase B. Case number 2, once this question has been asked in AIMS and 3 times for IIT. Case number 2, subcase B. See the compound, very, very important compound, just see. COOH, CHOH, 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 COOH. Now, my dear students, how to find out this is case 2? Right now, so I am telling you this is case 2, but in the examination, no one will be there to tell you. So just see, stand in the middle of this compound and move on the right hand side and left hand side. You see, on the right hand side, whatever you are getting, same appearance you are getting on the left hand side, same thing. And number of chiral carbons are how much? This is chiral, this is chiral. These two are being chiral carbons. But this is known as pseudochiral or prochiral. Now, what is there? Why it is known as pseudochiral or prochiral? That is the story. Pseudochiral means false chiral. Pseudochiral, you know, pseudophores, or prochiral. Now, my dear friends, this is very, very important. Very, very important. Is everyone ready? And I can see the dedication. It started with more than 100 and now it's 22. 22 only, kids. But you are going to be the winner, kids. Let's see. I'm going to draw. This compound are having, first let me tell you the answer. You can cram it. Total 4 optical isomers, out of which 2 optically active and 2 being meso. 2 optically active and 2 being meso. Let me explain it. Let me explain it. Just see to it, kids. COOH, COOH, OH, 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 H, H, H. Just see, kids. Right now it is having 3 chiral carbons. 1, 2, 3. Now you will say, sir, at there you said it is pseudo-chiral. Now you have started saying all 3 are chiral. That is the twist in the story. See, kids. Story is really awesome. This is chiral, this is chiral, this is chiral. All 3 are chiral and no plane of symmetry is there. When no plane of symmetry is there, let me say water image. Water image means if you see yourself downward side, if the mirror is downward side, you will get mirror image, or you see inside the water. Bahubali movie, she was seeing inside the river. So your face will be visible, water image. So its water image will be like this: H, H, OH, COOH, COOH, H, H, OH, no plane of symmetry. So both of them are optically active. This is the mirror image of this, and they are having the relationship of enantiomers. They are enantiomers. Now these two are optically active. These two are optically active. This is chiral, this is chiral, this is chiral, this is chiral. All 3 are being chiral. Now, the story is there. Wait just for a second. See, kids. Now, if I draw it like this, I draw it like this, just see, it's mind blowing. OH, 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 COOH, COOH, H, H, H. Now see kids, there is plane of symmetry. If you see clearly, you can see that there is being plane of symmetry. Just see to it. See to this. There is being plane of symmetry. See kids. Can you see? Can you visualize? This is the plane of symmetry. Is over here. Here is the plane of symmetry. Can you see kids? This is dividing the compound in two equal parts. So this is chiral. This is chiral. And this is not chiral right now, not chiral, because from here two equal parts the compound has been divided. So it's like this. Suppose there were three friends during their school time, but in college time, in the school time, that there was Ramu, Pandu and Champa. In the school time, Ramu, Pandu and Champa, all three were close friends, but during the college time, Champa got changed. When the history is written, what will you write? Champa to be. So during school time, Champa was friend. During college time, Champa was not friend. Or you can say Champa was pseudo friend. Either you say during the, if you want to tell in long detail that Champa, when they were in school time, Champa was their friend, but when they have gone to the college, Champa was not the friend. If you don't want to say that much long story, in short, you will say Champa was pseudo friend. Are you getting my point? So it's detailed in those two. Champa was friend, here Champa is not friend, and this is Meso. Meso's mirror image will be Meso identical. Mirror image will be Meso identical. So it's mirror image and this, they will be identical. Identical are also known as homomers. Now kids, there is story still ahead. Just see. Story is not ended. If I write OH, OH, H, OH, H, H, COOH, COOH. Now just see to it. There all three OH were up, but here two OH are up and one OH is down, but still there is plane of symmetry, you can see. This meso is different from that meso. Can you see? This meso is totally different from that meso. So there are two mesos. This is also meso, and here this is your chiral carbon. That is your chiral carbon, but this is not chiral, not chiral. So this is meso. Meso's mirror image will be meso identical, but there are two mesos, two optically active and two mesos. Everyone got it? Now in this only RS system, I have to tell you everything I have told you about optical isomerism. Only what is left, RS system. Is everyone ready, or should I give you? Oh my god, it's 121. So should we take 10-20 minutes break or 15 minutes break, kids? 15 minutes break. Okay, can we take 15 minutes, or should I continue? Or should I continue, kids? Should I continue, or should I take 15 minutes break? Continue. Okay. See, let's see RS system. Let's see RS system. Is everyone ready? Show me thumbs up. Show me some thumbs up, kids. I'm going to deal with RS system. R and S configuration. Okay, let me write down how many types of configurations are there. Types of configurations used for chiral carbon. Types of configurations. One, two, three, four. This is very, very important for examination point of view. Very, very important, kids. First is R and S configuration. This is absolute configuration. Absolute. Very, very important. Second is capital D and capital L configuration. Relative configuration. This is being relative configuration. Third is trio erythrio configuration. And last one is small d and small l. This is experimentally determined. Now, kids, what I've told you, optical isomerism is the backbone of isomerism, and this what I'm going to tell you, this is the backbone of optical isomerism. Is everyone ready? Because this is very, very important. This one is very, very important, kids. Really very, very, very important. Is everyone ready? Wow, I can see the fire in the chat section. Now see, kids, this is very, very important and we have to understand this. Then these are very easy. See, there are two types of representations. There are two types of representations. There are two types of representations of chiral compound. One is Fischer projection, another one is flying wedge dash. Fischer projection, another one is flying wedge dash. Flying wedge and dash. So we will start with Fischer projection. Is everyone ready, kids? Everyone ready? Wow, kids. Wow, that's really awesome. Now see, R and S configuration in Fischer projection formula. R and S configuration in Fischer projection formula. Now, kids, what he said, suppose if I draw tetrahedral like this, 1V, can you see 1V? Now, the another V. What Fischer said the thing, you just see first of all, one is coming towards your side, one is going away from you. and 2 are in the plane of paper. Now you see 2 are coming towards your side and 2 are going away from you. Can you see? The same way 2 valencies are coming towards your side and 2 are going away from you. Can you see? Can you see, kids? 2 valencies are coming towards your side. Let me hold it. A 2 valencies are coming towards your side too. So what he has done, this 3D diagram, he has made it 2D. So the valencies which were coming towards your side, he made it horizontal line, and the valencies which were going away from you, he made it vertical line. So he made it like 2D. So I'm going to draw 2-dimensional, but you have to remember it. What he has done, he is drawing it like this, like this, like this, but actually it is like this. The horizontal line is coming towards your side. This means towards your side, bold, towards observer side. The horizontal line valencies are coming towards observer side, towards observer, kids, towards observer side. And the vertical line means going away from observer, dash, going away. Foreign writers, they will draw like this. Indian writers, they will draw like this. If I say that here is A and B, that means A and B are going away from observer. And if I say here is X and Y, so X and Y are coming towards observer. Can you understand? Towards observer. X and Y towards observer. So these two are same. These two are being same. There is no change. This is just the way of representation. This is 2D figure, 2-dimensional, and that is being 3D. 3D and 3D. So Fischer has drawn in 2D and he was saying just try to understand in 3D. Everyone, are you getting it? He has drawn in 2D and he was saying just try to understand in 3D. Just what you're supposed to do. With this figure, let me tell you, in your brain, just you have to keep one thing in your brain, that vertical line means what? Vertical line is indicating what? Any atom which is attached on vertical atoms. Suppose if I say M and N, vertical line atoms means away from observer, away from observer, away from observer. So if I say the atoms which are attached to horizontal line, suppose if I say there is L and D. What is L and D? Let me write down. There is any U and V. U and V. So U and V, horizontal atoms, horizontal line atoms towards observer, towards observer. I hope this much is clear to all of you, and this is being chiral carbon. In the center, this is being chiral carbon. Is it clear, kids? Those who are there have to take care of those students. Those who will see the recorded lecture have to take care of those students also. Till now, everyone, this is clear. Now see, kids, I'm going to tell you RS system. Once again, let me take some more slides, add some more slides. First of all, hats off to you kids. I will appreciate you kids. Really, you are dedicated students. Because of you, I'm here. Otherwise, I won't be able to complete this isomerism. You are there, and that's why I'm getting some energy to complete this. Really, really salute to your hard work, kids. Now, see, rule number one. Baba is going to tell you rule number one, kids. Rule number one. Give number one to most senior according to CIP rule and give number four to least priority group. LPG. This is rule number one. CIP rule, you know very well. This is rule number one. For example, if I write down like this, H, iodine, bromine, chlorine. So who will get number one? Iodine is most senior. 2, 3, this is 4, least priority group. I think rule number one is clear to all of you. If yes, show me thumbs up. Okay, right. Now 31. They are back. Oh, that's really awesome, kids. Really awesome. See, some of your friends, they have come back. Now, this rule is clear. If yes, show me thumbs up. Let's have some energy, kids. Let's have some energy, kids. Rule number one. Is it clear to all of you? Is it clear to each and everyone? Rule number one, yes. Now, rule number two. Rule number two. Move from 1 to 2 in the decreasing order of seniority. In the decreasing order of seniority. Okay. The same compound C, which we have drawn. Iodine, bromine, chlorine. Just see. Iodine, bromine, chlorine. Iodine, bromine, chlorine, hydrogen. This was number 4. LPG, 1, 2, 3. So let's move. As we are moving, so rule number 3. Rule number 3. What's rule number 3, kids? For clockwise arrow, R configuration. Oh, we got it. R configuration. And for anti-clockwise arrow, S configuration. That's it. But provided that if LPG is on vertical line, if LPG is on vertical line, remember this. This is very, very important. If LPG is on vertical line, right? vertical line, then arrow is moving anti-clockwise. What we call it? Clockwise R, anti-clockwise S. What is the configuration of this compound? What is the configuration? Yes, kids, do let me know. Very good, Darshani. Do let me know what is the configuration of compound anti-clockwise, and this is over here. Definitely, it is S configuration. S configuration. You got it? Everyone got it, kids? Do let me know. Now, rule number 4. Rule number 4. If LPG means least priority group is on horizontal line, then for clockwise arrow, we will say S configuration, just opposite of that. And anti-clockwise arrow, we will say R configuration. R configuration. Is it clear to all of you? In this way, we can solve any question. Now, let's solve questions if you are able to understand. But as the time passes, you will forget which direction, which R, S, you will forget. So, let me give you trick. Brainy Baba's trick. Brainy Baba's trick. Brainy Baba HSP. Brainy Baba HSP trick. Haryana Basi. HAR VAS. What is this HAR VAS? H for horizontal line. If LPG, remember that this is all for LPG. They are related with LPG. LPG. If LPG is on horizontal line, if LPG is on a horizontal line, arrow is going anti-clockwise, then it will be R configuration. If LPG means least priority group, LPG is what? Fourth priority group. If LPG is on vertical line, kids, vertical line, arrow is going anti-clockwise, it will be S configuration. Are you able to understand this trick? If LPG is on LPG HAR, LPG VS, LPG is on horizontal line, anti-clockwise arrow, R configuration. LPG is on vertical line, anti-clockwise arrow, S configuration. How is the trick? Hey kids, how's the trick? How's the Josh? How is the trick? How's the Josh? Do let me know, kids. Wow, kids, you are my army. HSPN army. You are my army, kids. You are my army. Now, we can apply this trick anywhere, everywhere. Now, see, kids. Now, can you make trick and your trick LPG HAR. Oh, my name HAR Harendra. Harendra. My name, kids. Harendra. My name's initial. Now, VS. What do you say about VS? HAR VS. HAR VS. HAR is my name. And VS. VS is what? Very awesome. HAR is very awesome. HAR is very awesome. So this is another trick. HAR is very awesome. See, kids. Now see, let's do some questions. Now let me check it out whether you are able to do all these questions or not. First question, tell me if I say hydrogen, iodine, bromine, chlorine, R configuration or S configuration, do let me know. R or S. Let's see whether you are able to do it or not. Let me check it out, kids. Oh, kids. See who has made it. See, fantastic. HAR and Wasim. Harendra sir or Wasim sir. Hey, Laharika. Harendra sir and Wasim sir. HAR and Wasim, chemistry legends. Oh, Nandini made it. Claps, Nandini, claps. Today you have done it. Done it. Done it. Really done it. HAR Harendra sir or Wasim sir. Oh my God. So just send LPG cylinder to Harendra sir and Wasim sir. Just send LPG cylinder to Harendra sir and Wasim sir. Then you will get R and S configuration. Really awesome, really awesome. So solve this question. Solve this question. R configuration or S configuration? Do let me know, kids. Is it R or S? Do let me know, R or S. Yes, everyone is saying yes. Let me check it out. This is S or not. Number 1 to this, number 2 to this, number 3 to this, and arrow is going zoom clockwise. And LPG is over here. Oh, gates. How it is S? Arrow is going clockwise. This is over here. So this is R configuration. Why S? Why S? Kids, R or S? R. It's R. Let me give you another one. Let me give you another one. Iodine, bromine, hydrogen, chlorine. R or S? R or S? Do let me know. Is this R or S? R. Everyone is going for R. Let me check it out. Number 1, number 2, number 3, number 4, LPG. Arrow is moving zoom clockwise. So this is R. So this time, should I give you a little bit tougher one? Little bit tough. Just see. IBR HCl. This is a bit tough. I'm going to solve it. See, number 1 over here, number 2 at this place, 3 is over here, and 4 at this place. Now, which side will you go from 1 to 2? Always remember that if you go this side, this is wrong, because while moving from 1 to 2, you cannot cross third priority group. While moving from 1 to 2, this is allowed. You can cross least priority group. This is correct. That was incorrect. Let me write down. While moving from 1 to 2, we can never cross third highest priority group. We can cross LPG. See, on our way, if we are going to home, back to home from our coaching, one side there is ant, another side there is loin. Which way would you like to go? You can cross loin, or you would like to cross ant, cat, rat. So this is the least priority group. You can cross like this. You can never cross like that. So 1 to 2 arrow is going anti-clockwise direction, and this is on vertical line S configuration. Am I right, kids? Am I right? Is it clear to all of you? Do let me know. Yeah, my God. Yes, yes. Now see, one question for you. One question for you, kids. Hydrogen, COOH, iodine, chlorine. Do let me know. R or S? Is it R or S? Do let me know. R or S? S. R. Somebody is writing R. Someone is writing S. Let me check it out. Number 1, this. Number 2, this. Number 3, this. Don't see COH. It is C only. Number 4, this. Arrow is moving. Most of the students are thinking it to be COH. Just apply CIP rule. Don't see IUPAC. 1 to 2 arrows moving clockwise, but least priority group is on horizontal line. So LPG is on horizontal line, and arrow if moves anti-clockwise we will say R, but if LPG horizontal line and arrow is moving clockwise, then we'll write opposite of this HCS. That means S configuration. This is S configuration. How many of you got it? How many of you got it? Just opposite. LPG, HAR, so HCS. Anti-clockwise R, clockwise S. Opposite of that. Got it? Everyone got it? Now, if this is clear to all of you, I'm going to tell you R and S configuration in flying wedge dash formula. Is everyone ready, kids? Is everyone ready? R and S in flying wedge dash formula. Now, how to write flying wedge dash formula? Let's see. These two valencies are in the plane of paper. This is chiral carbon. One valency is coming towards observer side. Let me draw with another pen. This is coming towards observer side. Just see to it. It is with bold like this. Just see. And one valency is going away from observer like this. Can you see? If I say here, if I'm writing iodine, here if I'm writing bromine, chlorine, hydrogen, that means iodine is coming towards observer side. That's why it is looking thick towards observer. This is going away from observer. This is known as wedge. Towards observer is known as wedge. This is known as dash. And these two are in the plane of paper. In the pop, pop means plane of paper. Now kids, let's find out its RNS configuration. But really, I will say, my dear students, you kids are finally very energetic, very energetic. You have proved that you are highly energetic kids, highly energetic kids. Now see, if we understand how to convert this into Fischer projection, how to convert this formula into Fischer projection, we can do any question. Now, how to convert flying wedge dash to Fischer? How many of you want to know, and how many of you are interested, and how many of you are energetic that conversion of, to learn this, conversion of flying wedge dash to Fischer projection, to Fischer projection. Now let me draw one flying wedge dash. So see, let me draw Fischer. Fischer means plus sign, doctor sign. Always remember one thing, that any group which is attached, group or atom which is attached on dash line, the rule is atom or group attached to dash line in flying wedge dash put it on vertical line of Fischer. Put it on vertical line in Fischer. Now vertical line is this, either top or bottom, either at top or bottom. Anywhere. One point is clear. Rule is atom or group attached to dash line in flying wedge dash, put it on vertical line in Fischer, either at top or bottom. You just do let me know where to keep it. Should I keep it at the top or bottom? This hydrogen is on dash line. So let's suppose I've kept it at the top. Now rest of the atoms you have to keep as it is. Rest of the atoms you have to keep as it is. Rest of the atoms as it is. Keep rest of the atoms, rule number 2. Keep rest of the atoms or groups as it is. Now the chlorine is over here. The chlorine, see, the chlorine is over here. This position is blocked. So let's slightly tilt it. chlorine will come over here, bromine will come over here, and iodine will come over here, and these two are same. This compound and that compound same. Now you can see number 1, number 2, number 3, number 4. Arrow is moving in which direction? Arrow is moving in the anti-clockwise direction, and this is on vertical line. So LPG is on vertical line, anti-clockwise arrow. S was same. Got it? So it is S configuration. Everyone got it, kids? Do let me know if you are able to understand. How many of you got it? If you haven't got it, do let me know. I will give you another example. Okay, let's see another example. Those who are unable to understand it, for them. Let me take copies. See, kids, because this in one time you can't understand in one go, so I am making another one. Just see to it, everyone, because your understanding is very, very important. Nothing is more important than that. This is being chiral carbon, and if I place here, suppose any atom, hydrogen I have placed over here, bromine here, chlorine here, and CH3 at this position. Now let's convert it into what? Fischer. So I will draw plus sign. What I've told you, any atom which is attached on dashed line, this is attached on dashed line, you have to keep it on vertical line. So I've kept it over here. Now rest of the atoms as it is. So chlorine here, CH3 here, hydrogen here. Now you will say, sir, again and again you are keeping bromine at the top. This is no way correct. Just keep bromine downside. Okay, let me keep bromine downside. Dash, any atom dash, there I have kept at the top, and I have given you the facility you can keep it at the bottom. You have kept it at the bottom. Now see, I have removed this. Now hydrogen, little bit shift this side, this is on hold. Now let me put hydrogen over here. After hydrogen there is chlorine, after chlorine there is methyl. Now you will say, sir, why have kept it over here? Don't do that. Let's make another one. Okay, no problem, kids. Let's whatever you want to do. Bromine you want to keep downside. Now what are you saying? Hydrogen you want to shift that side. Okay, shift it. After hydrogen there is methyl, after methyl there is chlorine. All they are same. Now kids, I told you all of them are same. You have to find out the configuration. The configuration will definitely come out same. That's my challenge. Let's see. One by one, let me solve it. Here, number 1 is bromine, number 2 is chlorine, number 3 is carbon, number 4 is this. This is your LPG. Now, arrow is moving in which direction? Do let me know. Arrow is moving 1 to 2, and like this. Arrow is going clockwise direction, and this is over here. This is being S configuration. So if they are not coming as configuration, then I have told you everything wrong. Number 1 this, number 2 this. We can cross over this. So arrow is going which direction? It is going clockwise, and it is over here. So S configuration. Now in this number 1 this, number 2 this, arrow is going clockwise direction, clockwise, and this is over here. So this is S configuration. So that means this is also having S configuration, and all 4 are same. All 4 are identical. Now everyone able to understand Baba is how brainy Baba, how much brainy Baba. I can write whatever you want, Baba will write, and you will get the same answer. You got it now? Everyone able to understand. See, Baba has written so many things. They all are being identical. So visualization power should be there. Now, Baba is Baba. Now you got it. Now you got it. Now, after this, we have to go towards capital D and capital L. Is everyone ready, kids? It's 2 and 2. Oh my God. It's 2, 2. 9 hours gone, kids. 9 hours. Now we are going to deal with capital D and capital L configuration. Are you ready, kids? Capital D and capital L configuration. See, kids, this is used at two places in your chemistry. In carbohydrate chemistry and amino acids. It is used in these two places, capital D and capital L. And remember that capital D has nothing to do with dextro and levo. Remember that capital D is different thing, small d is different thing. One thing, let me make it very clear. This point to be noted, my lord. Capital D and small d, they are different things. Capital D and small d are different. They have no relation. They have no relation. This is the point to be noted, my lord. Very, very important point. Okay. Now, let me tell you in carbohydrates and then in amino acids. Is everyone ready? Is everyone ready, kids? Now you can call all other friends. Hey, wake up, kids. It's a time, morning. Everyone, wake up, kids. It's a time to wake up. Now, kids, in carbohydrate chemistry, in carbohydrates, this is glyceraldehyde. Now remember that Fischer said you have to write in this order only. Vertical line is parent chain and most priority group should lie at the top. Should be present at the top. Now, if these two are on the same side, last and second last carbon, how to say last and second last? 1, 2, if you do IUPAC, this is last and second last. You have always to see second last and last. This is being last, this is being last carbon. And after this, they are on same side. Once they are on same side, we will say D. D configuration. This is D-glyceraldehyde, capital D. We don't know this is dextro or levo. That we don't know. This is D-glyceraldehyde. If they are on opposite side, just like see, they are being opposite side. This is L-glyceraldehyde. It's L-glyceraldehyde. Now, if you see any compound, not only this compound, if I talk about any compound just derived from this, or this is being derived from this, glucose is being derived. So if I draw glucose structure, so which carbon I have to focus? Just see to it. Which carbon I have to focus? 1, 2, 3, 4. CHO, CHOH. So just to see whether it's D or L, which carbon I have to see? 1, 2, 3, 4, 5, 6. I have to consider the last and second last. They are on same side. Same side. So its name will be D glucose. Now you must have seen it is written like this. This capital D means for this. This plus sign means experimentally or in nature. In nature, it is dextrorotatory, small d, dextrorotatory. So everyone got it? Here, till now it is clear to all of you. Now kids, very, very interesting question I am going to give you and just try to understand. Just see to it. Very tough question. Rank deciding question Baba is going to give you. See. A good question. What is the question, sir? Question is find out R and S. No, find out D and L. D or L. The compound is like this. CH2OH, OH, CHO, H. Now, my dear students, this is a real problem, and to understand how to do this question, you should know 3 processes. Thank you, Nawab's World. Thank you. You should know 3 processes. What are these 3 processes? Without those 3 processes, you can't do this question. Are you ready? I want to see in the chat section. Are you ready? Are you ready, kids? No, kids, I have to complete the syllabus. Then only I can sleep. Otherwise, I will not sleep. See, kids, to do this question, we have to know 3 processes. The processes are like this. By doing these 3 processes, configuration will not change. See, let me take a compound. This is compound, and I will prove it. Let's take iodine, bromine, hydrogen, chlorine. Process number 1, by doing even number of exchanges, let's see what is that. Means if you keep bromine over here, hydrogen will go over there, one exchange. Then iodine will come over here, chlorine will go over there. See how it will look like by doing even number of exchanges. Just see to it. It will look like this. The hydrogen will go over there, bromine will come over there, one exchange. This will go over there, this will come over here. Now see, bromine over here, hydrogen over here, iodine at this place, and chlorine at this place. Are you getting it, kids? Everyone? Now they will have same configuration. Let's verify. 1, 2, 4, 3. Arrow is going clockwise direction. And it is on vertical line. LPG is on vertical line. R configuration, definitely that has to come R configuration. 1, 2. Arrow is moving anti-clockwise direction. And this is on horizontal line. So this is also see HAR, that is R configuration. Just see why LPG. I have told you LPG, Haryana Vasi. This is on H, anti-clockwise arrow, R configuration. This is the first method that while making even number of exchanges, configuration is not going to get changed. Clear to all of you? Now see the second process. Everyone clear? This is clear. Now second process is this was our compound. By rotating the whole compound through 180 degree, by rotating the whole compound through 180 degree, in the plane of paper. That means you have not to leave that. Suppose if I say this is the compound, kids, this is the compound, white one is the compound, and this is the plane of paper, I will rotate it so that this part will come down and this part will go up. So 180 degree. Are you getting my point? 180 degree. The upside down, like this plane of paper. Are you getting my point? So see to it. Everyone see to it that if I rotate it through 180 degree in the plane of paper, the east will become west and the north will become south. Are you getting my point? East will become west and north will become south. So see, iodine will come down. Hydrogen will go up. Bromine will come to this side and chlorine will go over there. The configuration will not change. This was R, no? This was R. 1, 2. We have gone through clockwise and we got R. That has to be R. If that is not coming R, that I have told you everything wrong. Just check it out. 1, 2. Arrow is moving clockwise, but this is on vertical line. LPG is on vertical line. So it is going clockwise. It is R configuration. Now, two methods, you got it. Everyone, now I'm going to tell you the third method, and that is really awesome. Till now, is it okay? Till now, is it okay? Everyone is able to understand. Do let me know, my dear friends. Till now, is it okay? Everyone, is it clear to all of you? Now, see, kids. Third process is mind-blowing. That will increase your speed for number of questions. The process is Third process. Third process. This was your compound. Have to prove it also. IBr H and chlorine was there. This was having R configuration. The process is by holding anyone, by holding anyone and rotating other three, and rotating other three. Clockwise or anti-clockwise direction. Just see, whatever you say, I will do that. Do let me know, kids. If I have drawn like this, which atom you want to hold out of these four? Do let me know. I will do that because this is going to be very, very important. Any atom you select, I will hold that. Do let me know which atom you want to hold, kids. Everyone. Do let me know which atom you want to hold, kids. Iodine. So iodine is on hold. Iodine is on hold. So let me fix iodine here. Now only three places are left. You want to rotate other atoms in clockwise or anti-clockwise direction. Do let me know. You want to rotate other atoms in clockwise direction or anti-clockwise direction. Clockwise direction. Rotate others. Rotate clockwise direction. Clockwise. So this is on hold. You want chlorine right hand side or downside? Chlorine you want on right hand side or downside? Just do let me know. By rotation, chlorine you want right hand side or downside? Do let me know. Right hand side or downside you want chlorine? Downside. So we will make rotation like this. The chlorine will come up to here. So chlorine, if chlorine is coming here, this hydrogen will go there. This hydrogen will go there, and we are rotating this. So chlorine is here, hydrogen is here, bromine will go. We are rotating just in front of chlorine. There is bromine, not hydrogen. So after chlorine there is bromine, and after bromine there is hydrogen. Kids, okay, let's check it out whether it is having R configuration or not. Just check it out. So number 1 should be given to this, number 2 to this, number 3 to this, number 4 to this. Let's see, arrow is moving in the anti-clockwise direction, but this is over there, LPG is over here, so its configuration is R configuration. Just see. Got it? Hence proved, kids. Hence proved. Hence proved. Just see to it. Just see to it. And do let me know you are able to understand. Okay. Now you must be thinking, sir, we don't want to rotate like this. We want to rotate in another direction. How many of you want to rotate in another direction? Let me take another one. If you're not able to understand, see. See, if you want to rotate in another direction, I can do that. Iodine, bromine, hydrogen, chlorine. Let's see. This time you want to rotate in which direction? Do let me know. Which atom you want to hold? Which atom you want to be on hold? Yes. Darshani, you tell me. No, anti-clockwise it okay. Which atom you want to hold? Chlorine. So let's chlorine on hold. Chlorine on hold. Chlorine on hold. Okay. Rest of the atoms you want to rotate in clockwise or anti-clockwise? Oh, Darshani is saying bromine. Okay, next time I will keep bromine. Okay, let me keep here bromine. One more. Let me take bromine. Okay, bromine on hold. Here bromine on hold. Okay, bromine on hold. Now tell me, you want to rotate in clockwise or anti-clockwise direction? Which direction? Clockwise. One is saying, Darshani is saying anti-clockwise and Nandini is saying clockwise. Okay, let's see rotate it clockwise and let's see rotate it anti-clockwise. Okay, now see kids, clockwise. So chlorine is on hold. If you want to rotate clockwise, iodine you want to place over here. Okay, let's place it over here. If iodine is coming over here, see, if I am moving, my nose is moving, if my nose is moving this side, my ears are also moving this direction. So the whole body parts will move according to the sequence. So if iodine is coming over here, just next to iodine there is bromine. Bromine will come at this place, and after bromine, hydrogen will go over there because this place is blocked. Now if you want to make anti-clockwise direction, which is on hold, bromine is on hold, anti-clockwise direction. So if hydrogen is going over there, so after hydrogen, bromine is on hold, iodine will come over here, and after iodine, chlorine is over here. The rotation you understood. Once the rotation you understood, now see the configuration will come out R, because I've told you with that will not get changed. 1, 2 is moving clockwise, and this is on the vertical line, so R configuration. Number 1, number 2, we can cross least priority group clockwise, and this is over here R configuration, and this is R configuration. So they all are being identical. You got it? Kids, have you seen the magic? Baba's magic? How much visualization have you ever seen anywhere? These things have you ever seen anywhere? Have you ever seen anywhere? This is only with magical chemistry group Baba HSP. Baba HSP is going to make such brilliant things. Kids, such brilliant things only Baba HSP can give you, kids. Now, after this, let's go to that question for which we have seen these three processes and this question. Just see. Now try to apply your brain. Try to apply your brain and let's see whether you are able to do this question or not. I want to see your answer, then I will let you know how to do it. Then only I will let you know how to do it, kids. Yes, apply your brain. Just apply your brain, kids. I want to see who is going to give the answer. If you're not able to do it, then do let me know, I will do it. If you are unable to do it, do let me know, I will do it. L. Laharika is writing L. Let me see others, what others are saying. What others are going for. D. D. L. Now see kids, let me tell you. This is not according to Fischer. This is not written according to Fischer. That is clear. Not written according to Fischer. This is not written according to Fischer because this is not the parent chain. Fischer said the parent chain should be like this. Parent chain should be like this. According to Fischer, this should be the parent chain. So this is okay. hold CHO, can we do this? We are going to convert it into this, and we know that the top priority group should be at the top. So holding CHO is in hold, and rotate other three. So let me write down over here, hold CHO, and rotate other three. We want this CH2H at the bottom, so rotate in clockwise direction. So we will get it like Fischer. So rotate other three in clockwise direction. So this will come over here, and after CH2OH, who is there? OH. OH will come at this place, and after OH it will come over here. Now see, my dear friends, this is according to Fischer. You got it? This is written according to Fischer. This is according to Fischer. Are you getting my point? According to Fischer format we got. Now this OH and this OH are opposite, so this is L configuration. You got it? Last carbon OH and second last carbon OH opposite, we got L configuration. You got it? Such a rank deciding question. It's being rank deciding, kids. Others will not be able to do this question, because for this you should have knowledge how to write down the way Fischer has said. Everyone, kids, you got it? Now in amino acids, is everyone ready? So kids, is everyone ready for amino acids? Do let me know. Let me check it out. How is the Josh? Kids, Josh is high. Is the Josh high? So let's see, kids. Let's see in amino acids. In amino acids, D and L in amino acids. All amino acids are optically active except glycine. What is the formula of amino acids? Let's see. NH2 CHR COOH. There is one chiral carbon in amino acids, chiral carbon, but in glycine the formula is NH2 CH, in place of R there is R H COH. So this is hydrogen, so not chiral. So this is amino acid, and all amino acid there is one chiral carbon. So due to chiral carbon, no pos, no cos, so optically active. Now, my dear friends, how to decide whether this is going to be capital D or capital L? Oh my God, everyone is ready and everyone is optically active. Now see, kids, let me take some more page. Pages are getting filled again and again. Now kids, just see. So remember that S will give you L, and what is left? R will give you D. This is absolute configuration. And this is relative configuration, and that's why it is known as relative configuration. But provided that COH must be on second position. According to CIP rule. Let's see kids. If the compound is given like this, NH2, H, CH3, COH. Now, who is on number 1? N. Number 2, C and C, but O, winner by O. 3, 4. Whether this arrow is going clockwise or anti-clockwise, just check it out. 1, 2, arrow is moving clockwise or anti-clockwise. This is going clockwise, and least priority group is on vertical line. So we'll say this is R configuration, and for R configuration I have told you what? R is D. So its answer is D. D. You can remember SL, SLRD, Salman, Research and Development. Suleiman are red Salman, anything, whatever you want to make trick for it. Got it kids? Everyone got it? Now trio and Ri3O. I am going to tell you about trio and Ri3O. Is everyone ready for trio? Of in 21 to 22 years, only once it has been asked. Trio and Ri3O. How's the Josh? Let me have a glass of water. Oh, 2 bottles got finished. Let me take water from the 3rd bottle. Let me take some water from the 3rd bottle, kids. How's the Josh? Do let me know how's the Josh. Five minutes break. Okay. So will you be back after 5 minutes? If I give you 5 minutes break, will you be back? Okay. So let me give you 10 minutes break, not 5 minutes, 10 minutes break. And then after that, I will tell you that thing. But you have to come back, okay? 10 minutes break. Short break. Right now the time is how much? 2:36. So 2:40 a.m. to 2:50 a.m. Okay. So we with full of energy, but come back. Promise? It's a promise. Yeah. You can charge your mobile. Yes, I can understand. I can understand. Sure. It's Baba is back. Baba is on time or in time. Now let's see how many of you are back. Can you hear me? Can you see me, kids? Once again, welcome back again to your Unacademy NEET English channel. Oh, 3 minutes still left. 3 minutes still left. So I'm before time. In time means. Okay, let me wait then. So I think are you there, kids? Is everyone back? So trio and erythrio. We were about to deal with trio and erythrio, the last form, trio and erythrio. This configuration, trio and erythrio, right? Just see, one side I will write trio, another side I'm going to write erythrio. And right now I'm a painter. Just consider me like painter. Trio. Erythrio. Now let's if I draw trio, I will write like this, that bromine, bromine, hydrogen, hydrogen, CH3, CH3. Just try to understand what I am going to tell you, kids. Bromine, bromine, H, H, CH3, CH3. Now, these are the same atoms on same side. They are the same atoms on different side. But let me try to tell you in different way that this, and here is one line, and here is one line, here is one line, this, this. Just try to see. Trio T, same atoms are moving different side. Erythrio E, same atoms are on same side. Can you see, kids, any resemblance? If same atoms on same side, see three lines same side, the name itself indicating which one is trio, which one is erythrio, and these are the chiral carbons. Can you see the magic? Can you feel the magic? Can you understand the magic? Everyone, do let me know. Can you see the magic? Can you understand it? Now, if trio erythrio is clear to all of you, then two more things I will tell you in this your optical isomerism, and after that definitely we will decide whether to go for conformational isomerism. If energy is there, if you are having energy, we will go for conformational isomerism. Otherwise, we will end this session. Okay, so see, trio and erythrio. This is trio when same atoms are on different side on chiral carbon. and this is right through when same atoms are on same side. If this is clear to all of you, show me the thumbs up. And I was a bit early, so energy is there. Oh, that's really awesome. Salute, salute. Now let me tell you optical isomerism, but yeah, before that, calculation of total number of configurational isomers. This is really very, very important. Calculation of total number of, this question is very, very important. Calculation of total number of configurational isomers. What do you mean by this? That means GI plus OI. Now, how to do this? For example, if you see, if anyone has given you compound like this, CH3, CH, double bond CH, CH, Cl, CH, Br, CH3. Now see, my dear students, if you see with respect of GI, this is active for GI, and there are two chiral carbons for OI. Now the value of N is 3. Remember that the value of N is 3. How? The value of N is 3, 1 for GI and 2 for OI. So combined together they will become 3, and we will write down total configuration isomers are 2 power 3, that is being 8. But formula gives the speed, but formula is not going to teach you anything. How many of you want to visualize it? And thank you kids, everyone is back. That's really awesome. That is indicating that you people are really real genuine people. So how many of you want to visualize it? Let me make visualization. See, if I write down the same compound CH3, CH, double bond CH, CHCl, CHBr and CH3. So see, if this is double bond, then two possibilities are there. This will be cis and this will be trans. When this is cis, this is chiral carbon, this is chiral carbon. When this is being cis, then they can be DD, LL, DL, LD. And when this is trans, they can be DD, LL, DL, LD. Now see how many are there. In trans they are 4, in cis they are 4. So 4 and 4 combined together, they are being 8. Got it? This is the visualization. That was the formula, and here is being the visualization. And visualization is always better than formula, and both together if you go, then that is the best. You got it kids? Oh kids, you are all fantastic kids. Now see, what I was going to tell you, that optical isomerism in alkenes. Optical isomerism in alkenes. Optical isomerism in alkenes. Now kids, if anyone is going to ask you that chiral carbon is necessary for a compound to be optically active or it's not necessary. Before this, if I ask you one question, chiral carbon is necessary or not necessary for a compound to be optically active? Chiral carbon is necessary or not necessary for a compound to be optically active, for a compound to be optically active, do let me know, kids. Yes or no? I want to see. I want to see. Not necessary. Very good, Samria. Fantastic. Answer is not necessary. Very good. Not necessary. Compound must be asymmetric. That is the necessary condition. Compound must be asymmetric. This is must condition, right? Now, my dear friends, compound can be optically active with or without chiral carbon. That is the most important thing. Remember that compound can be optically active with or without chiral carbon. Compound can be optically active. Very, very important point I am going to tell you. Compound can be optically active with or without chiral carbon. With or without chiral carbon. So right now I'm going to tell you two examples which are exactly based on this theme only, that they are not having chiral carbon, but still these compounds are optically active. The two types of compounds I'm going to tell you, they are not having any chiral carbon. So this compound, optical isomerism aniline compound, chiral compound without having chiral carbon, chiral compound without having chiral carbon. Compound is chiral. Compound is not having any chiral carbon. So for this, two things are required. Each sp2 hybridized carbon must be attached with different atoms or groups. And second point required is number of pi bonds must be even. Now kids, if you have studied the GI, in GI I have told you to show GI number of pi bonds must be odd. God, do you remember God? But here number of pi bonds must be even. Now why? Just see to it. If I write compound like this, so 2 pi bonds are there, and this will be optically active because it is not having no chiral carbon. No plane of symmetry, and it is optically active. Now you must be saying, sir, how? Let us visualize it. How is it not having any plane of symmetry? See kids, let me make it visualize. Just see, this is carbon, one valency is coming towards your side. let's say hydrogen, one valency going away from you, let's say CH3, double bonded carbon, and let's see that if this is lying horizontally on plane, so its pi bond will be vertically, vertical pi bond will be there, vertical pi bond, then this will be vertical, 100% they will be vertical, perpendicular. And if this is vertical, the another pi bond will be horizontal, like this, horizontal pi bond. And if this is horizontal, kids, the sigma bond will be vertical. Sigma bonds will go vertical, they will lie like this. So suppose CH3 at this place, CH3 over here, and hydrogen at this place. Now if you try to cut it, just see, if you try to cut it, the hydrogen, half of the spherical hydrogen will come toward this side and half will go that side of the board. If you come over here, one hydrogen is coming towards your side, one hydrogen is going outside the board, and one hydrogen is in the board, means just in the board. So half hydrogen will come toward this side, half hydrogen will go that side, one hydrogen is coming towards your side, one hydrogen is going away from you, plane of symmetry. But if you reach over there, this methyl is on right hand side, hydrogen is on this side, no plane of symmetry. Now if you want to cut it like this, so this will be half above, half below. But if you go over there, the upside hydrogen, below side methyl, no plane of symmetry, no pause. So compound is optically active. How many of you are able to understand? If number of pi bonds are even, then it will show optical activity. If odd, then it will show GI. Is it clear to all of you? Now the last point in this optical isomerism, just see to it. Last point. This is very, very important for the examination point of view. Biphenyls, ortho-substituted biphenyls are optically active. Ortho-substituted biphenyls. Biphenyls. Let's see. Any group or bigger atom like bromine, iodine, if placed at ortho position, just see. If I say, if the ring is given like this, and this question has been asked number of times in the J examination or NEET examination, AIMS examination, everywhere this question has been asked. If I say there is NO2, there is COH, there is COH, there is NO2. This compound is not having any chiral carbon, no chiral carbon, no chiral carbon. No plane of symmetry, no center of symmetry, and that's why compound is optically active. Now kids, everyone must be in need of how to understand it, how to visualize it. How many of you want to visualize it? I know that it's time has gone. It's how much? It's 3:06. But I salute to your dedication, your hard work, and I can understand that everyone you must be in need of how to visualize it. Just to let me know. Let me make it clear. If I say I'm having two rings like this, two phenyl rings like this, then definitely there is plane of symmetry. You can divide it from here. This is plane of symmetry, vertical plane of symmetry. I would like to say vertical plane of symmetry is there. Or you can do sandwich cut. Sandwich cut plane of symmetry is there. You can cut it like this. Two phenyls, they are in the same plane. Two phenyls are in the same plane. Two phenyls are in same plane. Now, my dear students, if I say that if I have added, if I add NO2 and COH somewhere else, then NO2 and COH, they are not going to put any effect. Suppose I have added NO2, sp2 hybridized planar, COH, sp2 hybridized, NO2 or COH over here. Still the plane of symmetry is there. It's not optically active. There is plane of symmetry. Plane of symmetry is there, not optically active. Now, my dear students, why at ortho they become optically active? What actually happens at ortho position? That is the question, $1,000,000 question. What actually happens at ortho position so that they become optically active? Let's see. If I make this ring another ring, when you put something over here, the space is very less. So if space is very less, this ring will be horizontal. This ring will remain horizontal. Let's suppose this is horizontal, then that ring will become vertical. Vertical means if I place here NO2 and COH, just see to it. These two rings were like this. Two rings were like this. But if I place four bigger atoms or groups and this in between this, so one ring will move like this. Can you see? One ring will move like this. And its atoms, the atoms were present like this. This is the ring. Suppose three fingers, this is the ring. And these are the atoms. And the atoms of one ring will go like this. Above the plane, below the plane, just to avoid the steric hindrance. So the plane of one ring will get changed. One will be vertical. Its NO2 will go up or NO2 will go down like this. So one is remaining horizontal, another one is remaining vertical. Now you can't have plane of symmetry. See, if they were like this, you could have gone like this. You must have got plane of symmetry. But if one ring is like this, and if you're cutting like this, then this side upside NO2 and downside COH, or if you're going to cut like this, this will be having plane of symmetry. But when you reach over here, you will get NO2 and COH opposite side. Are you getting my point? No plane of symmetry. You can't get plane of symmetry because the rings are in different plane. If this ring is being like this, if this ring is like this, having horizontal is having horizontal plane, then no, it's not correct. This is horizontal, then the another ring is vertical. This ring is being vertical. See, this ring is vertical. It's like this. The two rings are in different plane. Can you get it, kids? This is being vertical. This is being vertical. Two rings are in different plane. So kid, this is all about optical isomerism. Now it's your call. It's your call. Should I tell you conformational isomerism or not? I have energy, but you do let me know. If you're ready for conformational isomerism, I will let you know. And if you say no, sir, we don't have that energy, then I will leave. I will tell you some other day. It's your call. Do let me know, kids. If you want conformational isomerism, it will take just half an hour, not more than that. 20 to 30 minutes. 20 to 30. So if you're ready, then show me some fire in the chat section. Yes, I want to see some fire in the chat section if you're ready for that. Okay, my dear friend, that's really awesome that everyone is ready. That's hip hip hooray, hip hip hooray, hip hip hooray. So let's start conformational isomerism. So I got a green signal from you kids. So let's start. Let's start. So conformational isomerism. Suswagatam to conformational isomerism. Suswagatam. Conformational isomerism. My dear students, to show conformational isomerism, at least 3 regular sigma bonds should be there. What is required, kids? Thank you, kids. At least 3 regular sigma bonds. Required condition is to show conformational isomerism. Three regular sigma bonds. At least 3 regular sigma bonds. See kids how and why. See, let's see to it. A, B, C, D. These are 3 regular sigma bonds. 1, 2, 3, like this. In this way, you can do any question and you can understand what the thing is required, what we want to say. Let's just see to it. Question will come, which of the following compound will show, conformational isomerism? The options are like this. Option A, H2O. Option B, methane. Option C, ethane. Now do let me know, according to you, which out of these A, B, C, D will show. So answer definitely, in water, there are only 2 sigma bonds. So answer is no. In CH4, there are 4 sigma bonds, but they are not regular. Regular are just how many? 1 and 2 are regular. So no. In ethane, yes, you can see number of sigma bonds are there, and regular are how many? 1, 2, 3. So it will show this is your answer. And that's why in your NCERT, when you see your NCERT, the conformational isomerism starts with ethane. Never it has given about methane. Methane will not show. Now if I say H2O2, then answer is yes. H2O2 will show. Why? Because structure is HOOH. So how many regular sigma bonds are there? 1, 2, 3 regular sigma bonds are there. You can see clearly. So this is D option also. Now, let's see what is actually conformational isomerism and what happens in conformational isomerism. Let's see. Conformational isomerism in ethane. Ethane shows infinite conformers. Ethane shows infinite conformers. Let's see. One scientist was there. His name is Sawhorse. See what's the name? Sawhorse. Sawhorse. He has seen ethane like this in this form. Just see. Let me make Y. No, it's not good. Let me make it clear. V. Now I will make V. Here, V. Now he has added hydrogen. Just try to understand. Hydrogen, hydrogen, hydrogen. And just at the back of this hydrogen, there is one hydrogen, one hydrogen, one hydrogen. You can say they are just adjacent to each other. If you see, let me show you. First, let me make, then I will tell you. So this is V and this is inverted V. And what is happening, I will let you know. The scientist Sawhorse was watching these compounds from the the side view. This is the side view. And you just see that in between these two hydrogen, that is hydrogen. That hydrogen, this hydrogen is in between these two hydrogen. So this is known as eclipsed form. Eclipsed form. And that is known as staggered form, means They are away from each other. What do you think? Which one is going to be more stable? Out of these two, eclipsed and staggered, which is going to be more stable? So definitely staggered form is more stable and eclipsed form is not stable. That is more stable. Why that is more stable, kids? Why this is being more stable, kids? Because of two reasons. Are you ready to understand those two reasons? Have you ever seen that two actors which are sitting at the back of car? Never. Two problems are there. One is jealous factor. That means their psychology, mental level, they are not adjustable. And another, if they are collided with the body, they will say, oh, you hitted me. Now, kids, in this form, atom is nearest to atom, and atom-atom repulsion is known as, let me write down another page. Let me write down on another page. Atom-atom repulsion is known as van der Waals repulsion. Atom-atom repulsion is known as van der Waals repulsion. And their electrons, they are nearest. This I'm talking about atom-atom. Now, electronic repulsion, that bonded electrons repulsion, bonded electronic repulsion is known as torsional strain, is known as torsional strain. So, my dear students, if I talk about eclipsed, in eclipsed form, van der Waals strain is maximum and torsional strain is also maximum. So this is least stable form. Now if I talk about your staggered form, van der Waals strain is minimum, torsional strain is also minimum. This is most stable form, least stable, most stable. And in between these two, there is one form known as gauche. Gauche, that is also known as skew. Gauche or skew. So the stability order is like this. In this way, the stability is getting increased. Now, kids, I know that in this form you're not able to understand too much. So I'm going to give you another view that is known as Newman's projection formula. Just see how Newman has seen the compounds. Newman, see what's the name? Newman's projection formula. What type of scientists they are? Newman's projection formula. He said this was ethane. This was the ethane. You must have seen this was the ethane, right? Eclipsed form. So what Newman said, let's consider this to be the front carbon, that is the back carbon, front, back. So what he said, let me draw front carbon with this small circle. Let me write down here. Small circle is front carbon. and big circle is back carbon. B for big, B for back. Can you remember? B for big and B for back. So this is front carbon and it is having how many hydrogens? It is having 3 hydrogens like this. 1, 2, 3. Actually, Newman has seen the compound from the front. Newman has seen the compound from the front, that he has taken this carbon and brought nearer to you. So his eye was here. Eye was here from the front approach. Now this is the front carbon and the back carbon he has drawn with the big circle. This is the back carbon. Now back carbon is also having hydrogen, but those hydrogens should not be visible because they are eclipsed. But he has shown like this. Just see, otherwise you won't be able to understand. But they are just colliding. Are you getting my point? So see, the gap, the angle is 0 here. This angle between bonded electrons, let me write down, angle between bonded electrons is known as angle between bonded electrons is known as dihedral angle. Dihedral angle. Or torsional angle. These points are very, very important. Angle between bonded electrons is known as dihedral angle or torsional angle. So see here, the dihedral angle is 0. Angle is 0. 0. So electrons are too much close. So torsional strain is maximum. Van der Waals strain is maximum. So one will remain fixed, another will rotate. So let's keep yellow one fixed. Yellow one fixed. Although all are rotating, but let's take for simplicity yellow one fixed, and let me rotate the white one. So it will come over here, it will come over here, it will come over here. This is the form where all hydrogen to hydrogen are at maximum angle and all the electrons, bonded electrons, they are at maximum distance. So this is most stable. See, here the bond angle is how much? 60 degree. That means from 0 degree we have rotated to 60 degree to get more stable, and this is staggered form. This is known as staggered form. You got it, kids? Here staggered form, van der Waals strain is minimum, torsional strain is minimum, and if you keep on rotating like 0 degree, 1 degree, 2 degree, fractions degree, 3 degree, 5 degree, 70 degree, no, not 70 degrees, 60, 30 degree, like that, all they will be known as skew. So their stability is in between these two. This is least stable, most stable, and all these stabilities are known as skew. So this is clear to all of you. To get most stable from least stable, you have to rotate it through 60 degree or 120 degree. Are you getting my point? In the multiple of this, 60, 120, 180, like that. Everyone, ethane's conformation is clear to all of you? Oh, thank you. Oh my God. Yes, I have forgotten. This point is clear, kids. Is this point clear? Clear to all of you, this point, ethane, because maximum thing in our NCERT class 11th is given about ethane, but yes, butane is there, and then I will let you know hydrogen bonding, and then it will get completed. Then it will get completed, kids. Now, conformational isomerism in butane. Conformational isomerism in butane. Just see, butane is like this. So in the middle, let's say this is front carbon and that is back carbon, okay? Second carbon and third carbon. 1, IUPAC 2, 3, 4, C2, C3. So this is front carbon. If I suppose the second carbon is front carbon, then who is attached on front carbon? Just see. 2 hydrogens and 1 methyl. Just see. 2 hydrogens and 1 methyl, right? Let me draw back carbon with yellow. Then I will make circle, and who is attached? 2 hydrogens. Now if I keep hydrogen just back of hydrogen, hydrogen just back of hydrogen, and methyl at just back of methyl, then what will you say? This is fully eclipsed, least stable form, fully eclipsed, right? Least stable form. Why it is being least stable, kids? Because van der Waals strain is maximum, torsional strain is also maximum. Am I right, kids? Am I right? Now, what the compound will do for its stability? It is having freedom to get rotated. So let's keep the blue one fixed and rotate other by 60 degree. Let's make, although all are rotating, no one is fixed, but otherwise if we are rotating all together, we won't be able to understand. No one can understand. So let me make one fix, the blue one fix, and rotate by 60 degree. And if I am rotating the yellow one by 60 degree, just see what I am going to get. So this one is fixed, hydrogen here, methyl over here, and rotate by 60 degree clockwise. So yellow one will come over here, just see. Do let me know, am I right or not? This yellow one will come over here, this yellow one will come over here, and this methyl will come over here. Just see. This will be the situation after rotation. So they are far away, but methyl and methyl close. So this is staggered form. This is being staggered form. More stable than that. Let me give number. This is being first. This is being second. Once again rotate by 60 degree. Once again rotate by 60 degree in the clockwise direction only, in between C2, C3, keeping blue one fix, rotating yellow one, what I will get, kids? If I rotate this methyl will come over here. This hydrogen will go over there, and this hydrogen will come over here. It is not fully eclipsed, but we will say eclipsed, because hydrogen and methyl, they cannot collide, or they cannot cover each other completely. So I would like to say this is third one, and this is eclipsed, not fully eclipsed, but this is eclipsed. Now once again rotate by 60 degree. Now let's see on another page. This methyl will come opposite to this methyl, my dear student. Just see, fantastic condition will be there. Just see to it. By rotating 60 degree, this hydrogen is over here, this hydrogen over here, this methyl at this position. Now see, just see to it. This methyl will come away from that methyl. This hydrogen is away from that hydrogen, and this, they are far away from each other. That's why this is known as anti-staggered. Anti-staggered. Why anti? This methyl and that methyl, they are opposite, means they have gone far away from each other. So this is being anti-staggered, most stable form. Anti-staggered maximum stable. So let me give fourth number to this. Now once again rotate it by 60 degree. Rotating it through by 60 degree. Let's keep blue one fixed so that we can understand it. Hydrogen, methyl. So this will come over here, just at this position. Hydrogen will come over there, hydrogen will come over here. This is not fully eclipsed, but this is fifth one. We will say it is eclipsed. Now once again, kids, rotate by 60 degree. Once again rotated by 60 degree. How many times we have rotated? Let's see, let's make it one circle 360 degree. So let me say that once again, hydrogen over here, methyl at this position, and so 60 degree, methyl will come over here, hydrogen at this place, hydrogen at this place. This is your sixth one. And once again, if you rotate by 60 degree, we will reach to the initial position only. So these are the main conformers, kids. While doing this, we have got number of structures. Who was the most stable one? So you see, the most stable one is fourth. After fourth, so the examiner will ask, after fourth, who is being stable? Sixth, and like sixth, who is there? Like sixth, the second one, right? Second and sixth, just see, this is staggered, and this is also staggered. Second and sixth are equally stable. After this, we can say partially eclipsed. This is being partially eclipsed. Like fifth, there was one more partially eclipsed. Who was partially eclipsed? This is eclipsed partially. So third and fifth, and last, it is the first one. Everyone, just do let me know, are you able to understand it? This is the stability order of the conformers. Got it, kids? Everyone got it? Do let me know. Everyone got it, kids? Now only 10 minutes. 10 minutes more. It's over. 10 minutes more, kids. Just 10 minutes. Now see, you have seen all the time staggered form is getting more stable than eclipsed form. There is one case, in case of hydrogen bonding, intramolecular hydrogen bonding. Remember that in case of intramolecular hydrogen bonding, Gauche form is more stable than Gauche is more stable than staggered form. How to find out intramolecular hydrogen bonding? Whenever there is X and on adjacent there is Y, and in between X and Y, if hydrogen bonding is possible, then who is going to form hydrogen bonding? How to understand? Remember that hydrogen attached with either fluorine or oxygen or nitrogen can do hydrogen bonding with phone call, that is FONCl. This is about hydrogen bonding. So if either of these things are there, definitely they can do hydrogen bonding. And if hydrogen bonding is there, let's see what is going to happen. The example which number of times has been asked in the various examination, I will deal with that example only, the live example. Okay, I will show you that example only, right? See, kids, that well-known example is ethylene glycol. So they have asked about this, which form will be more stable. So see kids, you can compare what I have told you. It is like this: carbon, carbon OH, carbon OH. So there are R. You can place here R like hydrogen, hydrogen ethylene glycol, and you can see clearly that this hydrogen is attached with oxygen, so it is having too much positive charge, and this is having negative. And in between these two, what is there? There is intramolecular hydrogen formation. Intramolecular hydrogen bond is there. So how you will get it in the form of conformational isomer in kits? How you will get it in the form of conformational isomer? Just see, you will get two forms like this. One hydrogen, hydrogen, two hydrogens, one OH. You will get OH. This is staggered form. People will think that staggered form is more stable. No, my dear friend, this is not more stable. And second form you will get like this: hydrogen, hydrogen, OH, OH, H, H. Now see, here there is chance of formation of what? Intramolecular hydrogen bonding. So this is Gauche more stable than staggered form. Got it, kids? It is like this. Now, my dear friends, after this, I know that you are tired, too much tired, but there is one thing, conformations of cycloalkanes. If you give me permission, only that is the rank deciding question that can be asked, and let me make it clear, and then it's over and out. I've completed whole isomerism, and only one thing is there, kids. My dear students, this is the time to awake, and the whole night has gone. You are still there, kids. Yeah, that's fantastic. Everyone is ready. That's really fantastic, kids. Wow, wow, kids. Really awesome. Really awesome. Now, let me tell you conformational isomerism in cycloalkanes. That is the last topic because that will be asked in rank deciding questions. So, not to ignore it. Oh my God. So, let's start. Conformational isomerism. Isomerism in cycloalkanes. Cyclopropane is planar. Cyclobutane is nearly planar. Cyclopentane is open envelope shaped like this, non-planar. And let me come to the cyclohexane. Cyclohexane have infinite conformers. Infinite conformers following four are most studied. Chair form, twist boat, boat, half chair. This is being the stability order, kids. Now chair form is being the most stable. So now I'm moving towards rank deciding. Rank deciding. Thank you. Oh my God, Nawab's World, you are still awake from Lucknow. Wow. Now see kids, once again the page is required. Now we are in the world of what? SRDQ, super rank deciding questions. So see, non-planar chair form. This is your chair form. How to draw it? Just draw two parallel lines and try to understand. Just draw two parallel lines. Just see like this. And these are four carbons. Can you see? And if I join it like this and another one like this is your chair. This is your chair form, my dear students. Now, if I place any alkyl group on this chair, but before that, let me tell you, this is one V. This is one V, and let me make another V like this. Then remember that this hydrogen is going up and this hydrogen is going down. So that hydrogen will be known as axial hydrogen, axial. And this hydrogen will be known as equatorial hydrogen. Now, how to find out? See, this vertex was, this aeroplane was going up, so its axial is going up. This is coming down, so its axial will go down. Are you able to understand? Axial will go down and equatorial will go up. Let me tell you once again. That vertex was, this aeroplane vertex was going up. So axial is going up. Then equatorial will be down. If this vertex is going down, so its axial is going down and equatorial will be up. Are you able to understand, everyone? Then with this, the rank deciding GI also will be there, and that will be rank deciding questions. But till now, are you able to understand? Do let me know. Now, if anyone is asking that define which is more stable, they have taken methyl cyclohexane. Methyl cyclohexane. So which form is more stable? If they are asking this question, so you won't be able to understand if you don't know the chair form. So let me draw the chair form. So I have drawn like this, drawn like this. This is the chair. Now if I place methyl at this position, so methyl is at axial position. Now let me draw methyl properly. This is tetrahedral carbon. Hydrogen will go like this. And if methyl is axial, then hydrogen is equatorial. That is also clear. This is being axial. This is being equatorial. Now this is going up. This is going down. This is going up. So its hydrogen will be going up. Its hydrogen will be going up. And its hydrogen will be going up. And these hydrogens will put repulsion over here. Repulsion. This is the repulsion, very, very important. This repulsion is in between with respect to 1, 2, 3. With respect to that, 1, 2, 3. This is also 1, 2, 3. There are 2, 1, 3. It means in between 1 and 3, 1 and 3. So there are 2, 1, 3 diaxial, because these are axial one. This is also axial. That is also up, means up. The axial will go 1, 3 diaxial repulsive forces. and due to one 3-diaxial repulsive forces, the energy increases by, energy repulsion is there, so energy will increase. Energy increases by 0.9 kilocalorie per mole. No need to remember the data. So 2 into 0.9 kilocalorie per mole. So its energy got increased by 1.8 kilocalorie per mole. Now if this methyl, if this is doing flipping, now just see flipping, what is doing flipping. Have you ever seen boat? When boat is like this, people are sitting on the boat, and once the boat is doing flipping, boat will go down, people will go inside the river. That is flipping. Like umbrella is like this. Whenever the air is too much blown up, umbrella will get flipping. So this is flipping, you can say, or umbrella inversion. You can use word flipping or umbrella inversion. Flipping. That is conformational isomerism. So once it is doing conformational isomerism, this hood will go down, this will go up. The chair you must have seen in your school. Once the chair is getting fallen down, then what is going to happen? Upside down, upside down. That will be, now see, this hood will go up, this hood will go up, and that hood will come down. Now the methyl, which was axial, will convert into equatorial. Now will convert into equatorial. Now it is being equatorial, and the hydrogen will convert into axial. Now there is no 1,3-diaxial repulsive forces because these hydrogens are away from there. There is no 1,3-diaxial repulsion. So which form is going to be more stable, kids? There is no 1,3-diaxial repulsion. So definitely this equatorial form is being more stable, and equilibrium will lie toward this side. Are you getting my point, kids? Everyone got it? This is rank deciding question. RDQ. RDQ. Whether I talk about NEET or I talk about IIT. Yes, what's your doubt? Do let me know what's your doubt, kids. Do let me know what's your doubt. Somebody is asking for the doubt. What's your doubt? Now, kids, see. This is very, very burning question, that if you are having 1,2-dimethyl, 1,2-dimethyl cyclohexane, who is going to be more stable? Now see, two methyls are there. Now when two methyls are there, it could be like this. See, that both the two methyls can be axial. Just see, it's really very, very good question. Axial. Axial. Now due to this axial 2 and this axial 2, there will be total 4 diaxial repulsive forces. That means its total energy will be 4 into 0.9 kilocalorie per mole. Now if you get converted due to flipping, if it is doing flipping, then both the axial will convert into equatorial, kids. Both the axial forms will convert into equatorial. This will come over here. This will come over here. No diaxial repulsion. Now the another one will be like this: one methyl axial, one methyl equatorial. One is being axial, another one is being equatorial. and once it is doing flipping, it will remain like this. So my dear student, those who are unable to understand, and if you want brainy Baba's trick, hats off all these students. Now kids, if you don't want to see this, and if you want a trick, see, E for elephant, remember E for elephant, and A for ant. Who is more stable, elephant or ant? So if there are two E, more stable, there is one E, then there are two A. This is the stability order, that's it. Elephant is more stable than ant. This is being the stability order, kids. Stability order. Now I've told you this much. Then if the question is going to come on GI, it will take 10 minutes. Then I can let you know even that thing also. Now 10 minutes more. This is HSP Baba's trick. Baba's trick. How is the trick, kids? How was the trick? Do let me know. Brainy Baba's trick. Now kids. Now to GI in this cycloalkane. If this is going to come, you will be the first one to answer it. Rest of others, they won't be able to do it. Everyone ready? Let's see their GI. GI of disubstituted cyclohexane. See kids. GI in chair form of cyclohexane. Just see kids. To understand it, we should know that this is the chair. How many carbons are going up? 1, 2, 3. They are going up. Are you able to understand this thing? This is going up. This is going up. This is going up. Till now, is it clear? How many are going down? This is going down. This is going down. This is going down. This much is clear to all of you. Is this much clear to all of you, my dear friends? Just to understand it, we should know whatever I'm telling you. Now, if you place methyl over here, that means this is up, then axial is up. This is also going up. And if you place methyl over here, this is going down, that means this is also going down. Now see kids, this is axial. Their hydrogen, its hydrogen is going down, its hydrogen is going up. Now what do you call it? One methyl going up, this methyl is going up, and this methyl is going down. They are on same side, different side. Up, one methyl is up, one methyl is down. So two methyls are on opposite side. That means they are trans. That means this is trans. You got it, kids? This is transform. How many of you got it? How many of you got it that this is being trans? Now let me give you another one. Let me give you another one so that you can understand. See, if I draw it like this, so if I place it like this, just do let me know. Is this cis or trans? If you're able to understand, kids. If you're able to understand it, Do let me know, is this cis or trans? Do let me know, is this cis or trans? I'm waiting for your answer. I'm waiting for your answer, kid. Cis or trans? Is this cis or trans? Cis. Very good. Fantastic, kids. Fantastic. Now see, this axial, this is going up. That means axial is going up. This axial is going up. So methyl is going down. Now this is going down. That means its axis, axial is going down. If this is going down, this is going up. Oh my God. That is down. This is up. This is not cis. This is trans. They are on opposite side. Hey, this is trans. You got it? Should I give you one more? It is trans. Should I give you one more? Okay, let me give you one more. Just see to it. Do let me know. Cis or trans? Is this cis or trans? Everyone do let me know. Is this cis or trans? Cis. Let me check it out. This is going up. So its axial is going up. This is going down. So its axial is going down. So equatorial is going up. So this methyl is up. That is also up. Cis. Now you are able to understand it. Fantastic, kids. Now this is over and out. Only one thing is left. That is physical and chemical properties of diisomers and enantiomers. Is everyone ready, kids? Is everyone ready? And diisomers. But in optical isomerism, how to find out which is being diisomer? That is also one point we missed, because in GI we have studied all GI are diisomers. All GI are being diisomer, but in stereoisomerism we have not studied what are diisomers. So two things I have to tell you. See, if I draw, the heading is, let me write down the heading, difference in between enantiomers and diisomers. Now these are three structures, kids: X, Y, and Z. X, Y, and Z. So if anyone is asking what is the relation in between X and Y, what will you say? What is the relation in between X and Y, my dear friends? What is the relation in between X and Y? Thank you, Nawab's World. Thank you. What is the relation in between X and Y? Fast, fast, kids, fast. What is the relation in between X and Y? Mirror images. So the relation is enantiomers. They are being enantiomers. Now the question is relation in between X and Z. X and Z. Yes, kids. X and Z. What do you think? What is the relation between X and Z? Fast, fast, kids. Fast. X and Z. They are stereoisomers, but not mirror images. We will say they are distereomers. Distereomers. Now, kids, after this, I am going to give you a brilliant question that will look like easy. You will get failed. Are you ready for that? Is everyone ready for that? Just see to it. Find out relation in between yes, A and B are. Do let me know. A and B are. Let me check it out. What answer you are going to give? Do let me know, kids. Everyone, do let me know. Enantiomer. One answer I have got, enantiomer. Just see, kids. Number one, should I give 1 to this? 1 to this, according to CIP rule. 2 to this. Arrow is moving clockwise. Hydrogen is over here. So R configuration. In this, number 1 to this, number 2 to this, it is moving anti-clockwise. And it is over there, S configuration. So definitely they are enantiomer. One is R, one is S. So they are enantiomer. Absolutely correct. Absolutely correct. Till now, everyone is able to understand. Till now, is it clear to each and everyone? Now, only one thing is left. I'm going to tell you the physical properties of enantiomer and diastereomer. Are you feeling sleepy? Then we can leave. And if you're not feeling sleepy, show me the fire in the chat section. Then I will let you know, my dear friends. The physical properties very, very important. They can be asked. Number of times they have asked such type of things. So show me fire in the chat section. Yes, if you're ready, Let me have a glass of water. If you're ready, show me the fire in the chat section, kids. Fantastic, fantastic. Now see, physical properties of diisomers. Now see, they have different physical properties. Why? They have different physical properties. Do let me know why. Because they are not mirror images. They are never mirror images. So their melting point, boiling point will be different. They have different melting point and boiling point. But what will you say about the chemical properties? They have different physical properties. What will you say about the chemical property? But before this, these properties, we will say yes, they have different crystal lattice packing. That's why their physical properties are different. Their dipole moment will be different, so their boiling point will be different, their solubility will be different. But what will you say about their chemical properties? Because they have same functional groups. So chemical property, this physical property we have written, yeah, definitely they have different crystal lattice, so their physical properties of diastomer, they have different physical properties. But chemical properties, see kids, chemical properties of diastomers. Diastomers have same chemical property, but not identical. What is this? But not identical. What do you mean by this, kids? But not identical. This is very, very important. This means the rate of reaction is different. The rate of reaction is different. So what do you mean by this rate of reaction is different? In this, very well-known example is there, malic acid and fumaric acid. Very, very important. Malic acid and fumaric acid case. Kids, could you please let me know who is being more acidic? Whether malic acid is more acidic or fumaric acid? Anyone? I'm asking this question to you. Whether malic acid is being more acidic or fumaric acid, who is going to answer it? Fumaric. Let's see whether fumaric is more acidic or malic is more acidic. Kids, I will go with malic acid. You are going with fumaric. Let's see. Let's understand. Malic acid will look like this. C double bond C, COOH, COOH. This is the cis form. And fumaric acid will look like this. C double bond C, H, COOH, H, COOH. Now see, if this is going to release its proton, it will look like this. C double bond C, H, H, C double bond O, O negative, and C double bond O, OH. Now in between this hydrogen and this oxygen, there will be chelate formation. How many membered ring is getting formed? This ring is of C 1, 2, 3, 4, 5, 6, 7. Then it's okay. Chelation is there. Extra stabilization is there. Now, if this is going to release its proton, it will look like this. Now, kids, this COH is on this side and that oxygen on that side cannot form intramolecular hydrogen bonding. And this hydrogen is attached with carbon, can't do hydrogen bonding. No intramolecular hydrogen bonding. I think you are not able to understand. The hydrogen attached to carbon cannot do intramolecular hydrogen bonding. Yeah, hydrogen is attached to triple bonded carbon, because triple bonded carbon's electronegativity is 3.25. That can do, but this cannot do. No intramolecular hydrogen. Which conjugate base is more stable? That is acid. This is being conjugate base. That is acid. This is being conjugate base. Which conjugate base is more stable, kids? Definitely this conjugate base is more stable. So this is more acidic. It will easily lose its proton. So I will say Ka1, Ka of malic acid is more than Ka1 of malic acid is greater than Ka1 of fumaric acid. But my dear student, if by chance examiner is asking whose Ka2 is greater, whose Ka2 is greater, malic acid or fumaric acid? Ka2. Whose Ka2 is greater, kids? If examiner is asking like that. Do let me know, kids. Now Ka2 of fumaric acid will be more. Let me show you why. This is malic acid. This is being malic acid like this. I've told you C double bond O, O negative, and there was what? COOH, C double bond O, OH, and it got stabilized by hydrogen bonding like this. And this was fumaric acid, kids, like this. C double bond O, O negative. There was H, H, C double bond O, OH. Now once anyone is saying, hey, just give me your proton, this proton will say, no, I'm so involved in this bonding, I don't want to go because I am stabilized. But this proton will say, oh, let me go. So can easily eliminate out. Are you getting my point? Not involved in any bonding. Not involved in chelation. So can easily leave. This is being involved in chelation. Can't easily leave. So Ka2 of fumaric acid is more than Ka2 of malic acid. Now, I hope this much is clear to all of you. Exactly clear, kids. Exactly. Is this much clear to each and everyone, my dear student? Do let me know. Is this point is clear exactly to everyone? Now, let's see about enantiomers. Only one line is there and then it's up. It's completed. Only one line about enantiomers properties and then it's up. Enantiomers have same physical properties because they are mirror images of each other, have same physical properties. Same chemical properties. No, one physical property is different. Just think about which physical property is different. One physical property is different. Except their action on plane polarized light. So, second point is that they have same chemical properties. Their biological properties are different. Note, they have different biological properties. And my dear students, they have same physical properties like melting point, boiling point. They are same. And that's why if anyone is going to ask, can you separate enantiomers by fractional distillation? Can you separate enantiomers by fractional distillation? Answer is no. That's why enantiomers can't be separated by fractional distillation. Whereas diisomers you can separate by fractional distillation because they have different melting point and boiling points. Diisomer can be separated, but these can't be separated. Now, the last point. Kids, you must be thinking, last point, last point. How many last points are there? One thing, that racemization was left. Racemization. and that is really going to play a very, very important role in SN1 and SN2. Now kids, I know that your batteries must got discharged, even you must have got discharged, but if you're ready, if you can spend 10 to 12 minutes more, then let me complete that racemization. Now do let me know kids. I'm so full of energy. Baba is with full on energy. But you kids do let me know that are you having energy to give me 10 to 12 minutes? Okay, okay. That's really fantastic. So racemization. What is racemization? Just see. Suppose you are having lactic acid, and first point, if you are having one solution, it is having 50% dextrolactic acid and 50% levolactic acid. And if you have passed plain polarized light through this plain polarized light, what will happen? Do let me know. This will move through this solution. 50% of dextrolactic acid or dextro isomer will rotate the light clockwise direction, and rest of the 50% will rotate the light anti-clockwise direction. As a whole, light will come out in which direction? Definitely it will come out as it has gone inside. Same appearance will be there without rotation. But you know that inside the solution, light has been rotated. This compound has rotated the plane polarized light in clockwise direction, and this compound has rotated in anti-clockwise direction with the same magnitude, and that's why light is without any rotation, and the mixture will be known as optically inactive. And now this mixture optically inactive is due to external compensation. Kids, this is very, very important. Due to external compensation, Now, meso compound was optically inactive due to internal compensation that was within the molecule, and this thing is in between two molecules. This thing is compensation in between two different molecules. Compensation in between molecules. Compensation in between molecules. Got it? Now, last point. Just 3 minutes more. 3 minutes more, and that's it. So this is complete racemization. I would like to say this is complete racemization, and now partial racemization. Just see, that's it. Then after that, partial Racemization. Just see. If I say kids, I'm having a mixture of, suppose, 70% dextrolactic acid and 30% levolactic acid. And if the light is passed through the solution, plain polarized light is moving through this solution, unidirectional light, then who will rotate more? This will rotate more and this will rotate less. So 30 will neutralize 30. Still the light will be reflected towards clockwise direction because the amount of dextro is more. So 30 has neutralized 30. That means partial Racemization has taken place. Partial Racemization mixture will be still optically active. Due to enantiomeric axis. This is known as due to enantiomeric axis. Due to enantiomeric axis. This word is very, very important. Due to enantiomeric axis. This enantiomer is an axis, and due to this enantiomeric axis, this is an axis. Kids, over and out. Everyone is able to understand. Do let me know. I've completed each and everything. Now, any doubt? Yeah, one question. Oh my God, such a brilliant question. See, kids, let's see how much time you are going to take. One question, fantastic question. This is very good question of aims. Very, very good question. Find out the relationship in between your time starts now. Let's see how much time you are going to take and how accurate answer you are going to tell me. I'm waiting for your answer. Oh my God, Jesse. Right, 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 Jesse. How you have done it? Give me the explanation. How you have done it? Your answer is absolutely correct, Jesse. How you have done it, do let me know first of all. They are identical, absolutely correct. But do let me know how you have done it, Jesse. Identical, how you have done it. So rotation is done by 180 degree. Rotation is done by 180 degree in the plane of paper. Okay, so they are identical, they are homomers. Now the second question, everyone, you got it. Now if you are not doing it by rotation, if you're doing it by RS system, if you're doing it by RS system, kids, do let me know what is the configuration of this carbon, R or S, this red carbon. Do let me know what is the configuration of this red carbon. Configuration of red carbon. Do let me know, kids. Those who don't know how to rotate by 180 degree, do let me know what is the configuration of red carbon. Let me check it out. How many of you are able to do it? What is the configuration of red carbon, R or S? Let me check it out. R or S, kids? R. Darshani is saying R. Let me check it out what others are writing. R or S? Yes, kids. Others, I'm waiting for your answer. Everyone is going for R. Okay, let's see. Number 1 should be given to chlorine. This carbon is saying I am being carbon. This carbon is also saying I am carbon. Who is your highest oxygen? Who is your highest bromine? So bromine is winner. After 1, 2, arrow is moving clockwise, and this is over here. LPG is on horizontal line. So this is S configuration. Everyone got failed. S configuration. You must have given 2 to this. You have not seen BR. Everyone got failed. Everyone got failed. Failed or not? Do let me know you got failed or not, kids. Everyone got failed, kids. See, that is the thing. After one, you see this is carbon, this is carbon. Its senior most is oxygen, atomic number 8. Its senior most is bromine. So this carbon will get number 2. Clear to all of you? You got failed. Now another question. Just see. Once again you will get failed. See this compound. This is A, B, C. A and B, A and C, B and C. Yes, three questions are there. Do let me know, kids. There are three questions. Tell me the answer of first question, then second question, then third question. Good morning, good morning, good morning. What answer you are writing? Enantiomer. Okay, this is correct. Absolutely correct. Enantiomers. Second one. Second one. Second one. Enantiomer. Identical. Somebody is writing ANC identical. Someone is writing enantiomer. Do it, kids, do it. Now see how many of you are feeling difficulty in solving this type of question. How many of you feeling? How many of you feeling difficulty? Always do this question like this. See, either by rotation or you can see 1, 2, arrow is going clockwise. So this is over here S configuration. It is a mirror image, so it will be R, or you can see 1, 2, arrow is going, arrow is moving in which direction? Is moving anti-clockwise direction, and this is over here R. So R and S, what is the relation R and S? Enantiomers. Now you see over here, this is O, this is C, arrow is moving clockwise, but this is over here S configuration. So S, so see A and C, A is S, C is S, identical. Now B and C, this is R, that is S, enantiomer. Kids, you got it? Is it clear to all of you? Are your energy, your stability, each and everything is proper? Is everyone, are you getting confidence or not, kids? Do let me know. Are you feeling confident? Now the last question. If you are able to do this question, really your confidence is going to boost up. A and B. Relation in between A and B. Who is Darshini? You are right. Absolutely correct. Diastereomer. Now, second question is relation in between B and C. B and C. B and C. B and C. B and C identical. Just see, just check. B and C. What's your answer for B and C, kids? B and C. Enantiomer. B and C. B and C. B and C. What's your answer, kids? Now see, kids. Let me tell you. This chlorine is on right hand side. This bromine is on left hand side. But here chlorine and bromine, they are on same side. So definitely they are going to be diastereomers. They are not mirror images of each other. Now C and D. C and D. What is the relation between C and D, kids? What is the relation between C and D? Do let me know. C and D. I'm waiting for your answer, kids. C and D are. Do let me know. C and D, kids. C and D are, kids. Fast. C and D are. So C, kids. In C, two are same side, but in D, they are on opposite side. So what do you say? They are diastereomers. Now, if I ask you A and C, A and C, A and C are. Now see, in A, the chlorine and bromine are right hand side, and in C, chlorine and bromine are on right hand side. They are identical. Yes, they are identical, exactly identical. Got it. Now if I say what is the relationship between B and D, B and D, this too you can tell me, kids. Easy one, last one. B and D are. B and D are. This is so easy, kids. B and D are. Definitely B, chlorine here, chlorine there, bromine going that side away. So they are enantiomers. They are being enantiomers, isn't it, kids?